If you're working in the software industry or simply want to learn Playwright for your own projects, I will be there for you, every step along the way. It is a great time to learn. Hi everyone, and welcome back to the course. In this video, you will learn how to install Python and PyCharm in your device. PyCharm is the most widely used IDE for Python, and it supports Windows, macOS, and Linux. Since I have a Mac device, I will show you how you can install it in Mac, but the installation for any other operating system is pretty much the same. So let's get started. Firstly, you would need to go to python.org, downloads, and if you hit on the downloads button here, you can immediately select Python 3.10.5, which is the current Python version. However, with time this version might change as there are new Python releases, so please feel free to install the most recent Python version. So you can either install it from here, from the Downloads tab, or you can simply select Downloads and then you will see it right here. So once you select it from here, this will automatically detect your operating system and will download the right Python version for you. If, however, the detection is unsuccessful, you can definitely select Python for Windows, Linux, or macOS. So I'm going to select Download Python 3.10.5, and you can see that Python immediately gets downloaded into my device. Once you have that, you can select Python or the downloaded file, select Continue, Continue, then Continue again, agree with the software agreement, and then install it in the disk of your desire. So I'll select Continue here, and then here you will see the installation type, and you have the option to again change the installation location. I'm fine with mine, so I'll select Install, and then you will be asked to write your password. So I selected my username and password, and now the installation begins. So once the installation is complete, you will see this window here with Python installed in your applications if you use Mac, or the corresponding window if you use Windows or Linux. Then you will get a summary that Python has been installed in your device, and you can click Close here. And then let's move to Trash the installer. So once this is done, in order to verify that Python has been installed in your device, you can pull up the terminal, and then here you can simply write Python --version, and once this is done, you can see that you have installed Python 3.10.5, which is the last Python version, and this means that you have successfully installed Python. Now let's install PyCharm. It's important to make sure that you install PyCharm Community Edition, because the Community Edition is free to use and it has all the functionalities that you would need for this course and actually most of the Python related work. So here, for example, I will select Apple Silicon chip since this is the one on my device, and then the PyCharm community starts installing in my computer. To find the downloads, you can simply write in Google PyCharm community like this, and basically the first web page that appears on your screen will be the one with the community and professional versions. And you can again choose to download it for Windows, macOS, or Linux. So once PyCharm community is installed, actually downloaded in your device, then you can select it and then drag and drop it to your application folder, and then that should be all. So if I go to my applications, I would see PyCharm Community Edition installed, and so if I write here PyCharm, then PyCharm will launch into your device. Select Open here since these are security warnings, and then PyCharm, as you can see, is going to start. I will not open my current project, but here you can see all the projects that I actually already have in PyCharm. And once this window appears in front of you, which is going to be the first thing that you would see when you open PyCharm, is you can select a new project and basically start a new project in PyCharm. I will create one just to show you how it works. So let's select Create, and then here you can see your virtual environment and your project where you can create different Python files, right? Let's do file 1, and here is how you can create your own Python projects using PyCharm. So this was the end of this video. This is how you can install Python and PyCharm in your device. Thanks for watching, and I will see you in the next one. Hi guys! Since in the last video we already did the hard work to install Python and PyCharm, today we have the easy task to install Playwright and Pytest. So here the first thing we will do is to basically install those two packages, because these are Python packages, inside your device, and then when we start working on our PyCharm projects, I will also teach you how to create a virtual environment such as this one and install those packages there so you can have them locally as well, which will make your project way more reliable. So let's open a terminal, and this was the same terminal in which we already checked the Python version. So the first thing I will need to do is to install Pytest. So I just cleared the window, and now let's write type 3 install Pytest. Okay, and as you can see, the requirement is already satisfied since I already have installed Pytest. So you might see slightly different outputs from me, since for you the installation will start. Actually, let me uninstall it and install it again so you can see the exact output. You can do that by typing pipe3 uninstall Pytest, then confirm, and Pytest now has been uninstalled. So if I write now pipe3 install Pytest, now Pytest, you can see that it's successfully installed in my device. I even got a newer version. So once you have that, then you can begin installing Playwright, which is our main test tool for this course. So the first thing I will do is to do pipe3 install Pytest Playwright, and this should install the plugin, the Pytest plugin for Playwright. So let's do that, and you can see that we just installed the Pytest plugin for Playwright. Let's do clear. Okay, and now the next step is to install Playwright. So let's do Playwright install. So once this is done, let's actually try if Playwright works properly. So once this is done, let's actually test if we installed Playwright successfully. What you need to do is simply write Playwright in your terminal, and then you will see the different options that you can use with Playwright. The same you can do with Pytest. So let's first write Playwright version, and you can see the current version of Playwright that you have installed, and you can do the same with Pytest. So Pytest version, and you can see the version of Pytest that you have installed as well. So if you see those outputs, this means that you successfully installed Pytest and Playwright. Congratulations! Now you're able to continue with the rest of the course. Thanks for watching. Hi everyone, and welcome back to the course. Before jumping into the basics of Python, I actually wanted to talk first about one of the most important things when working with Python or any other programming language, and this is how to control the version. For example, if I write here Python version, you'll get a version of Python, and also every type of library that you install in your project also has a version. So in many cases, if you tried running a project that was using older Python or other library versions, this might not work in your computer. And for that reason, today I'm going to talk about the difference between the global and local Python environment and how you can control those in order for your project to always work. So let's open PyCharm, and I will explain you exactly what I mean. So before opening the PyCharm, actually, I want you to create a folder in which we're going to create all the projects that we'll be working on in this section. So I will just create here a new folder, and I will call it section 3, and inside this folder we will create all of our Python projects. So let's now talk about what is a global environment. A global environment, this is the Python version that is installed in your computer and all the libraries that are installed in your computer, but they are not local to the project. For example, if you write Python 3, actually let's write where Python 3, you will see where your Python interpreter is located. And this is the default version that every Python script will be using in order to execute. You can also write where Pytest, and you will see where the Pytest is installed. So this is installed in frameworks, Python frameworks, versions 3.10, and this is Pytest. So this is the default version that Pytest is going to be using. So let's say if you create a project on that version, but in the next version something changes, then your project will not be able to work with the new version. So let's create PyCharm project, and I will show you how you can control that. So let's write PyCharm. Okay, let's create a new project, and let's choose our section 3 folder. So I'll select desktop, section 3. Okay, let's add slash, and I will call this one calculator, which is actually going to be the name of our first project, which we will talk about in detail in the next video. But let's see what other things we have here. So in PyCharm, when you create a project, you have something called local environment, right? And this is right here. It is immediately created in your local directory. So when I create calculator, you have a folder called venv, which means a Python virtual environment. In this virtual environment, you will have the version of Python 3 that you saw there, but this will be local to your project. So your project will always use this virtual environment, and in that way, even though the global Python version changes, the project will use only the virtual environment. So it will use nothing else than this folder in order to execute. So even if I delete Python from my computer, this folder will still contain the Python version needed for the project to run. Okay, so let's create our project. Okay, so here on the left hand side, you can see our virtual environment, and you should take a real close look at the right bottom corner, because here will be the current Python interpreter or the Python version that we're using. So if I select that, you can see that we're using the virtual environment from the calculator project. So if I select interpreter settings, you can see all the packages that we currently have installed into our virtual environment. So for example, let's create a new file here. Let's create a new Python file and let's call it test1. And so for example, if I try to import here Pytest, this is not recognized. And the reason for that, even though we have it installed in our computer, this is still underlined in red. The reason for that is because it is not installed in this virtual environment right here, even though it is installed in our computer. So now if I want to install Pytest here, in PyCharm, it is enough to hover over Pytest and install the package. So let's do install anyway. Now you can see here in the bottom that the package gets installed. Let me write my credentials. And so the easiest way to install that is to simply hover over it and select install package. And you can see that now this gets installed and the red underlining under Pytest is completely removed. And this is the way that you can install everything you need in your local package, so you don't need to worry about what's installed in your device. And this is always going to be part of your project. Now, another cool thing about PyCharm is that if you select terminal, you're immediately into your virtual environment. So you can run your code from here and you have all the packages installed. Obviously, for the introductory videos for Python, we wouldn't need Pytest, but it is good to know how to install package and manage your virtual environment. So just to recap, the best practice is if you have a project with virtual environment set inside it. In PyCharm, you can use your virtual environment, which has the Python version and all the libraries that you desire to install. You can access it from here and you can see what you currently have. For example, in this project, I changed to Python 3.10, which is the last Python version. And if I would like to install any type of libraries, I can simply do pipe install. And let's say we would like to install Flask. Then Flask is going to get installed into your virtual environment as well. So if I close that and open it again, you can see that Flask now has been installed in my current virtual environment, but not in my device. And this is how, guys, we're going to be working throughout the course, so you can keep a very good control over your versions. Thanks for watching, guys, and I will see you in the next video. Hi everyone, and welcome back to the course. I named this video using Python as calculator just because there are so many people, especially beginners, that for them using a programming language is simply performing some basic calculations. Of course, a programming language is way more than that. However, today I'm going to focus on this so you can really see the key Python functionalities, and we will calculate not only integers or numbers, but also strings and other data structures. So as you can see, I'm already into the PyCharm IDE, and there are a few ways in which you can run the code. The first one is obviously into this file test1, where you can simply write something, let's say print hi, and then execute this file, right? And you will see hi here. The other way is if you go to the terminal, which is basically the same as if I open a terminal into my device. So you can open the terminal and you can write Python 3. okay, and you would go in the same console. So if I print hi, you will be able to immediately see the output. Obviously, I would like you to see the code underlined, and I think it's way more presentable if you run it from the file test1. So this is what we're going to be using, but I just wanted to make sure that you also know about the second option as well. So the first thing I will talk about is variable assignment. So let's say if I would have a variable spam, I can assign it the value of 1. I can also assign it a string or text. So you can do, let's say, text would be equal to hi everyone. Okay, so you can either assign integer or string to a variable. Always the variable on the left is the one that gets the value, while the variable on the right is the actual value. So if I do here print spam, and then if I do print text and I run that, I'll get 1, which is the value of spam, and hi everyone, which is the value of text. Okay, so I will comment this out, and so it doesn't run anymore in the code. And let's perform some basic operations. Let's say if you want to print 2 plus 2 and run that, this would be equal to 4. So the addition operation works properly. You can also do something more complex. For example, print 50 minus 5 multiplied by 6. So 5 multiplied by 6 is 30. 50 minus 30 should give us 20. And you can see that we're returning 20 here. You can of course perform division as well. So for example, 8 divided by 5, it will give you 1.6, and so on and so forth. Now, if you want to calculate power, so let's write here basic operations, and then if you want, for example, to estimate the power, you can simply do 5 to the power of 2. So 2 stars mean power, so this should give us 25, right? You can see here 25. Also, if for example you want to do, let's say, an estimation of a surface of square, you can create a variable width equals, let's say, to 20, height equals to 9, and then you can estimate the surface or the area by simply multiplying those. So if I multiply the width and the height, then I should get the area, which is 180. Using numbers, you can also estimate tax, for example. So if I do tax equals to 12.5% divided by 100, okay? So this would be in percentage. And then if I do price equals $150. And if I want to see what is the new price, I will do price equals price multiplied by tax. So now the new price would be equal to $100.50 multiplied by the tax will give us the new price. So if I want to print now the price, this will give us 12.56. And of course, actually, to find the price after tax, we need to also add the price here. Okay, and this will give us the final price, $113, from which 100 is the price, while 12.56 is going to be the tax. So this is another way to estimate things in Python. For example, if you would like to round this number here, you can simply do it with a round function. So if I do here round price, comma 2, which means 2 signs after the decimal point, and this will give us 113.6. Okay, so this was about the integers, but in Python it is actually quite easy to sum strings. And this is one of the key Python benefits. It is a really simplified programming language. So if I want to do, for example, print, and I can do I space plus everyone, and then I want to print it, I will see hi everyone. This is how you can just sum strings. If I remove the space here, the strings will be printed together. So this is how easy it is to append strings in Python. You can also use some specific symbols in order to print things within the strings. So for example, if I delete this, and if I want to write doesn't, for example, let's say we have single quotes, and if I want to do doesn't, the T is going to get out because Python would understand this parenthesis as the end of the statement here, so the end of the string, and T will be left out. So if you want to avoid Python to consider certain character, you can simply write a backslash and then the symbol, and if I run this, you can see that we can print doesn't, okay? Because this doesn't get recognized as the end of the string. Another useful thing is, for example, if you want to print something on the next line. So if I do s equals first line dot, and then if I do /n, and then I write second line and run that, actually let's also print it, so print s. Okay, you can see that we have first line, and then on the end this one is split, and and next we have second line right here. So you can also print strings with comma. So if I do print 1, comma 2, then if I print that, you see 1 and 2 with space. So the comma would add space between the strings. You can also select a specific characters from a string. For example, if I write car equals to Toyota, and if I want to print just a single letter from this car, for example, if I want to do print car at position 0, then I will print T. If I want to print car at position 3, for example, I print O. Notice that in strings, and actually this is the same in lists, we start with 0 and we continue until the end. So position 3 will not be Y, but in that case it is O. Okay, you can also start on the other side of the string, and you just need to add minus. If I do -1 and I run that, you will get the last letter which is A. If you do -2, you will get E. So when you write minus, you're traversing or starting from the last letter of the string. You can also take chunks. For example, if I do R from position 1, position 4, then you will get OYO. And if you wonder why is that, it is because we start from position 1, which is O, and then we continue until position 4, which is T. However, we're not taking the T because we stop there. We start from 1 and we stop before 4. You can of course do this with starting from the last letter as well. So if I do -2, then we will get A. We will start from T until the end. When you have a column and you don't have anything after it, this means until the end. So for example, if I put -2 here, this would mean from the beginning until -2, right? Pretty simple. So this is how you work with strings. Let's talk now about lists. So in Python, a list is simply a sequence of different elements. So for example, let's create a list of different squares. Let's write squares would be equal, and list is denoted by this type of parentheses, square parentheses. So let's do 1, then 4. Also another square is 9, which is 3 multiplied by 3. Then you have 16, and 5 multiplied by 5 is 25. Okay, so we have this list of squares, and now let's see how and we manipulate this list. First of all, let's actually print it, see how it's going to be displayed, those squares. You can see the list right here printed, and lists are one of the most useful data structures in Python because you can traverse them in many ways. For example, if I want to print squares at position 0 like this, then I will print 1. At position 1, I will print 4, and so on. It's pretty similar to when we extract characters from the string. With the same logic, if I do squares -1, I'll print the last element, which is 25. -2 will give me 16. 3 will actually also give me 16 because we start 0, 1, 2, 3. You can also slice a string. So for example, if I would write 2 until the end and run it, then you will get 9, 16, and 25. If I do -2 until the end, then I will get 16 and 25. We will start from 16 until the end. One interesting operation in Python is that you can also sum lists. So let's see how it works. For example, if I do pairs plus, and let's add another list. Let's do plus. Actually, let's print that. So let's print squares plus 4, 17, 1070. Okay, so let's print that, and you see that you don't actually sum the numbers with the numbers of the other list, but instead you just add them to the previous one. So if this one ends to 25, then you add 34, 17, 1070. Another way to add element into a string, which is actually a quite useful way, and a way that is used very often by the Python developers, is by using the append function. So if I do squares dot append and I write here inside, okay, so which one is the next square root? 36. And then if I print the squares, you get 25, and then we append 36 after that. You can definitely explore all the list functions in the web. There are quite a few very useful functions, and we cannot cover all of them here, but I really advise you to do that because lists are very important. So in order for you not to get the impression that we can put in list only integers, I will also show you that we can put characters or strings. Actually, the idea for characters doesn't exist in Python. Everything that is in parentheses is a string. So let's do letters equals, and let's do A, B, C, and D. And in the same way, for example, if you want to print letters from 1 to 4, okay, if you want to do that, you print B, C, and D. right? Those here. So the same rules apply for letters. You can also do a two-dimensional lists. And don't get freaked out about the term two-dimensional. This is just list inside a list. For example, actually let me comment in this list. We have squares and we have the letters. So if I do, for example, x would be equal to squares, comma, letters, then you will have the squares list and the letters list within our new x list. So let's see how this looks like. So let's print x right here, and you can see that we have a list of different lists, the squares and the letters. Pretty simple. So I will definitely leave this file and project into the resources for this course. You can go back to what we already wrote and check it out. And here, what I will do next is to show you just some simple steps to go towards programming. So far we were doing simple code execution and we didn't apply any particular logic, but let's change that. So let me just comment out those. By the way, you can comment out by control and then /. Okay, so let's call that first steps into programming. So let's write a simple while loop. Let's write first variables a and b, and this will be equal to 0 and 1. And this means that we assign 0 to a and b we assign to 1. Okay, so let's create a while loop, and we'll talk about while loops in the next videos. So while a is smaller than 10, okay, then I would like to print a, and then a would be equal to b, while b would be equal to a plus b. Okay, so don't get confused. That's a pretty simple program. So what we say here, while we use the while statement, we say while a is less than 10, so when we start, a will be equal to 1, so we'll enter this while loop. We want to print a, then a would be equal to b, so a would become 0, a would become actually 1 because we started with 0, and b would become a plus b, which in the first step would be 0 plus 1. Actually, let me write those on different lines so it's not confusing for you. So a initially would be 0, while b would be equal to 1. In the first step, a would be equal to b, which means that a would be equal to 1, and b would also be equal to 1. In the next step, a would be equal again to 1 because b is 1. However, b would be equal to 1, a plus b, which is 1, and it will become 2. And we'll execute again and again this while loop until a becomes equal to 10, at which point the while loop will break. Also, in many programming languages, you have normally a semicolon after every line, but in Python we don't have that. You simply need to control the indentation level. So this means that you need to have what is inside a loop, exactly one tab space from where the loop starts. And this is pretty simple. So let's run that and let's see what's going to get printed. You can see that we got 0, 1, 2, 4, and 8. And these were the different values of a. So this is how you execute a while loop, guys. And this is the first actual programmatic thing that you've done so far. That's it. Thank you very much for watching this video. And next, we will focus on the control flow statements. Thanks for watching. Hi everyone, and welcome back to the course. In this video, we'll talk about control flow statements, and those are all the statements that involve or and while loops in Python. So we'll start by covering the if and the for loops, since we already talked about the while loop, and then we'll move to something more advanced. So let's create a new file here, Python file, and I will call it control flow. So I'll get a little bit closer so you can see. And let's first talk about if statement. So the if statement is basically a condition that if it is met, the code inside this condition gets executed. If this condition is not met, then the code is not executed. And this is pretty simple. For example, I can create a variable x, and x would be equal to an integer. This is how you can specify that something is specifically integer. And then you can take the user input, and let's write here, this enter an integer. Okay, let's do semicolon and space. So x would be assigned to some integer that we specify, and then we can create if statements depending on what is the value of x. So I can do if x is less than 0, then we can make x equal to 0, and then we will print negative changed to 0. Okay, then elif, this means that if x is not smaller than 0, we're just checking another condition. So else if x is equal to 0, then we will print 0. And finally else, which means that the code in else will be executed for absolutely everything except for x equal to 0 and x smaller than 0. This means for all the positive numbers, we'll print higher than 0. Okay, so let's run this code and let's see what happens. Actually, let's run control flow, and you can see here, please enter an integer, right? So I will enter -4, and then I can see the statement negative changed to 0. So we go here and we see that x is smaller than 0. Then we make x equal to 0, and then we print this statement here, right? So let's run this again, but let's now put 0. As you can see, I put 0 here, and then you can see 0 printed just because we didn't go into this if statement since x is it was not smaller than 0. In fact, x was equal to 0, and for that reason we printed 0. And let's check also our final condition. So let's put a positive integer, 5, and here you can get higher than 0. So this is how these statements basically work. Now let's comment this out and let's move on to for statements. And I will explain them to you in a quite simple way. Okay, so let's write here for loops. And we say loop because the for statement gets executed again and again and again until certain condition is not met. So for example, if I create a list of words, and in this list I can add the words, let's say add doc, and let's say window, and let's say for W in words, print W and the length of W. Okay, so there are a lot of things that we need to talk about here. Now the first thing is what is W and what means this in statement. So we say for W, which I refer to word, actually we can write it as word, so for word, okay, so for every word in words, now it's more understandable, right? So for every word in words, print the word and also print the length of this word. For example, the length of cat is 3, the length of dog is 3, the length of window is 6. So what the for loop is going to do, it will go to the first word, it will execute what is inside the for loop for that word, then it will move to the next word, and then to the final one. So let's run the program and let's see what we're gonna get printed. So you can see that we have cat 3, dog 3, and window 6. And actually in PyCharm there is one very cool feature, which is the PyCharm debugger, which is this thing right here. So if I place a point, you can select here and place a point and run the debugger, you can see that your program stops right here. Okay, so it executed this line. We have a list of words that are called cat, dog, and window. And now we go in the for loop, but we didn't enter it yet. So if I select this step into, we can see that first the for loop gets executed for cat. Then we're gonna print cat and the length of the word, right? We printed. You can see it in our console. Then we're gonna execute the loop for dog, as you can see here, and we'll print the dog 3. And then we'll do that for the final word in the list, which is window. And then we'll print window 6 here. And since this was the last word in our list, when I select the arrow again, we exit. And this is how it works. Let me now remove the point from here and see some other more advanced example. So in Python, there is something that is called dictionary. So dictionary usually has key and value. And if you want to get the value, you need to provide a key. If I do users, it's a dictionary, and dictionary is with these curly brackets. So let's say ans is the key, and the attribute is active. Okay, then let's say Eleanor inactive, and then let's say John active. Okay, so for example, if I want to do let's say if I want to print user ans, okay, I will see active. So if you select the key, you will get the value, right? If I do John, I will also get active. If I do Eleanor, I'll get inactive. So this is how dictionaries work. And you can also use them into for loops. If I do for user, comma, status, and those could be any type of words. This is just the words that we'll use in the for loop. If those, so for those in user.copy.items, so this means if you copy the users, actually don't focus too much about the copy statement. You need to focus about the items. Here we're getting all the items from users, and we assign the user to the name and the status, the value. Active, inactive, or active. And so obviously in the first iteration or the first time when this loop gets executed, we have for user hands, and for status we'll have active. So let's do if status equals inactive, then we want to delete or del user. Actually, let me do here users so this can differentiate. So users user. Okay? User refers to the key, while users is the whole dictionary. Okay? So if the user is inactive, we want to delete the user. And then let's print users. Okay, see what has left. So you can see that, actually let's print users here as well. So let's do print users so you can see the change. So you can see that before the for loop, our users were with one more, so Eleanor should go deleted in the for loop, because in the for loop what we did is we said if the status of the user is inactive, so let's say the loop will start with Hans. So we will say if the status of Hans is inactive, which is not the case, then we'll delete it. So we don't delete it since its status is active. Then we'll go to Eleanor, and since her state was inactive, this if statement here will get triggered and we'll delete her. And John will not delete him because he's active. And this is how this works here. And then this gets deleted from users. So when we print the new users, you can see that Eleanor has been removed. But you cannot only remove, but also you can populate a dictionary using for loop. So let's comment this out. And for example, let's create a list or a dictionary of active users. So let's do active users would be equal to an empty dictionary. And now we can populate this empty dictionary. If we do for user and status in users dot items, actually I'm gonna leave the users here so we can use those in order to populate the active users. So let's actually leave the print statement, right? So right now we have the users here, and we want to find only the active users and put them into another dictionary. How you can do that is you can say if status is equal to active, then active users at key user would have value of status. Okay? And here is square signs. Okay? So let's after that print active users, and basically we get the same thing. However, the difference was that in the previous loop we deleted the inactive user, and here we actually created a new dictionary only with active users. So we said if a user is active, add that user to the active users dictionary. So these are two instances that you can use for loops in order to either create or delete elements from a dictionary. So this was the key for creating or and if statements. Thanks for watching, guys, and next we'll talk about some keywords that you can use within the control flow statements. Thanks for watching. Hi guys, and welcome back to the course. So since in the last video we were talking about control flow statements, today I will talk about a topic that is quite important, and these are some of the most important keywords when using control flow statements. So the first one that we will talk about is the range keyword. So let's write here range. So range is something that is quite commonly used in the for loops, and an instance would be for I in range 5, let's say print I. So this would mean that for I in the numbers of 0, 1, 2, 3, and 4, print I. So in the first iteration, I will be equal to 0, then to 1, then to 2, then to 3, and then to 4. So if I run that, you'll see that we print each and every of those numbers that I just mentioned. Now, with range, you can do many different operations. For example, you can choose range that starts from 5 and finishes at 10. So if I start this, you get 5, 6, 7, 8, and 9. You can also add step, for example, 3. So this means that you will start from 5 to 10 with steps of 3. So the first one will be 5, then 8 is 5 plus 3. So then you will print 8. And since if you add 3 more, this becomes higher than 10, you will not print anything else. If you do steps of 2, then you will have 5, 7, and 9. So always remember, in range, the first number is the start, second number is the end, third number is a step. You can always avoid writing the step or the first number. You can, if you want, provide either the last number or the first number and the last number. Let's see another instance of range, since this is quite important parameter. For example, if I create a list of different names, so let's do Mary, add a little lamb, and you can do for I in range length of A, and then we can print I and A at position I. Okay, so let's see what we've done here. So how much is the length of A? So the length of A is equal to 1, 2, 3, 4, 5. Okay, so this will be equal to 5, which means that here we simply say for I in range 5, print I. So in the first step, I will be equal to 1, and A at position I. Actually, at first step, this will be equal to 0 because we start from 0 to 4. So A at position 0 will be Mary. So the first one will be 0 and Mary. Then we would have 1 and hat, and so on and so forth. So if you have a list and you want to loop over this list and get both the location and the element, you can use length in order to loop over every element of this list. And this is something that is used very often by the Python developers. So let's run that code, and you can see at position 0 we have Mary, then we have 3 for little and 4 for lamp. I think you got the idea. Okay, so let's now talk about some of the other keywords that are quite important into the loops. And those would be the break, continue, and else. So you already know about the else keyword as part of if statement. However, it could also be used in for statement too. So if else is written into a for loop, it is executed when the loop is in the situation where it has condition that is false. So if I write here or n in range 5, and let's actually instead of 5 we're going to create a list. Let's do values, and let's write here 6, 5, 25, 3, and 8. So let's do range length of the values. Okay, and let's do if n percent, actually let's do if values at n percent is equal to 0. So this would mean that, for example, we get 6, and if 6 divided by 2 has no remaining, which means that the remaining is equal to 0, then I would like to print loop exited at the first even. And after that I will put break. So break would mean that the loop will break immediately after we find the first even number. Okay, actually let's print this even number. So I will do values at position n, wherever this number is, and then I will print that statement here. So let's run that, and you can see that we broke the loop at 6. If I remove the break statement, you'll see that we would actually get two numbers, 6 and 8, because we have two even numbers. However, with the break keyword, this means that as soon as we reach this keyword, our for loop is going to break. So this is how the break keyword is used. Now if we remove it, as you saw, we're getting this for loop executed. So if the for loop don't get broken, or when it's exhausted, which means that all the possible values have been executed, then you can also specify some condition what will happen after that. And this is done with the else. So most commonly else is used in combination with if, but sometimes in very few cases you can use it as part of the for loop. And I can write here print I, and this will specify what would happen exactly after the for loop finishes. So if I run this, you'll see that once the for loop finish, we see high. If for example I have break here, since the for loop will not get exhausted, you will not see high because all of those statements will broken or will break out from them. Okay, great. So this is about the break and continue, break and else. But how about continue? So continue is usually used when you want, let's say, certain condition from a for loop not to be executed. For example, if I write for num in range 2, then if num %2 is equal to 0, or this means if the number is even, we can print count an even number, and then we can print the number. Okay, and then we can print for the rest of the numbers, count an odd number, and then we can print the number. So is that going to actually print the even numbers here and the odd numbers here? Well, let's see. What do you think? Let's run this, and you can see that, for example, 2 is printed 2 times, not only 1 time here. Right? So we say found even number 2 and found odd number 2. That's weird because 2 is not odd. So you can see the pattern that basically the odd numbers get printed once in the correct way, right? So 5 and 3, they are printed correctly. However, the even numbers, they are printed 2 times. And if you think about it, there is a very good logic behind it. So once this if statement is executed for an even number, then the code continues here and the same number gets executed within the print statement here. So how can we prevent that? Well, I actually use this example to show you the power of the continue keyword. So if you write here continue, this would mean that once the execution reaches this keyword, we will not continue until the end of the code, but we will return back to the for loop and we will take the next element. For example, if we have 2 here, let's say, we would come here into this if statement, we would print found an even number 2, then we will reach the keyword continue and we will go back and take the next element, which would be 3. So 2 should not be printed 2 times. So let's run that, and yes, you can see that once we run the function with the continue keyword, you can see that after the even number 2, we don't get it printed a second time. So this is how continue works. Okay, so let's comment this out. And the next keyword that I'll talk about is the pass and match keywords. So let's talk first about pass, because pass is more simple. So pass, guys, is actually used in loops or functions, even in classes, which we haven't talked about yet. But what it basically do is preventing the appearance of errors. For example, if I write while true and I run it, I'll get an error because we have a while statement, but we don't have anything inside. So if you want to write a while loop or for loop, but you don't want your program to fail, but you haven't decided yet what you exactly write inside, you can simply write pass. If you do this, simply this line will pass and you will not return an error. The same is with classes, for example. So let's do class and let's call it my class. And if I write the pass keyword here, let me comment out the while loop. And if I run it, you'll see that the program executes correctly. If I remove the pass keyword, we'll get an error here because you created a class that has nothing inside. So this is why pass keyword is useful when you want to build a structure that you don't know what you put inside yet. And finally, we will talk about the match keyword, which is also quite useful if you have different cases. And as an example, I will show you how you can use it, for example, to define errors. So let's do match status, and you can do here case 400, and actually let's define first status here. So let's say status would be equal to 418. Okay? Those are the standard HTTP errors that you sometimes receive when you try to enter to some browser in internet, right? You can receive error 400, let's say, and you can use a structure to define the errors. So if you receive 400, then you can return, let's say, bad request, right? If you receive, for example, 404, you can return error not found, or case 418 would return, or actually let's here write it with print, it might be easier. So let's do print, okay, and then print, and here we can return, for example, bad number. Actually this is not any type of error, I just made it up, okay, and that's it. So what we say here is basically trying to match some of the options for status, and let's say if status is 418, then we'll return bad number, right? Let's run that, and you can see that we're printing bad number. If it is, for example, 415, we return nothing because we don't have this defined. So you have number that is not defined, you can actually write case underscore, and then you can do print I don't know, right? So when you run it like this, if it's any other number than the ones defined, you will print I don't know. And this is how you work with case and with match. Basically the whole statement here is called match case. So this was all about that I wanted to share with you guys about keywords. Thanks for watching, and I will see you in our next video. Hi everyone, and welcome back to the course. Since you are already familiar with the loops and the main Python syntax, today we're going to talk about functions. So let's create a new file in our project, and I will name this file functions. So what a function is? Every function has an input, okay, and then it has an output. So the most simple way that I like to define functions and to describe them is the following. So usually we have some input or some variables that you pass to the function. Then inside the function, there's some processes that are happening, right? And you don't care about these processes. It could be anything. There is some functionality that happens into the function, and then you have the output, right? So for instance, if the plus sign is a function and you pass to that function 1 and 2, you're getting 3. So your inputs are going to be 1 and 2, and your output is going to be 3. You don't care how this plus sign works. You just care about what you pass, which is 1 and 2, and what you get. So functions in Python and actually in any programming languages are used in order to take some very complex and big portion of your code and completely forget about it by putting it into a function. And then into this function, you can pass your parameters as inputs. Then this code can perform what it does, and then you can get the output from that. And I will show you some examples here if it is not clear enough. So let's write here functions, and below I'm going to define a simple function. So let's say that we want to find the square root of a number. How do we do that with a function? Now, firstly, in Python, we define function by the keyword def. Normally, this keyword should be followed by the name of the function. So let's name this square. And after that, you need to create brackets, and in the brackets, you pass the parameters that are inputs. Right? So if you want to find the square root of a number, then as an input, we will pass that number. And let's call this number a. So everywhere where we refer a, this will be the number that we will pass to that function. So next, I will create a variable that will be used as an output, and let's call it sq. So sq would be equal to a multiplied by a. Okay, so this is going to be the square root of a, right? And then in order to use this sq as our output, we'll use the return keyword. So if I write return sq, this means that this function returns or gives the sq parameter as an output. So let's try that out. Now, let's go outside of this function, and you probably already noticed that when you write a function, you need to go one indentation level in order for this code to be considered as part of the function. So let's say that there is some number, okay, that is 5, okay? So now let's say that we want to find the square root of 5. This is 25, right? So we want to use our square function in order to find that. And this is very simple to do. You simply need to do square of the number, okay? And if I run this code, you're actually not going to get anything. And this is because even though we returned the result of this function, we actually didn't print it. So if I write now print this function of the number 5, then you will get the result 25. You can also assign the function run to another variable. So if I do here sq number equals to square of the number, and then if I print sq number, you would still get 25. So as you know, in PyCharm you can use a debugger in order to see how things work, and I will place the red dot right here, and let's see what's happening with the program. So you can see that we're actually running the function with the number 5, and here we assign to a 5, right? So in the function, the number that we pass to it is represented by a, and a is 5. Then on the next line, we are executing this line here, so a multiplied by a, 25, and then we're returning 25. And after we return it, we assign it to this parameter sq number, and then we print it right here in this line. So this is how a simple function works. You can also print the sq number inside the function. So for example, if I don't want that, I can simply do here print sq. So this will actually make sure that we print sq, and this will happen inside the function. This is usually not the best approach, because if you just print sq but we don't return it, this means that our function will not have output. It will not return anything. It will just print what we send to it. So let's return the return statement. Okay, so let's create actually a little more complex function here. I will comment out this one, and our next task will be to create a Fibonacci series up to a certain number. Okay, so if you don't know what the Fibonacci series are, the Fibonacci series are series where every next number is combination of the previous two. So they would be 0, 1, 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, and so on and so on. So let's create a function that will generate a list with certain number of Fibonacci numbers. So let's do def fib for Fibonacci, and then we'll pass one parameter n, and this will be the number of Fibonacci numbers that we want to generate. Then we can write result, and the result could be equal to empty list. We already talked about lists. So let's create a would be equal to 0, b would be equal to 1, and then we can say while a is smaller than n, while a is smaller than the amount of Fibonacci numbers that we need, then we want to do result dot append a. This means that the list that we have here, which is initially empty, we're going to append, or we're going to attach the next Fibonacci number. Okay, so initially the Fibonacci number will be 0, but now here we will update it every next step. So let's do A would be equal to B, okay, and after that B would be equal to A plus B, okay. And so in that way, we'll continuously update A and B, and A would be the next Fibonacci number, okay? So then here you can return result, okay? And after that, let's run the function. So for example, you can do, let's create a number. So let's do F10 would be equal to fib, and then we'll pass here 10 numbers, okay? So we would like to get a list of 10 Fibonacci numbers, right? So let's run that code and see what happens. Actually, let's print it here, and then let's print F10. So F10 would be a list, as you can see here. So if I run that, we would get a Fibonacci series up to 10, okay? Actually, I created this function for up to what number we would like the Fibonacci to be. So when the Fibonacci number is smaller than the limit that we pass here, then this while loop is broken and we return the result. But you can also create it depending on the amount of Fibonacci numbers in the list. So for example, if I would like to change the condition in this while loop, I can do, for example, if the length of the result is smaller than 10, then we will break the while loop. And if I do that, you can see that we're getting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 Fibonacci numbers, okay? The only difference here is that we're comparing the length or the amount of numbers into the result with the number that we passed. So this is how we're getting 10 Fibonacci numbers in the same list, okay? And see how simple it is. We actually don't care what's happening here inside. We only want to pass how many Fibonacci numbers we want in this function, and then we're getting the result. And this is the idea of the functions, to hide all these unnecessary calculations for the users. Now, another very cool thing about functions is that you can pass default parameters, and I will show you exactly what I mean. So let's say you want to define a function, so let's do def. Actually, first I'm gonna name that default arguments, and by arguments I mean inputs, right? So let's do def ask okay, and let's pass a few arguments, prompt, retries, and you can assign the retries to be equal to certain value. For example, here retries would be equal to 4, right? And this means that if I don't pass anything, any argument to retries, it will be equal to 4 by default. If, however, I pass something, so if when I run the function, I write retries equals to 11, let's say, then this will be updated. So this is done so the function does not fail if you don't pass any value to retries, so it would have the value of 4. And then let's do reminder. I will also pass a default value, please try again, right? So this will be our function. Now let's create some logic here. Let's do while true, okay will be equal to input prompt. So then if okay is in the following tuple y, ye, or yes, then we'll return true. And then I'll create another if statement. So if okay in and no, nope, or nope, then I will return false, okay? And then we will reduce the number of retries. So let's do retries equals to retries minus 1, okay? And then I will say if retries is smaller than 0, then we'll raise an error. So we're going to talk about errors later on in the next videos, but here I will raise a value error, and this error would say invalid user response. And finally we will print the reminder, okay? So this is our function, and I don't know if you guessed what this function is doing, but what it basically does is when you run it, you're passing to the function prompt, which is a user input, and prompt could be either y, yes, or no. Then you have retries. So once you get this prompt, you have 4 retries until you raise an error. And so you can either increase the number of retries or you can change the reminder message, but you don't actually need to assign those. So let's run our function. Now, let's create a variable and let's call it okay variable, and this would be equal to ask okay, and then we are required to pass at least the prompt parameter. So here I will pass hello, and after everything is done, let's print the okay var, because we're either going to return true or false here. So let's run that, and you can see the hello message right here, and after that our function is actually still executing. So now we're into this while loop, and we either need to provide yes or no. So if we don't provide those, then our function will re-execute again, and we'll have 4 retries, and then our function will fail. So if I write something random here, you can see that we are getting message please try again, Then if I write another incorrect thing, we will again get the same message. Let's write some other thing too. And finally, since we have only 4 times, when I do that right now, we're getting an error, invalid user response. And this is because here the times were set by default as 4 and our message was please try again. Now how about we actually write retries equals to 2 and then let's change the reminder. So the reminder would be different reminder. Okay, so let's run the function again and see the changes. So again we have the message hello and I would type one time something that is neither yes or no. Let's run it and you can see that you're getting different reminder because now we assigned some specific value here, so the default value is overridden. And now I will have only one try to write something right here, and then on the next one I will fail. And this is because we no longer have 4 retries but only 2. So this is how functions are working, guys. I hope you enjoyed that video. Thanks for watching and please enjoy the rest of the course. Hi everyone, since you already learned what functions are, the next logical step for me is to explain you how to create classes and methods in Python. So object orientation is one of the most important programming concepts and we're going to talk exactly about this today. So let's create a new file, Python file, and let's call this file dog. And here we'll create a class that basically generates dogs. Class, guys, is a blueprint of an object. So a class could be dog and then we can create different dogs named Jack, Buddy, and so on. We can create a class human from which we will get different humans and we can name them, right? So let's say all the humans and all the dogs, they have the same type of attributes. Let's say all the dogs, they have a breed, they have 4 legs, they are barking and so on. And in the same way for humans. So why creating all those attributes separately for each human and each dog if we can create a blueprint? So let's create a class and let's name this class dog. Classes in Python are always named with the caps, with capital letter, right? So when you create a class, the very first method inside, so you know we define method as def, is usually the constructor. And the constructor in Python is marked with the init. Here is init, right? So this means that when we create a dog, what are the attributes that we want every dog to have instantly? So obviously one of the attributes that we would like a dog to have is a name. So let's add name here and we can say self.name is equal to name, right? So what that means? This means that the name that we are passing from outside to this class is assigned to this variable, while self.name is the current name inside the class, right? So for example, I can change the name of this variable here as name1 and name1, and this means that the name that we pass would be equal to the name inside the class. Okay, so everywhere where we state self.name, this would refer to the current name that was taken from the calling of this class. So let's say that every dog has different tricks, right? Every dog could know a number of tricks. So let's say if we want to create a dog and also to this dog we want to assign the number of tricks that the dog knows, we can also do self.tricks could be equal to an empty list. And why here we don't need to write anything in the call of this method is because we want to assign the tricks to an empty list and then increment or increase what's inside this empty list depending on the new tricks that the dog knows. And bear with me, this would really make sense in a second. So in order for the dog to learn new tricks, we need to create a function for the dog to learn new tricks, right? So let's create def learn trick, and here we'll pass the trick variable, okay, and we'll do self.tricks, this variable here, which is a list dot append, and we're gonna append the trick that we want to add, right? So this is our class. Now let's see how this class is basically working. Let's say I want to create a new dog. So let's say d or dog1 is equal to dog, and we need to pass name to that dog, right here. So let's call it Buddy, right? So in order to prove that there is actually a dog created, let's do print dog.name. Okay, so dog.name should give us the name of the dog that we just created. Actually, this runs our previous function, so let's close it and let's run the dog, and you can see that the name of the dog is Buddy. So now we have a new dog. If you, for example, print dog1, you're going to get this object here, which means that an object doc has been created, or an instance of this object doc. Actually, this number here is the exact location in the memory where our doc is located. Nice. So let's see how we can teach our doc some tricks. For example, I can do doc1 dot learn trick, and then you can pass the name of the trick that you want your doc to learn. So let's do row over. Okay, let's add another trick. So let's do doc1 dot learn trick play dead. Okay, so now let's see all the tricks that the doc already know, which should be row over and play dead. And you can do that quite simple. So let's do doc1 dot tricks, and actually I need to write doc1 dot tricks in order to make sure that those tricks belong specifically to doc1. This is because I can also create a doc2, and this could also be a doc, but it could have different name. So let's say the name Teddy, right? So now the doc Teddy would not know any tricks because we didn't assign any, but the doc body will actually know 2 tricks. So let's test that out. Let's do the tricks, and let's actually print that. So let's do print doc1 dot tricks, and let's see what tricks doc1 knows. Well, our doc now knows how to row over and to play dead. On the other side, if we want to print the tricks of doc2, right, then you will see that here we have an empty list because we didn't assign any tricks to doc2. If I do here doc2 learn play dead, and if I now run the code, you see that our doc2 now knows how to play that. So you can also add certain attributes, specific attributes to every class. For example, if all of your docs are located on west, you can do location equals west. So this means that every doc that is created would have location west. And you can check that by simply printing, let's say doc2.location, okay, you see west, and this would be the same for doc1. You can of course also change this location. So if you want to do doc1.location equals east, after that if you want to print doc1.location, you would actually get east, right? Makes sense. So this is how you're creating a class, guys, and this is how you can create different attributes in those classes. So that was all I wanted to share with you for today. Thanks for watching, and in the next video we'll talk about imports and class inheritance. Thanks for watching. Hi everyone, and welcome back to the course. Now, one of the most confusing topics when using Python is how to deal with the modules and the packages. What are actually modules and packages in Python? And I think many people are thinking that those two concepts are very complicated, but they are actually not. And here is how it works. You see these files that we have on the left? Those are modules. In Python, those files are called modules. So module is a single file that has certain functions and variables. So those functions and variables, they can be used. So you use this module. Let's say if you want to use the module doc, we can import it in some other file and use the class doc there and all the functions that we just wrote. So what's a package? A package is a combination of many modules. For example, our project that is called calculator has control flow, doc, functions, and test1 files or test1 module. And so if I want to import the calculator to some other Python file, then this will be the package. Package is a group of modules. Very simple. You also might know that sometimes we're importing in external packages. For example, if I just want to import something randomly, let's say import dist units. This is some random package that somebody created and it represents exactly the same thing. So if I select control and I click it, you see that this is simply another file that has certain attributes, right? So this is another module. And so everyone that is creating those libraries, those external libraries, is basically creating different Python files combined in a package that can be reused by anyone. For example, some of the most famous Python packages are, let's say, Flask, right? So if I go into Flask, you see one huge initialization file, which is basically the header file of the Flask package. And inside the Flask package, you would have many different files with functions or modules, right? So for example, here I selected this Flask class and it sends me to the class app.py, from where I can use that class here, right? So again, the external packages are just a normal Python files with some advanced code that you can reuse. just as the one that you made. So you can either import your local packages or you can use external ones. For example, if I do import functions, then I'm importing this file right here. Okay, so if later on I do functions dot, and you can see this function okvar or ask OK, which is part of the function. So I can simply assess this function here by importing the module functions and then writing dot and then the name of the specific function that I can use. So you can use functions, attributes, basically everything that you have defined in the file that you're importing. If you, however, don't want to use this function dot thing, you can simply write from functions import ask OK. So I don't need to write this, and I can simply use the ask OK as it is. Okay, when I run the code, it would go to functions, it would assess the ask OK, and it will send it right to my file. So the imports work in the same way no matter whether you use external or internal imports. And since you know that already, here it comes the topic for class inheritance. Now normally in Python you can inherit a class, which means that you use one class into another one and import all of its methods. And normally this is done by creating the other class in another file, or you can do it in the same file as well. I'll first do it in the same file and then I'll show you how you can do it in a separate file. So if I create this, let's say another class called Labrador, which is a breed of dog, then it makes sense that the class Labrador pretty much have the same initialization and basically the same methods as a class of a dog, because Labrador is dog. So in that case, dog would be the base class, while the Labrador would be the derived class. And you can simply write here into the brackets dog, and here is how Labrador just imported all the methods from doc. So if I don't want to update any of those methods here, I can simply write pass, and this means that every time when I create a Labrador, it will basically have the same variables as the dog, right? So let's say if dog1 is actually a Labrador, okay, and then if you want to print dog1, you would print the same object here, and then when you check for the dog1 location, you would get west, as you can see here. So we don't get any errors for the only reason that we pass dog to Labrador. If we remove that, however, and run the code, you can see that we have many errors because Labrador has no arguments, right? And it didn't import anything from the dog class. Of course, you can also create another file. So let's do new Python file and let's call this Labrador. And I can simply copy this class right here, okay? And you can see that the dog is not recognized, and this is because we need to import it. So let's do from dog import dog. And you can see that now this is completely recognized and ready to use. So if I create dog5 equals Labrador, and let's write the name Jack, and then let's print dog5 dot name, and let's run the Labrador file, you can see that we're running not only the code here, but also the code in the doc.py, right? So let's say if I disable this here and I rerun it, you would see the name Jack, which means that the class was successfully inherited and imported into another file. So I hope, guys, that this video really answered a lot of questions about imports, packages, modules, inheritance, and so on. This is a very important and easy topic actually to understand if explained well. So that's it. Thank you very much for watching, and in the next video we'll talk about how you can handle errors in Python. Hi everyone, and welcome back to the course. In this video, we will talk about a little more advanced topic in Python, which is the error handling. Even though I use the word advanced, this topic is actually quite easy to understand, and you'll see that it is not that hard to handle errors in Python. So there are many different types of errors, but in order to explore those, let's create a new file. So new Python file, and I will do errors. Okay, so let's get a bit closer, and now let's try to create a syntax error. So if I do while true print I, okay, so if I run that, you can immediately see that we're having invalid syntax error. This is because we normally need to do a semicolon between the while and what we want to be inside this loop, right? So this wouldn't work. Let's see another type of error. For example, if I want to do 1 divided by 0, then I will get non-zero division error, because usually in math you cannot divide numbers by 0. Let's try another error. So for example, if I do 2 plus string of 2, and if I run it, you're going to get a type error Or let's say if you haven't defined a variable, let's say hello, and if I run that, I'll get name error because hello doesn't have anything assigned and it hasn't been defined. So sometimes errors might appear, but you also want to make sure that you handle them. So usually in programming, if there is automatic error generated, this is a bad sign. This means that something happened in your code that you didn't predict it, right? And this could break your system. It could prevent the rest of the code from execution. So for that reason, we're having something called error handling, right? So it is very simple. So let's write one example so you can see how you can handle errors. So let's do while true, x would be equal to 2 plus 2. And when I run this loop, this should generate constantly errors. So we get a type error here, right? And we immediately break this while loop. And this means that our code will stop executing. So instead, what we can do is we can use the try statement. So let's do try, and then let's press tab to move this statement here. So we can try that, and in case this doesn't work, we can do except, and we can say that we expect type error. And this means if we get type error while we are trying this here, we can print the variables are from different type, right? So let's run that and let's see what happens. And you can see that since we're having a while loop, now our while loop actually is not breaking, so the code continues executing, and we're getting these errors or error exceptions constantly. Our code doesn't break. Of course, if you want to stop once you find a type error, you can simply write the break keyword, which we were talking about, and you'll see that since our code will break on the first execution of the while loop, we will return this statement here. So we will not get a system error, but we will be able to predict that error. So how it works is that we're first trying this clause here, and if no exception occurs or no error, then our exception clause is skipped. For example, if I write here 2 plus 2 and then print x, you'll see that we will constantly get false, right? You can see it right here. So if our try clause passes successfully and there is no errors, then the except is not triggered. And however, if an exception occurs, okay, then the except clause is triggered and the exception is raised. However, if the exception is not the same as the one specified, so if you do divided by 0, then you are still going to get an error. If you remove the exception specifier, you will get the exception activated with absolutely every type of error. Quite simple, isn't it? You can also write a multiple exceptions here. For example, type error, you can do zero division error, and so on. So if I close this, you will see that if I run the code, this zero division error is also covered. So this is how you are dealing with exceptions in Python, guys. Thank you very much for watching. That was a quick video, as you see, and it is really easy to handle errors in Python. And so please enjoy the rest of the course. Hi everyone, and welcome to this section where we're going to learn the basics and even more about Pytest. So here I will explain you why Pytest is the industry standard for testing and why it's important to know Pytest for absolutely every programmer or software engineer. So whether you're working on your own project or on open source projects, it is quite important always to be able to test your code. And normally for that, Python has a built-in testing tool called unit test. However, in the past years, Pytest gained popularity among the software engineers because it has many incredible functions with which you're able to test your code easily and efficiently. So as you probably know, in every company there is automation test team which is specifically given the task to test the code produced by somebody else. So regardless if you're using additional test tools, they can all be combined with Pytest in order to create your ultimate testing routine. Moreover, engineers that are doing code testing in Python are usually one of the most highly paid professionals in those companies. But why Pytest is so widely used today? Well, this is because it has very powerful functions, such as the assert function, and also it allows third-party plugins, for some of which I'm talking in my courses. So Pytest is a test framework, which means that it has a command line tool that automatically finds tests you've written, runs the tests, and reports the results. It has libraries with different functions that can be used throughout the tests efficiently. Pytest can also be extended by writing plugins or installing those third-party plugins. So let's see the few reasons for which Pytest stays way above the other frameworks. So simple tests are simple to write in Pytest. This means that you don't need a lot of setup in order to write just a single test. On the other side, complex tests are still simple to write, but learning just a few key Pytest functions, you'll be able to test absolutely everything easily. And trust me, I use Pytest in my own work to test APIs, web services, or even physical instrumentation for which the code is created on Python. At the same time, because of the Pytest fixtures and the command line tools, the tests are very easy to read and well organized. And you will see just in a bit in the next videos how easy Pytest is to learn. So I hope now you have an idea and you are more excited about what is going to happen in this section. And we'll continue in the next video where I will talk about the different types of testing. Thanks for watching. Hi everyone, I thought it might be quite useful for you before jumping into the actual coding first to learn what are actually the different types of testing. So in this video we're going to discuss all types of testing known by the software development engineers in the industry. So there are many different types of testing: unit testing, integration testing, black box testing, white box testing, and so on. But what is the difference between them? So let's first talk about the unit test. Unit testing is testing a very small amount of code or a unit. You can test just a function, and this could be one unit of your code, or you can test a file that consists of many functions, or a class. So this means that you want to test a specific unit or a function within your program or software. So actually in the next video, the first thing I will show you is exactly that, how we're creating a test function and test some certain unit of our software. We will create certain units that we are going to run separately. So this is the easiest way of testing and the most common one. You're simply writing a different units or test functions, and then you're testing them from the command line. So this is a very good way to start your testing. However, unit testing might not be sufficient in some instances, and this is when different units are communicating between themselves. So even though you test the separate units, when they exchange information or messages, there might still be some errors. So for that reason, we have integration testing. And integration testing means testing all the information exchanged between different system components or different systems. So in simple way, we can say that integration testing is on way larger scope comparing to unit tests. Basically, integration testing is testing the communication between the different units. So in normal conditions, you would first perform unit testing to ensure that each of your units or functions are working, and then you test the communication between them with integration testing. For example, if your gas pedal on the car is a unit and your wheels are another unit, you definitely want to know what happens when you press the pedal and how this affects the wheels. Because your pedal might work perfectly fine, your wheels might rotate also perfectly, but the communication between those could be affected. So you definitely need to test that. So after you did the integration testing, then the next level is system test. And system test usually checks how the whole system or all the units working together can actually perform in real life when an actual user or client is using them. So coming back to the example of the car, you might test the communication between the pedal and the wheels, but you also want to understand how the car works as a whole. Are there units that are affecting each other that you didn't account about in the integration testing? Well, maybe they are. So in that case, you need to test the whole system, and those tests should involve as close as to user experience as possible. And then there is the functional testing. The functional testing is testing a single bit of functionality in your system. An example could be how well we add, delete, or update certain tasks. In many cases, functional testing is not actually testing the code, but is testing the user experience. So for example, if you're creating a website, functional testing would be a user going to that website and testing certain service. For example, the payment service. You can make a payment and you can see if that service is working properly or not. You can test it under different conditions and see if that service is actually meeting the needs of your clients. And if you heard the terms black box and white box testing, well, they're related to the type of tests that I just described to you. So for example, the black box is when the internal structure of the program is hidden. So functional testing would be black box testing because the testers have no idea about what and how the code looks like. They are just testing from user perspective. On the other side, the unit testing and the integration testing are are white box testing, because with them the tester is actually having access to the units that he is testing and can see the code in details. Of course, we can have transfers between the different types of testing. For example, if our unit information or the code within the units is hidden and you want to do a testing of them, then this would be black box testing as well. But this is it, guys. Those are all the different types of testing that I wanted to share with you today. I really appreciate that you watched the video, and please continue with the rest of the section so you can really understand and learn Pytest. Thanks for watching. Hi everyone, and welcome back to the course. So before jumping to the actual coding, I wanted to discuss a little bit with you about how Pytest actually works, and later on we're going to of course write some test functions. But before that, I wanted to show you the simple logic behind Pytest. So what you can see in front of you is a test function right here. You can see how we run this test function and what is the output. Something very similar is what we're going to see when we start writing the actual Pytest test cases. So this is a simple Python function where here we're defining it. This is the name of the function. We pass no parameters, and here we're using the assert keyword to compare to tuples. Tuples is something similar to lists. The only difference is that you cannot modify the elements inside. So assertion in Pytest means comparison. So this means that we're going to compare this tuple with that one. We're going to test whether they are equal or not. So since, as you can see, they're exactly the same right here, logically the test. Okay, so since you understand the function now, let's see how the test is actually working. So firstly, we're going to the file that we're using, to the actual directory. So cd means enter a directory. So we enter the directory path and then the directory sc1, okay, which could be any type of directories with any type of name on your device. This pretty much doesn't matter. And then we're running the pytest command, right? And then we're running to.py. And to.py is a Python file that has this function inside, right? So when you run Pytest, this means, okay, assess this file, and with that, assess this test right here. But how Pytest actually knows what to test? Well, it's pretty simple. In every test function that you write, you should start that function with test. So when you start the name of the function with test, then Pytest is looking only for those functions with that name. And it knows that this is a test function, and it basically tests it. So this is how you run Pytest. But let's see what's in the output. First of all, you will get how many tests were collected. For example, here, since we have one test function, we're collecting only one item. And then the result of the test. In order for everything to be simple, firstly, you have the name of the function and then the result. If the result is passed, you're going to get a dot, usually a green dot. If the result is fail, you're getting F, right? So this is done for simplicity, of course, and there you will see some options where you can actually see a little more information once your test is executed. Now, let's see an example of test that actually fails. So, for example, if I change the positions of the numbers in the tuple, then the test would fail. And you can see that here we basically have the same approach. The only difference is that here we're not getting a dot as before, but we're getting F for failed test. So usually you would get F, and after that you'll get some additional description about why your test failed. Now here there is one option with which you can get a little bit more information. So if you write -v, as you can see right here, when you execute the test function, then what you would see is little more information. For example, instead of dot, you would see the result passed, and this will be again in green. And also you will see the exact test file and the test function that you are testing, right? So definitely do that if you want to get a little more information. If you simply have thousands of tests that you just want to see if they are whether passed or failed and you don't care where they are, running the Pytest without the verbose method or -v option, it's more sufficient. So the choice is yours depending on your use case. So these are, guys, the very basics of Pytest. Thanks for watching, and in the next video I will show you how you can actually create and set up Pytest and also write test cases. Thanks for watching. Hi everyone, and welcome back to the course. In this video, I will show you how to create your complete Pytest project with everything installed, and also we'll talk about how to create your first test cases. So to do that, let's run PyCharm and let's create a new project. And I normally like to create the project on the desktop so you can see it better. And let's code this project We'll use Python 3.10 in this example, and we have a custom virtual environment, as you can see. So let's create it. And so in PyCharm, you can simply open your terminal which runs in your custom virtual environment that is here. So everything that you install is basically going to be installed in your virtual environment. So let's do pipe3 install pytest, okay? And you can see that pytest has been successfully installed in your computer. If you need to update it, you can do pipe install -- update pipe to update pipe, or pipe install -- update pytest to update pytest. Now, since you have it installed, even if you don't, you can do this later, of course. Let's actually create our first file. I will actually create two test files, and let's create a new Python file, and let's name it 1, and let's create another file, Python file, okay? And those are going to be your first two tests that you execute in Pytest. So you can see that here from the terminal we can actually run Pytest, and here in the files we can write the code and test functions. So let's actually do our tests from the example. Now let's create a function, so def test underscore pass, and we will not pass any parameters, and then let's do assert, and then let's do 1, 2, and 3. We'll check if it is equal to 1, 2, and 3, right? So this is our first test case. You can also see that only in PyCharm you get a specific ability that it recognizes if you have a test case, and you get this arrow here with which you can immediately run your test case. However, for more complex projects this is not sufficient because sometimes you need to load a lot of libraries. So I will just show you the standard and the most secure way how we do it from the terminal. And this terminal that I open here, trust me, it is basically the same if you would write a terminal and you would open it somewhere else. So this would be the same if I would go to this folder and activate the virtual environment, right? So don't get confused. It doesn't matter whether you use the virtual environment and the terminal from Pytest or from your command prompt. It doesn't matter. It is just for me more convenient to do everything from the same screen. So now if I write pytest2.py and I run it, you can see that you have one test that is passed. If I go up, you will see that one item has been collected, and we have test2 with green dot, which means that the test has passed successfully. Now let's create a failing test case, and I will do that in file 1. So if I write here def test failing, and then if we do assert, let's do 1, 2, and 3, should be equal to 3, 2, and 1. So since those are tuples, those two elements are actually not equal because the positions of the different numbers is not right. So if I run now this test case, for example, if I do pytest, and then if I write 1.py and I run it, you can see that one test is failing, and also you can see failed result, and the reason is that the assert here is wrong. If you go up, you can even see more in detail, more in-depth comparison. So you can see that we failed in the assert statement, and that at index 0, which is this one, we recognize that 1 is different to 3, right? So this is where we got the error. The Pytest would even advise you for some better options. For example, it advises you to do -v to get more information, and this is the verbose method. Now usually with Pytest, guys, you should be able to run all the test files just by writing pytest in the directory. So let's do that and see what happens. So you can see that there are no tests that have been run. Can you think of any reason why that could happen? Well, the reason here is that if you want to automatically run the test files, not the test functions, but the test files, you actually need to also name them starting with test. Because remember, Pytest is always looking for the files or the functions that start with test. So let's rename those and see what's gonna be the difference. So let's do refactor, rename, test _1, and let's rename the other one too. So let's rename and let's do test. Okay, let's do refactor. Okay, so now if I run pytest, okay, pytest, if I run it, you can see that both tests have run successfully, and you have one passed and one failed, exactly as we were expecting. You can also do pytest -v to get more information, and let me extend that actually. So if I do -v, you can see that you are getting way more information here. You're getting the full difference, all the numbers that are different between the elements, and also you get the full word. You're getting passed and failed, right? So definitely use the verbose method if you want to get a little more information. So those were two simple cases. Actually, they were very simple, but this video was more about you understanding how Pytest works and how the tests are structured, which is way more important at that point rather than learning how to write complex tests. However, this is actually coming up in the next videos in that section. Thanks for watching. Hi everyone, and welcome to the next Pytest lesson. Since you already know how Pytest is actually working and you developed some quite easy and simple test cases, today we're going to do something more advanced. We're going to test tuples, and I will show you I will create two files, actually one in this video and one in the next one, where we're going to test tuples. So let's create a new file, Python file, and let's name it test3. Okay, so what is the idea here? We'll create a list of tasks, and each task would have a related element from a tuple. So for example, if I do task equals named tuple, okay, and let's import name tuple, and here inside let's do task will be the name of the tuple, and after that we're going to create a list of elements. So let's the first element be summary, the second one owner, then done, and finally ID. Okay, so this is our tuple that is named task. So every time when we create a task, we'll create a new instance of this tuple, and we'll have the different tasks here: summary, owner, is it done, our task, and the ID of the task. Imagine this as if you would have a system and you would like to create different tasks, and each of those tasks would have summary, owner, is it done, and ID. But each of those elements, they should have a value, right? So let's say for done, we should have a value of true or false. For ID, we should have some number. For owner, we should have some name. And for summary, we just need to pass a summary. So let's do that. I will do task.new.defaults, and this will be equal to none, none, false, and none. So you don't actually really need to understand what name tuple is or have some practice with it. But what you do need to know is that each of those elements here is a default option for summary, owner, done, and ID. So summary, owner, and ID would have default value of none, while done would have default value of false. So now, since we have that, we can actually create some tests. So what test would you normally need to do for this type of tuple? Well, the first one could be to test the default values, right? So with Pytest, I could do def test defaults, okay? And so this test would actually test the default values. So let's create task 1 would be equal to task, okay? So this means that T1 would have all the attributes of a task: summary, owner, done, and ID. And by default, each of those values for a task should have these defaults here, right? Then let's create T2, and this would be equal again to task, but here we're going to pass the values none, none, false, and none. So the difference between those two is that in the first one, we don't assign any value to each of those elements. However, on the second one, we specifically assign the exact same values like the default ones. So what we can do in this test is to simply compare those. So if we assert T1 and T2, if we have successfully implemented the default values, then the values for task 1 and for task 2 should be the same. So let's go down here in our terminal and let's see if this test is going to pass. So I will do pytest test3.py and I'll use the verbose method. So you can see, guys, that one test has passed and you can see the pass result here, right? So this means that the default values are the same as those here: none, none, false, and none. So let's see what would happen if we change one of the values of the second element or the second task. Let's do this one equal to true, okay? So let's run the same thing, pytest test3.py -v for the verbose method, and you can see that this test is failed. Also notice how fast the test is actually running. Now you can see that we got assertion error, and we can see that for the task done, right? The first element or the first task is equal to false, while the second one is equal to true. And there is a difference, so Pytest definitely spot that, which means that the values of task 2 are different from the default values, which is actually the case. So let's put here false. Now another thing that you might want to do, and actually let me paste it here. So another test would be to assign values to, let's say, some of those elements of a task here and see if they are going to get assigned accordingly. So let's do another test, and here I'll write def test member assess, okay, and let's do here t equals to task, and here we're going to pass some values to those elements here. So let's do for summary by milk. For owner, let's do Brian. This is basically if you want to create a task for Brian to go and buy some milk. Then let's now test that. So let's assert t.summary equals to buy milk, okay. Then we can also assert t.owner to be equal to Brian, And also in that case, you would like to assert and check whether the completion of the task and the ID are the same as the default values. So let's do now assert t.done and t.id equals to false and none. Okay, so this is how you're creating this task, and let's see if we will get a passed result. So if I do test3.py and let's do -v for the verbose method, and you can see that you have two tests that have passed. So firstly, you run the test member assess and then you run the test defaults, right? Which means that all the assertions here have passed. If you even make a space here, right, this would be recognized as a different element and you can see the difference immediately, right? So you can see that there was a space here, and for that reason the name Brian, or the name that we're checking, is not the same as the one that was assigned to our task. So this is how, guys, you can actually use Pytest on more complex data structures, and this can be really expanded to enormous tuple or hash map sizes. So I hope that this video was useful. Thanks for watching, and in the next video we're going to continue with another test. Hi everyone, and welcome back to the course. In this video we're going to do an extension of the previous one, so I will show you how to do some additional tests for the tasks that you created. Now first of all, we're going to create another file, so I will want you to import this task tuple to it, and I will show you how this is done. So let's go here on the site in Pytest, let's create a new Python file and I will name it test4. Okay, the reason why I'm doing that is because later on we're going to use those 4 files, so I can show you some command line features of Pytest for which you would need multiple tests and multiple files. So let's do here from test3 import task. Okay, so now task is taken from here and it's in your test4 file. Now sometimes when you're creating data structures, you maybe want to transfer from this tuple to a dictionary, and this is because the dictionary has a unique ability to have keys and values. So let's see if we can actually transfer our task name tuple to a dictionary and test whether this conversion was successful or not. So let's go to test4 and let's create a function called test asdict, and asdict is a Python function that actually creates a dictionary from another data structure. So here let's do t underscore task would be equal to task. Okay, and let's pass now something to this task. So let's the actual task be, or the note in the task, the summary, let's this be do something, then the name, let's put it Jack. Okay, then the next element would be if the task is done, let's make it done, so this would be true, and finally the last value is the ID, so let's assign to the ID 21. Now let's do t underscore dict, and here's where the conversion will take place. So if I do t underscore task dot asdict, and this is a default Python function, so you don't need to import anything to use it. And now we converted our task to a dictionary. Okay, and so what we want to do is to actually test whether our dictionary looks in the way that we expected. So let's do expected equals, and let's create a dictionary that we expect to be the output of this asdict function running on our t task. So what I would expect is to have a summary. Okay, and the summary would be do something, then owner would be Jack, then the task done would be true, and finally the ID would be 21. So this is how a dictionary, or the dictionary that we're expecting, should look like. So let's now check whether this is a dictionary or not. Now what you can do is simply to assert t underscore dict to be the same as expected, right? Okay, so let's test that and check. So sometimes you could even make a mistake with your expected result. So let's run Pytest and see if we did any mistake, or if the dictionary that we created is the correct one. So what I'm gonna do is Pytest test4py, and let's see. So this test is passed, which means that our dictionary was created successfully. Now for example, if for ID you put 2 instead of 21, then this should definitely fail, as you can see here. And so you're getting the element of the dictionary that is not the same, and you can even write -v to see a little bit more information. So you can see the whole dictionary here that you're receiving compared with the one that you're expecting. So this is a very easy way to check conversions into other data types. Okay, so the last test that I want to show you is how to test if you want to replace something, right? So maybe you created a task, but you want to replace some of the elements in the task. So let's see how we can test that too. Now if I do def test replace, okay, and here let's do t underscore before equals to task, and let's pass first the summary, which would be finish work, then the name, let's again use Jack here, and also false. So we haven't yet finished our work. Okay, I'm not gonna assign ID at this stage because we would like to do this at the next stage. So let's do t underscore after, and to do that let's use the t underscore before, and let's do dot replace. So here with the replace method you can actually change or add certain elements. You can actually add elements, and you can actually see them here with PyCharm, the different elements. So if you want to add element, it is very easy to do, even in order that is not the right one. For example, if I do id equals to 10 and done instead of false is equal to true. Okay, so let's say the task got ID and the task got completed. Now, if we look at the logic, this task that we created after should be with attributes finish work, Jack, true, and 10. Right, so we want to test this replace method if it works properly. So what you can do is to do t underscore expected would be equal to exactly what you expect. So task finish work, okay, then the name would be Jack, then the done would be equal to true, and finally the id would be equal to 10. Okay, so if our replace function was successful, then we should get that. If it was not successful, maybe we would get what we assigned initially. So let's see if this works properly. So let's do assert, okay, and let's compare the t underscore after with t underscore expected. Okay, so let's now run both tests and see. You can see that you have two tests that have passed, and the test replace was passed as well. Of course, I will actually do some modifications so you can see what would happen if this fails. So let's say if the id that we assigned instead of 10 was 11, and we run the function again from the terminal, of course. So let's do pytest test4 py. You can see that we have one failure, and the failure is that here 11 for the id is not equal to 10. Let's do -v, and you will see that actually in that case we need to do -vv for the replace method. So you can see here that actually the id of the task was different from the one that we assigned. So this is how you can test different types of functions, guys, using Pytest. As you can see, this is really simple. Now, thank you very much for watching. These were the 4 test cases, so in test 3 and 4, that were a little bit more advanced, but I did my best to explain them to you in a way that you can understand easily. In the next video, we're actually going to explore some of the key Pytest command line tools in order to run your tests in different ways. One of the most important things in Pytest, because especially when you work with a lot of test cases, you definitely want to use some additional tools in order to select and run the correct tests at the correct time. That's it. Thank you very much for watching, and I will see you in the next video. Hi everyone, and welcome back to the course. In this video, I will show you some amazing tricks and techniques to improve dramatically your testing with Pytest. So let's get started with our command line options that you can choose from. Now you already know in the previous videos we created 4 test files with 6 tests in total. Actually, let's check that. So if I do Pytest, okay, we should test all the 6 tests that we have there, and you can see that one of them is failing while 5 of them are passing. So we're going to use those to explore the Pytest options. Okay, so the very first thing, which is probably one of the most important command line options, is of course the help. Or with the help, you can definitely explore different Pytest options that you can choose from. So if you do Pytest --help, you can get all those options that you can choose from, right? So if you want to go a little further, definitely do Pytest --help or -help, and then I can assure you that you will find some amazing functionalities. Now, another very nice option to know is going to be the -k option. So if you write pytest -k as dict, right, this would mean that Pytest would search with its advanced search tools for expressions or tests that are involving the asdict keyword. So you can see that we have one test here. So what we would expect is to run this test. Let's run that. And you can see that you have one test passed and 5 deselected, which means that you selected only the test asdict file that you can see here. So we went to test 4 and test asdict. So definitely use -k in order to find tests by name. Into the asdict, into the parentheses here, you can also write or and add another keyword. For example, if I want to test the replace method, so I can do here replace, and then you have 2 tests, right? So you can use or, and then you have 2 selected tests. If you do -v, you can actually see exactly which tests have been selected and have passed. So definitely use the -k option because it is quite useful. Now, the next key tool into Pytest is called marker. Now, marker is something that is very widely used, and I will show you how exactly it works. So if you do pytest.mark.importantTest, you can basically use that to add a marker or something with which you can find all the tests that have the same marker. And to do that, you need to actually import Pytest in your file because this is some specific functionality of Pytest. So I'm gonna mark this, and let's mark another one. So let's do this one. Let's do pytest.mark.importantTest, and let's import Pytest here too. Okay, perfect. So see, with -k you can really search for specific name, but sometimes if you have hundreds or thousands of tests and you want to select only the ones of your desire, you cannot simply write keywords for every test name. So instead, you're going to mark those tests with the same marker. And this is why here what we're going to do is write pytest -m for marker and then search for the specific marker that we defined. So the marker could be important test, right? Let's also use the -v for the verbose method. And let's run that. So as you can see, 2 tests were selected, one failing and one passing. And those were the test replace, which is right here, which we marked, and also test failing, which is this one here. So the common thing between them was that they had the same marker, which we used in order to run them at the same time. Now, at the moment, we're looking only at 6 tests, but as I said, sometimes, especially if you're working as a test automation developer, you might find yourself in a situation where you need to test thousands of tests. In many cases, you only care about those tests that are failing. So you would like your program to stop there. And to do that, you can simply write pytest and do the -x command. This will make sure that your program stops when it finds the first failure. For example, when you run Pytest here, you have your test 4, so we started from there and we have 2 passes here. But then in test 1, which was our failing test, we had failures, so we stopped there. In that case, you can make sure that you're not skipping the failures that are resulting from the different tests. If you, of course, have more tests that you want to fail before your program to stop, you can actually use the max fail option. So you can simply write max fail equals and then the number of tests that you would expect to fail. So if I would expect to fail 2 tests and run it, actually we got an error because I had to do double dash. So if I do that, you can see that we're running all the tests because we were expecting 2 tests to fail before the script stops. So if I do max fail equal to 1, then you can see that we actually stopped at the first failure. So you can use that too. Regarding this, another cool option that you can use for only showing the failing tests is the elf option. So this is going to show you the last test that have failed. For example, if you do pytest-elf, so yeah, actually here again you need to do double dash, and you can see that we're running or we're showing only the test that has failed right here. We're skipping 3 files and we're showing only the failure that you, or this is the last failed test. In our case, since there is only one test that is failing, we're always going to get this one. But it's good to know the options for the last fail and the first fail. So for the first fail, for example, it is FF, and this test will actually show you the first failing test, right? Which is this one, okay? So imagine if you you would have many tests, you would get always the failed tests first, and after that you would get the rest of them. So in here you're actually showing all the tests with the failing first, while in the other way, the last failed shows only the tests that have failed. Then the next option I want to show you is actually exactly the opposite on the verbose method, and this is the -q option or quiet. So if you do pytest -q, we're seeing even shorter version of the test output. So if I go up here, you're just seeing dots and fail. So you can use this option if you want to see as less information as possible. So those are all the options, guys, that I wanted you to know, and actually I created a list for you easily to be able to choose from those. And of course the help and the verbose options, I would say, are the most useful, because with them you can really get access to firstly all the options that you can choose from, and also get more information for your test cases. So this was the last video of that section. I hope you now understand Pytest and can apply it to your own projects. This will also help you with all future test courses that you plan to take. So thank you very much for watching, and I will see you in our next adventure. Hi everyone, and welcome to this section where we're going to talk about why Playwright is the best emerging test framework and how it gained its popularity. So as a software test engineer, I've always been exploring the best cutting-edge test frameworks, and a few years ago I found out about Playwright, and since then it became my favorite test automation framework to use when building new automation projects. And there is a good reason for that. It's very easy to set up, and it's currently one of the fastest and most reliable frameworks I've ever used. So as you know, in this course I'm going to guide you through the Playwright framework, which will enable you to write end-to-end tests for your favorite projects. We'll talk about the extensive features of Playwright, but before that, of course, I want to give you with this section a brief introduction. So Playwright is actually built by a Microsoft team and is used for end-to-end testing and automation. The biggest Playwright competitors such as Selenium and Cypress even didn't realize how fast Playwright gained enormous popularity. So what I have in front of you in this figure is a survey among developers, shows that the current trend is a rapid growing popularity of the Playwright framework, and you can see it right here in the graph. Since it is an open source project, we can easily track how many people are using it and contributing to this framework. Its GitHub repository actually has about 39k stars and 12.2 active users tracked there. So this framework is not only easy to use, but also it has lightning fast execution speeds and some great features that are unique to Playwright framework. And also the Traceviewer and the test generator, which we'll really explore in detail in this course, but for now I'm just gonna give you a brief introduction. So let's first talk about the Traceviewer incorporated in Playwright. So what it is? It is actually a graphical user interface tool that is used if you want to review the Playwright traces after tests have been executed. You can easily enable it by setting the set trace to on, but this feature I will show you in our next sections. This will not only generate reports, but also it will create a zip file in which you will get all of your test results. And you can either get those in the trace.playwright.dev or from the command line with a command that you can see right here. This one you can simply write in your command prompt. So after following either of those processes, you will be able to see the Playwright Traceviewer. And so here you can really dig deeper into how long your tests took to execute, the parameters that have been passed, the network calls that have been made, and any other logs related to your test execution. You can also hover over the trace film strip at the top of the page to see the stage, actually each stage during your execution, and they are covered differently, as you can see, which is quite useful and can really give you a very graphical and easy to grasp understanding of your test cases. The other really nice feature of Playwright is the test generator, and this is actually one of my favorite tools. This is a browser tool that Playwright provides. it is used to record all the actions performed in the browser and generate equivalent code to those actions, right? So you don't even need to know how to code. You can simply perform the necessary actions and the code will be generated for you. So definitely stay tuned because I will show you exactly how this works. This is quite useful too if you want to quickly draft some tests for your team that is not familiar with the code yet. You can again choose to run the test generator using a command line command where you simply need to pass the code gen abbreviation and also the website for which you would like to record. So as you can see, this is a pretty basic view of how Playwright looks like and its key features, which give you way more flexibility compared to some of the other software test tools. So thanks for watching, and in the next video we will talk about some of the key reasons for you to use Playwright, and we'll talk for things such as competition, integration with other frameworks, and the current releases. That's it. Thank you very much for watching, guys, and I will see you in the next video. Hi everyone, and welcome back to the course. In this video, I want to motivate you and to tell you why should you actually use Playwright and how important is to learn this amazing tool right now, because trust me, in the near future there will be way more people and companies that will adopt it, as it is currently the fastest, and I mean it, the fastest software test framework out there. So as I said, Playwright is open source framework that is relatively new to the market, but as I said, it is building popularity very fast. It is created by Microsoft and Microsoft currently maintains it. And as a result, this framework receives regular updates and improvements. So if you look at the numbers in front of you, here you can see the number of downloads of Playwright compared to similar frameworks which have been on the market for a while. You can really see that the Playwright has way more downloads comparing to the competition. It actually peaked to more than 1,200,000 downloads in 2022, which really shows how popular this tool currently becomes in this and the upcoming years. And actually this is really a new generation framework. This is because the whole way that it's built and maintained is quite innovative. In every new release, the Playwright team uploads the new changes in the open source repository in GitHub with quick updates, sometimes even in a form of video. This is something that we haven't seen from any other major framework, and it's really helpful for us to get insight into the team building this framework and into the new features. So on the figure right here, you can see a snapshot from one of the recent releases. I actually think that now we have one release after this one, or even more than one, but this is a really simple way for the users to understand what's been added and removed from the framework architecture. But of course, as a software test tool, Playwright has enormous competition. So as you know, there are other famous test frameworks that are well established, such as Selenium and Cypress. But the main reason for picking up Playwright over the others is simply because this framework is really intuitive and flexible in the way that it interacts with the browsers and multiple pages and domains. So I would say it is like the Python of the software test frameworks. It is very easy to use, it is very intuitive, easy for everyone to understand in a quite simple way, and you really see that throughout the course. But this is just one of the advantages. I would say for me, the most significant advantage of Playwright comparing to the rest of the software test tools is the speed. So in testing, speed is everything. If you can't run your tests quickly and speed up your test cycle, you cannot deliver your product quickly. If you cannot deliver your product quickly, you would of course have a lot of unhappy stakeholders. So let's talk about speed and see how Playwright compares to the rest of the frameworks. So here I prepared a simple graph, actually a table, comparing Playwright with other frameworks. You can see that in most of the categories, Playwright actually takes a first place, and actually this is on the most complex and high scale categories. So these are actually real results and are published by CLI HQ. So what they did, they performed the same test with the most famous test frameworks that involved in-depth execution speed monitoring of all of those frameworks. Playwright is actually the fastest framework on two of the three categories and had Puppeteer behind it in most cases. But of course, if you use this framework, of course you care about speed, but also you care if it is well integrated with the rest of the tools that you're using. So let's talk about that. Let's talk about the integrations for Playwright. So this is probably one of the most important factors when selecting a new tool or framework, because if it doesn't integrate with your current architecture, it is pretty much useless. The worst feeling is implementing something only to realize that it doesn't have an actual integration and we have to start building a custom plugins for our tools. Well, the good news here is that the Playwright team have covered that. So Playwright has support for Docker, so you can execute tests in isolated and controlled environment. There is a command line integration tools, and you can also integrate Playwright with CI/CD tools such as Jenkins, CycleCI, Azure, GitLab, and so on. For a new software test tool, this is actually quite a big coverage when we're talking about integration. You also get support for JavaScript test runners such as Ava, Mocha, and on the Python side, you have a complete integration with Pytest, which we're going to talk about in detail in this course. You even have integration into the competitors of the Playwright, Selenium Grid. And in addition to that, you can definitely manage parallel execution using Playwright as well. So to conclude this video, let's actually talk about the key features that Playwright has. It supports the most popular browsers. It is actually a cross-platform web browser test tool, and it's adopted in Chromium, WebKit, and Firefox. So this includes Chrome, Edge, Firefox, Opera, and Safari. Actually, specifically the way that Playwright is running into different browsers is quite advanced comparing to the other test frameworks, and I will show you this in detail in this course. You can also use Playwright in any operating system. So you can use it in Windows, Linux, or Mac OS. I'm actually using Mac OS, but no matter which device you're using, you're definitely covered when using Playwright and integrating it with the rest of the tools. Now you also have support for any type of programming languages, so you can run Playwright with JavaScript, TypeScript, Python, Java. If you're a C fan, you can use it with .NET. So you have a very big choice and you can reuse the programming language of your desire. I'm even planning to create courses that will also cover Playwright for JavaScript, since JavaScript is the other most popular programming language for testing. So let me know in the comments if you will be happy to see such type of course. But let's talk about the features that Playwright actually has. Of course, those are some very basic features that I provide in this slide. You will actually see in the next lectures how many more features Playwright has, but you definitely have the ability to do smart assertions, retryings until an element is found, test data tracing, keeping logs. You can even keep videos and screenshots easily. You can interact with multi-page, multi-tab websites that involve users, forms, browser events, and so on. And all of those features are working very smooth and lightning fast. So I hope I got you motivated learning Playwright with this video. This is really worth a tool to know. Even now it is used in some of the major companies and it expands massively. So that's it. Thank you very much for watching, guys, and I will see you in our next video. We've already covered some of the reasons for which Playwright is a great to work with on feature and implementation level. But how is it working? What goes internally? How the code actually works? This is what we're going to talk about in this video. What is actually the reason for the execution to be more stable in Playwright comparing to the rest of the tools? So a good way to understand this is to compare Playwright with Selenium and see what is the difference. So Selenium sends each command as a separate HTTP request and receives a JSON response. Quite simple. right? We send HTTP request, actually it goes the other way around from Selenium, and we receive the response into a JSON file, which we're using later on to analyze the test and collect logs. So every interaction, such as opening browser, clicking element, or sending keys in Selenium, is sent as a separate HTTP request. As you can imagine, this definitely results as slower execution because we are waiting for responses, which introduces another layer of operation. So let's take a close look on what Playwright is doing instead. So here Playwright actually uses a single WebSocket, right? We don't need to send different requests, but we use a socket to connect the tests with Playwright, and once the socket is connected, then we can exchange information. This socket stays open until the execution is completed. So this reduces the points of failure and allows commands to be sent quickly with a single connection. So thank you for watching this quick video, guys. I hope that now you clearly understand the key advantage of Playwright compared to the rest of the famous test tools out there. Thanks for watching, and in the next few videos we'll compare Playwright versus its major competitors out there. Thanks for watching. Hi everyone, as we mentioned earlier, Playwright is one of the best tools out there, and its main competitors are Selenium and Cypress. So in this video I decided to compare straight Playwright with Selenium so we can see what are the advantages and the disadvantages of both tools and why should we choose Playwright here. On one side, Playwright from Microsoft is one of the newest additions to the automation framework, and on the other side is probably the most preferred and used test automation framework, Selenium. Selenium has been there for over a decade. First, let's talk about browser support. So both tools pretty much cover all the browsers, and you can see that Playwright supports Chromium, Firefox, and WebKit, which involves Edge and Safari. On the other side, Selenium has support for Chrome, Firefox, Opera, Edge, and IE. So the coverage here is pretty similar, and both tools cover a lot of browsers, so there is not much of a difference when we talk about this factor. But let's talk now about language support. So when talking about language support, Selenium actually supports more languages. You can see that on one side Playwright supports Java, Python, .NET, C#, and JavaScript, while on the other side Selenium supports all those, but it also have support for Ruby, PHP, and Perl. So if you're a fan of the last three, you pretty much don't have any other choice but choosing Selenium. The next thing is comparison depending on what web elements can be handled. So regarding this, both tools are completely different in their own way, and we cannot decide if different is better or worse. So on one side, Playwright handles alerts, iframe, and elements that are different comparing to Selenium. On the other side, Selenium has different WebDriver protocols and architecture to handle DOM elements. What we know for sure is that the way Playwright is handling web elements is way quicker comparing to Selenium, because Playwright uses just a single socket instead of sending HTTP requests over and over again. So talking about architecture, Playwright has a headless browser with event-driven architecture, while on the other side, Selenium is pretty much based on JSON wire protocol. This means that while working, Playwright uses events to handle data, while Selenium is using a JSON protocol in order to collect the test data. So let's talk about waits. Wait is usually an event which implies waiting for some action to happen on the browser. Playwright does many different actionability checks on different elements before performing specific actions, and this makes it actually way more stable comparing to Selenium. On the other side, Selenium uses different types of waits like explicit and implicit waits. And finally, let's talk about the speed of execution for each of those tools. Now, as we already mentioned, Selenium is way slower comparing to Playwright. This is because Selenium has a driver that serves as a middleman and translates the test script commands and sends them to the browser for execution. This is done with HTTP requests, making the process way slower. On the other hand, Playwright is using just a simple single socket to connect to the browser, and from there the testing becomes way more stable. So this was the comparison between Playwright and Selenium. Selenium, of course, is a well-established tool with great community and language support, while on the other hand, Playwright is a new tool with, of course, less documentation, which is considerably faster and suitable for complex Python and JavaScript applications. Playwright is coming up with many features, and it is definitely a good alternative of Selenium, having some components which are better comparing to Selenium. So that's it, guys. Thank you very much for watching that video, and I will see you in the next one. Hi everyone, and welcome back to the course. In this video, we'll compare Playwright with one of the most popular web automation test tools called Cypress. Now, we already talked about the key capabilities of Playwright, such as supporting multiple pages and domains, cross-browser web automation, lighting speed, and so on. So let's see what is actually Cypress and how it compares to Playwright. So Cypress is open source automation tool for web app testing. It is used for end-to-end testing, but supports only JavaScript and the Mocha test framework. So if you are, for example, a Python developer or actually developer into any other programming language, then Cypress is definitely not suitable for you. But if we talk about JavaScript, then you can definitely compare Playwright and Cypress. One of the key features of Cypress is that it provides you with very consistent and detailed results, so you can understand everything that happens both inside and outside the browser. So one of the features that I like the most in Cypress are the real-time debugging, its API testing capabilities, and automating wiring. Now let's talk how this compares with the Playwright. So firstly, comparing the languages that you can use to work with both frameworks, actually Playwright here is the clear winner because it supports way more programming languages. Even though Playwright is relatively new framework, it already supports more than 5 of the most popular programming languages, such as JavaScript, Java, Python, .NET, and C#. Those are pretty much the top 3 programming languages that are used worldwide. On the other hand, Cypress is using only JavaScript, which is not very convenient for some developers. Now, talking about real device support, even though Playwright supports emulators, it actually doesn't support yet mobile browser tests. On the other hand, Cypress supports real device clouds and remote services at the same time, which makes sense because Cypress is on the market for way longer time, so it adopted these capabilities. So when it comes to choosing the right framework, I would say the Cypress actually offers way more documentation and proactive community. This really helps to overcome some bottlenecks just by simply reading the documentation. However, if you want to create a very detailed tests with more coverage on multiple domains, which is of a key importance for most of the projects, then Playwright is going to be the right choice. It's important to note that choosing a test tool for your web app is ultimately a choice based on usage and functionality. So if you choose the right test tool, then the entire test process is streamlined. And for that reason, Playwright really have advantage here because of its simplicity and speed. That's it. Thank you very much for watching this section, guys, and I will see you in our next section. Hi everyone, and welcome back to the course. In this video, I will show you how to develop very quickly your first Playwright script. So let's open the IDE that we use for this course, PyCharm. So just write PyCharm, and let's create a new project where we're going to place all of our scripts for this section. So I'll select a new project and I will use Python 3.10 as a virtual environment. And for simplicity, I'm going to place this new folder on the desktop. So let's do desktop and then let's write Playwright Tools, which is the name of this section. So when you hit enter, you'll be able to see your project, and I hope that you're already familiar with this. And let's create a new file. I will actually call it test1, and here we're going to write a simple script that you can run with Playwright. So before continuing, let's actually first make sure that Playwright is in our virtual environment. So I open here the terminal. So let's first update our pipe environment. So simply write pipe install -- upgrade pipe, just to make sure that you have the last version of pipe. Now the next thing is to install Playwright. So let's do pipe install Playwright, okay, and now you can see Playwright is actually getting installed in your virtual environment. Then do Playwright install, and now we're able to use Playwright scripts within our virtual environment. So the first thing I will do is I'll write from playwright.sync API, and I just want to mention that since APIs can be synchronous or asynchronous, for that reason Playwright have two versions to cover both of those. So if you don't know what's the difference between synchronous and asynchronous APIs, it is that with synchronous APIs, we are blocking all calls until there is a change. So when either a call has been completed or there has been an error, then we move to the next one. While with the asynchronous, the response from the API is returned immediately while the request continues to be processed. So there is a slight difference. You don't need to know in detail what this means, but for that reason I will show you actually two ways for how to work with Playwright for both synchronous and asynchronous API calls. So here I will show you a case where we're using synchronous API. So from playwright.synchronous API, we will import sync playwright, okay, and then let's write with sync playwright as p, okay. So here we would represent the sync playwright with p. So everywhere where you see p, this means that we're using the synchronous playwright. So first let's define our browser. So you know that Playwright has support for different types of browsers. Let's in that case choose Firefox. So let's do browser equals to p.firefox.launch. You can see that all the options are proposed here. So let's do launch. And in order for you to actually see the browser, because Playwright is so fast that you will not be able to see the browser within the automation, let's add some slow motion. So first I will do headless equals to false, and later on we're gonna talk specifically about this option. And also let's do slow-mo equals, let's say 500 milliseconds. Okay, so then let's do page. So page will be equal to browser dot new page. So this is how we open a new page in our browser, and then let's specify which page we want to go to. So far we defined our browser, we opened a new page, and now let's do page dot go to, and let's actually go to the official site of Playwright. So let's do http playwright.dev, okay, and then let's print page.title. So we'll see something in our command prompt once we run that, and after that let's do browser.close, so we can close the browser. Okay, so let's save that, and as you can see, we haven't yet imported Pytest. So in the next videos I will show you how to integrate Pytest and Playwright, but for now let's simply run this Python code. So you can simply write Python, okay, and then run the test1.py file. So let's see what's going to happen. So as you can see, we got the browser for half a second and then it disappeared. So what it basically happened, we opened the page within the browser, we went to the website, we printed the title of the website right here, and then we closed it, right? So this is how it works. I will just give you an example with the asynchronous API. There will not be difference in the outcome, but just so you can see that both cases are possible if you face asynchronous APIs. So let's write below async def main, okay, and so basically here we're creating an asynchronous function, and I'll write here async, and the rest is pretty much the same with async underscore playwright. And actually here you're getting an error because I forgot to import it. So what you need to do is first import async io, and then also we're going to import playwright dot async API. So from there we're going to import async playwright. Okay, so this error here is now removed, and we're gonna represent this as P. So everywhere where you see P from now on is going to be asynchronous Playwright. Okay, so let's do now browser equals to await, and here we use the keyword await when we're working with the asynchronous API. And await keyword is a keyword used only for asynchronous APIs, and it's usually used to pass the function control back to the event loop. So await basically suspends the execution of the scope until we get a result from that await. So let's do await 3 dot, and let's this time run chromium.launch, and then I will place the same options so you can see what's going on. So let's do headless equals to pause, and then let's do slow mo. This time I'm gonna make it equal to 2000 milliseconds or 2 seconds. Okay, now let's do page equals await, and then let's do browser and open a new page. So let's do new page, right? After that, let's do await and then page dot go to, and I will just copy and paste the same website, right? So you can see that what we will get as an output is exactly the same. Then let's print the name. So let's print await page dot title, and finally let's do await browser dot close. Okay, so the final thing we need to do is to simply run the main function. So let's do async io.run, and let's run our main method right here. Okay, so I'll comment out for now this function, and I will save the file. So let's do Python test_1.py, and let's see what's happening. So you can see that we go the page, it stays for 2 seconds, and then it disappears. Exactly what we assigned here. So you can see how we can actually open a page with Playwright in both synchronous and asynchronous way. So you can really see how easy it is to use Playwright to open and close pages. That's it. Thanks for watching, guys, and in the next videos we'll continue exploring the amazing tools that Playwright provides. Thanks for watching, and I will see you in the next one. Hi everyone, and welcome back to the course. In this video, I will show you a very easy yet powerful way to generate code in Playwright without actually writing any code. You didn't know that this is possible? Well, stay tuned and I will show you how this is exactly done. So Playwright is one tool that is called Code Generator. It basically allows you to activate it, go to a web page, perform some actions on this web page, and those actions automatically generate code for you. So let's see how this is done. We're here in our Python project, and here in the terminal, let's simply write Playwright code gen, and then let's go to a website. For example, let's go to wikipedia.org. Okay, so let's hit enter here, and let's see what's gonna happen. So you probably have in front of you the wikipedia.org website plus another window, and this other window is generated from Playwright. As you can see here in the tabs, you can see that we have Chromium open, and at the same time we have the Playwright icon. So what we can see here now, what we wrote automatically generated this run function here, with which we assess the browser in Chromium, we create a new context with which we're recording our actions, and about context we'll talk in detail later on as well. Also, we open a new page, right? And we went to it. Basically, everything that we did in the last video is now automatically generated for you. And this is done in synchronous manner. As you can see here, we're importing the Playwright synchronous. Okay, so what's happening here? Let me actually first reduce the size of this page so you can see both icons at the same time. Okay, and let's start clicking on the different tabs. So for example, if I click here, you can see that a new code has been generated that says page.locator, and it basically says where we click. Let's now go to the search, and you can see that here we went to the search and we clicked, and let's write something. Let's write docs. Okay, so then you get locator, and that we click docs. Let's select docs in warfare. Let's select that. Okay, and you can see that our click was recorded, and also we waited until we go to the next page. Okay, and you can really do a lot right here. So you can click on the different elements and automatic code will be generated, right? So let's take a look at our window. Now we have our code generated here. You can copy it from this tab here. You can stop the recording from right here, and also you can change your language of interest, right? So you can do asynchronous Python, you can do Java, JavaScript, and so on. So if I hit asynchronous Python, you get basically the same actions but using asynchronous API. You can also do the same with JavaScript, Java, C#, all the languages that basically are allowed in Playwright. You can also use that in Pytest as well, which is quite simple. So let's close our recording. So now as you can see, even if I click here, nothing is recorded. So I already copied the code from the asynchronous pause. So let's go back to PyCharm and try to run the code and see what happens. So firstly, I will go to the terminal and press Ctrl Z, and you can also stop all the processes by doing PS, actually kill, -9, and select the processes that you want to kill if they are running into the background. And so once you closed everything, now let's create a new file. So let's do new Python file, let's do here test2, and let's paste what we actually recorded from our recording tool. So now if I run that, for example, actually let's just place right here page.pause so you can see where we actually go. So the idea is that we enter to wikipedia.org and we actually finish into here logistics and communication. So let's see how this works. Let's go in the terminal and write Python and then test2.py. Let's run that, and you can see that Chromium opens and we go exactly to the page that we ended last time. And also if I open the page that just appeared, the Playwright page, you can see that here we're on our pause statement, and if you're okay with what you see and everything is checked, you can simply select the display button and then your test is going to end. So this is, guys, a very easy and useful way for you to generate test scripts of a web page without any effort. That's it. Thank you very much for watching, and I will see you in our next video. Hi everyone, and welcome back to the course. I'm sure that with every next lesson you're gaining more and more confidence with Playwright. So as you know, this section aims to introduce you to the main tools incorporated in that framework. And for that reason today we'll talk about the Playwright interactive mode. So how this works. If you go to the terminal, and actually let me increase the terminal tab here because we use the terminal quite a lot today. And if you write Python, then you're entering the terminal interactive mode. And luckily Playwright actually can be used using that mode as well. And this is done by step-by-step approach. So this interactive mode takes the same functionality as writing the script in a separate file. The only difference here is that after every command you get the action from that command immediately. So for example, if I do from playwright.sync API import sync_playwright, okay, this is the import statement. Then you can, for example, define a variable called playwright, so playwright equals to sync_playwright dot start, okay, and this is how you start Playwright. Then you can also manually create your browser. So if you do browser equals to playwright dot, and let's use Chromium in that case, Chromium dot launch, okay, so actually here I did a typo and that's why it doesn't recognize it, but let's actually use this word even though it is not exactly correct. So let's do here pyWrite.chromium.launch, okay, and at least here you can see that this variable here has nothing to do with the predefined Playwright function. This is just a random variable that can have any name. So now we launched our browser. Then let's do page equals browser.new page, okay, so we defined what page is, and now we can go to the browser. So let's do page.goto, and let's go to https, and let's go to youtube.com, okay, so this will be our page. Okay, let's close it and let's go there, and as you can see right now we got a response and we use the get method which confirms that we did our request successfully. So now, how do we know that we actually went to this page? Well, let's create a screenshot. Yes, with Playwright you can do screenshot of a page, and you only need to do page.screenshot, and then let's say what the name of the screenshot is going to be and where it's going to be located. So let's do path equals, and if I don't place any path, it will be in our current directory which is this one, the Playwright tools. So let's do example.png. Okay, let's hit OK. And you can see that something is happening here. And if I select anything on the folder, it will update, and you can see that here we have the example PNG. So let's see what is there. Well, you can see here that we have the YouTube page, the YouTube entry page, right? With the logo, with the different videos, with some ads as well, right? So this definitely confirms that we successfully entered the YouTube page and we made a screenshot there from the command line. It's quite cool that you can make screenshots, and later on in the next videos I will also show you how you can actually record the whole process and create a video, in fact. Okay, so we're there, but now let's close our browser. So let's do browser.close. Okay, and then let's do playwright.stop. Actually it's Pywright.stop. Okay, and here is how, guys, you can use the Playwright from the command prompt and at the same time make a screenshot to confirm that. You can definitely do this not only from here but also from your Python files. You can do a screenshot, and this is how it works. Thanks for watching, and I really hope that this video was useful. We will continue studying the rest of the Playwright tools, but that was everything for today. Thanks for watching, and I will see you in the next video. Hi guys, and welcome back to the course. In this video, I will show you how you can integrate Pyinstaller with Playwright. So let me first explain you what Pyinstaller actually is. So this is simply a packaging tool. It is used in Python in order to package all the dependencies in a single package. So this means that you can package your app without installing Python and reuse it later on. This is quite famous when companies want to write test cases or other type of code and have working everywhere package with all the depending variables installed inside. So let's see how we can actually make this work using Playwright. Now let's go to Playwright tools project and let's create a new file, and let's call it test_3. And here I will just copy and paste some code that we already wrote. I will only change the website to youtube.com since this is a more famous website, and I will still use the screenshot. So when you're working, for example, from your terminal, the first thing you need to do is to create a variable that is defining your Playwright browser's path. So if I do playwright underscore browser's path equals to 0, let's do playwright install Chromium. Okay, so let's hit enter here, and you can see that now we're installing Chromium dependencies. So let's wait until the installation completes. And so once this is done, let's actually use the Pyinstaller. So let's do Pyinstaller -f and then write the name of the file, which is test3.py. So if I hit enter here, you can see that we're generating a zip file and we're uploading some stuff there. Okay, so as you can see, everything has compiled successfully, and if you hit on the folder, you will see that 2 other files are generated. So first of all, into the this directory, you have the dist3 file where you can get the run file of the test3, and then into the build directory are the rest of the dependencies. And here you get a zip file with all the dependencies and also a package. So this is how you can completely convert your Playwright tests into a separate package, which you can always build with the test3 file. So that's it. Thank you very much for watching, guys. I hope this video was useful, and I will see you in the next one. Hi everyone, and welcome back to the course. In this video we will talk about one of my most favorite tools used in Playwright by far, and this is the Traceviewer. So in order to show you the tracer, I will actually use our code from test2, where we actually entered a page, we filled the work docs in wikipedia.com, and then we perform some additional actions before closing the page. So I will just copy that, I will create a new file, new Python file, I will name it test4, and I will paste it there. So in order to enable the Traceviewer, you just need to add some additional values here. So under the page go to, where we actually go to the page, we need to do context.tracing, and this is where we enable the tracing, then start, and we're going to enable screenshots true, so we can make screenshots. Then let's enable snapshots, also true. Actually, here is screenshots, snapshots, and finally, let's enable sources. Okay, this will be true as well. Okay, so now the tracing has started, and from here on, everything that we're doing is going to be built into a report. But it's not everything. So let's remove this post statement here that we added before, and also we want to close the tracing. So let's do context.tracing.stop, and then let's do path. And if we don't provide path, we can just write the name of the file in which we want our tracing to be saved. So let's do trace.zip. Okay, so we'll generate a zip file which will have all of our results, and then we close the browser and we close the context. Okay, and so once we have all this created, simply write Playwright, actually Python, and then the name of the file, so test4.py. So let's run it, and as you can see, the page comes, some actions are performed, and this is done very quickly. So let's see now our report, and you will be amazed how good those reports look like. So let's do Playwright show trace, and then let's provide the name of the zip file, which is the trace.zip. So let's hit enter here, and you'll see that a new window will pop up. So what you can see here is, first on the left hand side, you can see all the actions that Playwright has performed and the approximate time that it took. So we first had a page locator, and this is where we clicked with the mouse in the middle of the page. Then we have the second touch where it was on the search. Then we attempted to fill this field. Then we selected the doc wildfire, as you can see here. Then we entered that page, and then we selected a particular topic. Pretty simple. So you can definitely try this on other pages as well, and on other inputs, trace them and see how this report will look like. Now, right here on the top, you can see all the screenshots that were performed. So first of all, you see the time for each action to be taken, how much it took, which is quite important when testing, and also the different screenshots, as you can see, from each of those actions, right? So Playwright is making for you different screenshots which you can use to see how the web page was performing, and you can see absolutely everything that was opened, which is, in my opinion, really useful and a very nice graphical representation of what the script is doing. You can also see here on the right hand side the time that it took, which was 70 milliseconds, the parameters used, and also a complete log of what has happened. Even if you want to play with the different pages, you can definitely select different links, and this works pretty much just in the same way as a browser. So this is interactive, which is quite amazing. Even though you have screenshots, you can actually interact with them and see if there are any different options that you want to choose from. So let's close that tab. This was everything I wanted to share with you for this video, guys. I hope you like the Traceviewer just as much as I do. It is really useful into the day-to-day work. Thanks for watching, and I will see you in the next video. Hi everyone, and welcome to this section. Here I'm gonna show you, and you will begin to integrate Pytest with Playwright. As you know, Playwright is using Pytest to create test cases during the automation testing, so the integration of those two tools is crucial for you to understand the next sections in the course, and actually one of the most important things if you want to begin creating and executing a real-world test case. So let's open PyCharm and let's create a new project. So I'll create it on our desktop, and let's name it Pytest_Playwright. Okay, so let's create it and let's open this folder, and here we'll create our new project with virtual environment with Python version 3.10. So let's create it, and since this is a new project, you need first to install Pytest and Playwright. So let's do firstly pipe install Pytest-Playwright to install the Pytest plugin for Playwright. Then let's do Playwright install, and then let's do pipe install Playwright. Okay, great. So now we have Playwright and the plugin for Playwright installed. And so let's now create one basic test case just so we can test Pytest, and I will show you how you can run your test cases. So I'll create a new file here, so new Python file, and let's name it test_usage. Okay, so with Pytest, all the test cases are actually functions. So you can do def, they usually start with test, visit, YouTube. Okay, so obviously, as you can see, this test function will have the purpose of visiting a test function. So as I already mentioned, Playwright has a support for Pytest, which means that you can pass Pytest fixtures into your test cases, which makes your code way shorter. So for example, a fixture would be page. And you remember before, in order to create a page, as you can see from the files from the previous section, you would need to use this here. So you would need to use sync playwright as p, and then page need to be equal to browser.newPage, right? So instead of using all this, you can simply use a fixture page, which is basically the same thing as the one I showed you. It involves the same lines of code, just represented by a single word called page. So for example, if I select command and I click on page, you would see that here we have a predefined playwright fixture that is called page. And what it basically does, it creates a new page. So it's the same thing, it's just here is predefined. So we can save a lot of code. And this is honestly one of the main advantages of using Playwright with Pytest, because many of the functions that you would normally write are already done for you, okay? So we're also going to pass a browser type, and as you can see, if I click on it in the same way, this fixture basically defines what is the type of your browser, okay? And you can either choose to define its name or not. So let's pass that too. And now let's do browser type dot launch, and let's try it again here. Headless would equal to false, and let's do slow-mo so you can see actually the page. Slow-mo equals to 2000 milliseconds, which is basically 2 seconds. And then let's do page dot go to, and we'll go to youtube.com. So let's do https youtube.com. okay, so you can see just with 2 lines of code we can basically specify how we would like our test to run and go to the page. Even you can pretty much skip this line, because this is just specifying the slow motion mainly, so we can see what's on the page that we want to open. But if you want to automate your test and you don't care actually what appears for you to see visually, pretty much you have just 1 line in order to go to a page. Okay, perfect. So now it's time to run our code. So as you can see here in the command line, we're into our Pytest Playwright folder and we're using our virtual environment, which is great. And what you need to do now is simply write Pytest, okay? And normally this is going to be enough for you to run your test case, but I would like to specify browser. So let's do browser, and let's for example do WebKit, okay? If you don't specify that, it will run into the default browser, which at the moment I think it's Chrome. So let's run that, and you can see that. So once we run that, you can see that the browser appears, and we actually go to youtube.com. Another way to actually add the parameters that we defined here is if you delete the browser type completely, okay? So you can just leave it like this, and you can define the slow-mo parameter here. So if I do here slow-mo, for example, 3000 milliseconds, which is 3 seconds. Let's try to run that, and you can see that the page appear, stays for 3 seconds as you can see, and now it disappears. Okay. If you want to run, for example, your code in another browser, you can define here, let's say Firefox. Okay, and you can run that, and you can see that we run the code in Firefox exactly in the same way. So that was everything I wanted to share with you guys. In this video we set up the project and we run an example test case to verify that Pytest is running. Thanks for watching, and in the next videos we're going to go through all the command line interface arguments that we can use, and also I will show you all the different fixtures that Playwright integrates into Pytest. That's it, thank you very much for watching, and I will see you in the next video. Hi everyone, and welcome back to the course. In this video I will show you all available command line interface arguments with Playwright. So as you can see on the slide in front of you, there are 9 different arguments that you can specify when you're running your tests with Playwright. So the first argument, which you're probably already familiar with, is the headed argument, and you would usually want to enable this one when you want to do some advanced debugging. Then is the browser argument, which is used to specify the browser with which you would like to run your script. So you would usually have a default browser. For example, for me this one is Chrome. However, you can actually specify the browser or the browsers that you want to run your tests with. You can use multiple times the browser argument, and specify the exact browsers to use. Then is the browser channel, and regardless with which browser you run your code, you can specify a browser channel. So for example, if you want to run your code in Firefox, but you want to use Chromium channels, you can do that. Then we have the slow-mo, which, as you probably know, defines how much time we're going to take from command to command, and this really helps for us to visually see what the script is actually doing on the website. You can also emulate device. This means that if you want to use specific resolution of a specific device, you can simply state the name of that device, and if it is supported, you would see your website resized into this particular device that you want to test your script with. This is really helpful if you want to see how your website is going to look at smartphone or tablet, and so on and so on. Then you can specify output, which collects all the artifacts gathered during the test. You can do tracing, which can record trace for each test and generate a report. And then you have one option that we didn't talk about so far, and we definitely test at some point in this section, which is the video video, where you can actually export a video from the test run. This is also quite useful because in that way you can present to stakeholders or to your team how exactly the web page is tested and the tests are executed. Pretty straightforward, so everybody can understand what the actual anomaly or defect is. And finally, there is the screenshot keyword, where you can capture screenshots of absolutely every step that is completed while running your tests. So that was everything for this video, guys. I just wanted to state here all the possible command line arguments so you can really think about them and think for their different usage. Of course, we'll cover them in the next videos and I will show you how exactly they work. But before that, in the next video, we'll talk about fixtures, and I will explain you what fixture is and what are the different available fixtures in Playwright. So I know this is only theoretical video and the next one is going to be theoretical as well, but this is quite important for you to understand first. They are really short videos, so it wouldn't take you too much time, but you can get a very good and deep overview of everything available before start using it. That's it. Thank you very much for watching, and I will see you in the next video. Hi everyone, and welcome back to the course. In this video, we'll go over all the fixtures available and integrated between Playwright and Pytest. So here you can see a typical usage of a fixture in Pytest. I briefly mentioned fixtures, but this is something that we will use actually constantly when we are writing test cases in the future. But don't worry, most of the fixtures that I will show you are already written, so you just need to know how to call them. In any case, here is how a fixture works. So a fixture basically defines how a test case would run. For example, if you want to open 2 tabs within your browser every time when you run the test, you definitely don't want to write 1000 tests and define that you want to open 2 tabs every single time, right? For that reason, you can simply write a fixture which defines that and simply pass it to all the test cases, right? So this fixture, you will define it somewhere else, and there you will define the logic for opening more than 1 tabs or something else, and then you pass it back to the function, right? So no matter what code is being written into this function, it will execute using the fixture that you created. So this is the idea of fixtures. And so for that reason, the developers of Playwright decided that many of the functionality of Playwright can be simply incorporated into fixtures and then pass it to the different test cases for simplicity. Of course, I'll also show you how you can develop your custom fixtures, because in many cases you would actually need that in order to simplify your code and test cases. But before creating custom fixtures, first let's go over the fixtures that already exist into the Playwright world. So here they are. Here are all fixtures that are predefined in Playwright. So let's see what they mean. So you have 2 types of fixtures that you can see. They're in the function scope and they're in the session scope. Okay, so function scope means that every test function, okay, could have different browser context and browser page. However, all the test cases would have the same Playwright instance, browser type, browser name, and so on. So the session scope applies to all tests, while function scope applies only to the specific tests within the test function. So this means that you can have different pages opened for each different test case, right? And this is quite useful. So the first one is something that we already created manually, and this is the browser context. Now you can simply pass it as a fixture into your test. Browser context is an isolated incognito-like session within the browser instance. So every test can run into the browser and have its own browser context, which is isolated from the rest of the tests. So each browser context can have multiple pages. A page normally refers to a single tab within the browser context. So if browser context is instance of the browser, then page is something created within a specific browser context. Then the Playwright instance is the current Playwright module that we launched. The browser type is the instance of the current browser, and it provides methods to launch a specific browser instance or connect to existing one. Then browser is the specific browser instance that has been launched by Playwright, and this is usually created by the browser type .launch. And finally we have some helper fixtures here, the one that provides the browser name, the one that provides the browser channel, and booleans that are returning whether the browser is Chromium, WebKit or Firefox. Quite simple, isn't it? So those are all the Playwright fixtures that you can use, guys, within your tests. Thanks for watching, and in the next video we'll start using fixtures and I will show you how you can skip test by browser. Thanks for watching. Hi guys, and welcome back to the course. In this video we'll start our first Pytest Playwright project and I will show you how you can run specific code and skipping a particular browser. This will be done by using Pytest marker. So let's go to our Pytest project and let's actually create a new Python file, and I will call this one test_skip browser. So here for simplicity, let's write again our test case. So let's do def test YouTube and let's pass page here, and then let's do page.go to https youtube.com. Okay, let's test actually if our script is running properly. So let's do pytest, and here I will specify the file. So let's do pytest test_skip browser.py, then browser will be Chromium and we'll enable headed. So let's run that. Okay, we'll open the browser and you can see that our test is passed. Okay, so we can see that this works properly, and now I will show you how you can actually run that into many browsers. So as you can see right here, you have browser Chromium, and if you write another -- browser, let's do Firefox, and let's add another one, browser WebKit. So this means that now you're going to test your code into 3 browsers and you see if your test is going to pass there. So let's run that, and here we start the first test in Chromium, then the second one in Firefox, and finally the third one, which actually go to another window in the WebKit. But you should see all 3 of those. So as you can see, we had 3 tests at the same time, but let's see how we can actually skip one of those browsers. Now to do that, you can add a Pytest marker. So let's import Pytest. So let's do import Pytest, and so here I will do add pytest.mark.skip_browser. Okay, and let's write here Chromium. Okay, perfect. So let's run our tests again and see how many pass cases we will have and if we would have anything skipped. So let's run that. Okay, so now the rest of the tests are executing, and as you can see now we have one skipped test, and if you see here this is skipped, and as you can see here Chromium was the first browser we actually used, so it was skipped. And this is how you skip browser, guys. Now, since you can skip browser, it makes sense that at the same time you can also define the only browser that you want your test case to use. So for example, if I go back here to the Mark browser, actually let me create a new file here so you have this in different files, and let's name it test_only browser. Okay, so let's open this file, and I will just copy and paste what we already have in the skip browser. Okay, and what you need to do is simply to change this to only_browser, and if you add this marker, then Playwright will recognize that it needs to run your test only with Chromium. So let's run our test case again. The only difference that I will do here in our command line is instead of test skip browser, I will do test only browser.py. Okay, we run this with all of those 3 browsers, Chromium, Firefox and WebKit, and we will see if our test case will get executed only with Chromium. Okay, so we should see one pass test, which would be the first one, and then two skip tests. Let's run that. And you can see that exactly we're having one test that is passed, and then we have two tests that are skipped. If I run also the verbose method, then you will see a little bit more information. So you can see that the first test was passed, then we have skip for browser Firefox, and then we have skipped for browser WebKit. So if you don't know how I do that, I just wrote -v in the end, so I activate the Pytest verbose method, so I can see a little more information here. So this was everything for today, guys. This is how you can skip and use only particular browser. Thanks for watching, and in the next videos I will show you how you can record your tests and also use predefined and custom fixtures. That's it. Thank you very much for watching, and I will see you in the next video. Hi everyone, and welcome back to the course. In this video, I will show you how you can record your script and at the same time ignore HTTP errors if they have been raised. So let's first see how you can actually record the video of your work. Let's take, for example, the test-only browser test that we created right here. And here in the command line, you would need to write Pytest. Then you can specify your browser. So let's say browser, and let's do here Chromium, then do -- edit. And finally, in order to activate the video, you simply do -- video on. So you can either do video on or video off. So let's do that and see what happens. So let's hit enter here, and your test starts, and then it ends. You can see that we actually had 3 tests running because here I didn't specify which file we're using, but that's okay. So now if you go here, you can see that there is a new folder generated called test results. Let's open it, and you can see that we have 2 folders here. The first one is test only browser. Okay, so here we would have a video, and then we have the test usage, which is this one. So you can usually open these video files into your browser. So you can simply go to your folder and you will see that all of them are here. And for example, I would open them in Chrome, and let's see what happens. So you can see that when you open them here, they're pretty much 1-second videos because we just opened the page. But even if you do something more complicated with way more actions, you're gonna get longer video and you will be able to see absolutely every action that is happening on your web page. So this is how you record videos. But let's see how you can actually avoid HTTP errors. Well, this is done by using fixtures. So normally, to use fixtures in Pytest and Playwright, you will need to create a new file called conftest.py. So let's do Python file conftest.py. Let's create it. And here you can place all the fixtures that you want to run while you're executing your tests. So first of all, let's import Pytest. And then in order to create a fixture, you need to write pytest.fixture. And then you can define the scope of the fixture. As you remember, there were 2 types of scope, which was the function scope and the session scope. The session scope are the fixtures that are working with all the tests while you're running your test cases. So here you can define the scope by scope equals session. Okay, and let's do def, and I write browser context args, and here you can pass the parameter browser context args and then return from this function. Okay, so let's return browser context args, and also we'll return ignore HTTP errors. Actually, here this has to be in parentheses. So ignore HTTP errors will be true. Okay, so this is how, guys, you're avoiding HTTP errors. And so your test will never fail due to those errors. Actually, there is only one typo that we did here. There should be HTTPS errors instead of HTTP errors. And now, if you run your tests, you actually not see anything visually. But now, if there is any error while you're opening the page or while you are sending some of the requests, those now will be ignored. That's it. Thank you very much for watching, guys. And in the next video, we'll continue exploring the different type of fixtures that you can create manually. But there you will see some more visual representation about how those function works. That's it. Thank you very much for watching, and I will see you in the next video. Hi guys, and welcome back to the course. In this video, we will talk about the different view sizes that you can set with Playwright. So you don't always want to test your script or your web page in the same resolution. In many cases, you want to try out different resolutions, and sometimes if you're creating your page specifically for tablet or phone, you really want it to have absolutely the best structure when displayed on those devices. So today, we will start by teaching you how to select the specific resolution for your web application to open. And also in the next video, I will show you how you can do that by selecting a specific device. So let's get started. You again need to create a fixture here, and I'll actually comment out this HTTP errors fixture so it doesn't affect our tests. And I'll create a new one. So let's do pytest.fixture scope equals to session. Okay, and now let's define the function. So let's do def browser context page. Okay, and this will control our browser context page. So let's pass here browser context args. And so this function would return firstly the browser context args, which means what we see on the browser. So let's do browser context args. And then we will need to specify the viewport, right? So in Playwright, you have something called viewport, which basically defines what is your resolution. So if you simply write viewport, okay, and then you do a curly bracket, and here inside you can define width, okay, and let's do the width 1920 by height 1080p, okay, and we're done. This is all you need to do in order to define the resolution. So let's now save this file and let's run one of our tests. So let's run the test usage.py. So let's do pytest, then let's do test usage.py. Let's define the browser Chromium, and then let's do headed. Okay. So when we run that, the page that appears here is exactly 1080p. So let's actually see if it's gonna work changing of that resolution. For example, let's do it 400 by 400 so we can see a significant difference. So let's save that. And also I noticed that actually we haven't named our function properly. And since we're updating here a predefined function, we want to use the correct name. So let's, instead of page, use args here. Okay, browser context args. Okay, so let's save that and let's run again with the slow-mo parameters so we can have a little more time for displaying the page. So do pytest test usage browser Chromium headed slow-mo 3000 milliseconds, which is exactly 3 seconds. And then if this fixture activates, we should see our page quite small, 400 by 400. So let's run that and you can see that our page appeared on the resolution that we selected. So we went to youtube.com. That was 400 by 400. So this is how, guys, you're selecting the specific resolution with which you want to run your test by writing this conf test fixture here, and then this applies to all the tests in your suite, in your test suite. So that's it. Thank you very much for watching, and bear with me in the next video because there I will show you how you can use a specific device. Hi guys, and welcome back to the course. In today's video, we will talk how we can run our test cases on a specific device, and I will teach you how you can apply that for all of your test suite. So let's actually comment out this function by pressing Ctrl/, and after that I will create a new function. And this function will actually have the same name as the previous one, browser context args, but there we'll specify a device. And for this video, I chose to specify iPhone 11. So let's say you want to run your script on iPhone 11. I will show you how you can specify exactly this device to make sure that your script works there properly. So let's do pytest.fixture, and then let's define the scope session. And so let's create our function. So let's do def browser context args. Okay, and here we will pass the browser context args and also Playwright. Okay, so firstly let's define our device. Let's write iPhone 11 equals to playwright.devices, and from the Playwright device you can choose iPhone 11 Pro. Actually here we need the brackets because this is simply a variable in dictionary. I will show you. Actually, if you select control and then the devices, you can go here and you can see here the actual function, right? So here we define the iPhone 11 Pro, and now let's do return, and you can simply write browser context args, and then you can place iPhone 11, okay, the device that we just defined. And now if you save that and you run your script, you should be able to run your web page on iPhone 11 Pro, resolution. So let's run that and see what happens. Okay, so this is the iPhone 11 resolution, and you can see it looks exactly like a smartphone. Let's run it again actually for 10 seconds so you can see better. Okay, so this would be the same if you would run your function on iPhone 11 Pro or run it right here. It doesn't matter. So this is how you can pretty much define absolutely every device that you want to have a good user experience and test on different devices. That's it. Thank you very much for watching, guys, and I will see you in our next video. Hi guys, and welcome back to the course. In this video I will show you how you can specify the browser context. Now, if you don't know by now, the browser context is basically how your browser is set up when your web page appears. So you could have many different parameters there, and for that reason it is reasonable to create a fixture defining those. And I mean parameters such as the language, whether you want another tab to be opened as well, those things. So let's comment out the fixture that we created in the previous video, and now we'll create a new one. So let's do pytest.fixture and let's do scope equals to session. And in order to change the context, you will need to create a function that is called context. Okay, and to this function we're going to pass a few parameters. So the first one would be the browser type. Okay, and here we use the browser type class, browser type. So you can see that there is an error here, but you can import this from Playright. So let's do Playright sync API browser type. Okay, and you can see that we imported it here, and you can check actually what it is. This is pretty much the function that defines it. Okay, then let's do browser type launch arguments, and this will be a dict. Okay, we use a class dict here, and let's import that too from typing. Okay, so we have this import here, and finally let's do browser context args, and this will also be of a class dict. Okay, great. Okay, so let's close our function. So basically those are the arguments that we are passing to the function, right? And now we can start writing the actual function. So let's first update our context. So let's write context equals to browser type actually. Okay, dot launch persistent context right here. Okay, and now you simply need to define the arguments for launching this persistent context. So firstly, let's select the first argument. Actually, it doesn't matter what you write here. Let's do bar. Okay, then let's add the rest of the arguments. So the first one would be browser type launch args. Okay, then you can add the context arguments. Okay, and finally, if you want to change the language, for example, of the page, you can do local. And for the language, let's use German. So DE-DE. Okay. And so this is how you define the context. So now let's run the context, and you can do that by doing yield context, and then let's do context.close. Okay, so what it will happen here is you define the context, then with the yield keyword you run the test with the context, and after your test is completed, then you close the context right here. Okay, so this is the function. Let me actually put it in full so you can see. Okay, make sure that you remove the rest of the functions here. So let's save that, and let's run our test with slow motion of 5 seconds. Right, let's run it and see what happens. So you can see that we're going to YouTube, and it's in German. And also you have another page right here. Let me run it again. So obviously here we're in Dutch, as you can see, and we made sure that we open our page too. So this is how, guys, you can define a specific way that you want your browser to appear. So this is quite useful if you want to test different scenarios of your browser and you want to apply it to all of your tests. And trust me, this is a very useful feature among with the rest of the fixtures that I mentioned to you that you could apply to the real life testing. Of course, in the next sections, we're going to get a little more practical on the test perspective, but I want you to always be aware of the ways and the fixtures with which you can run your test. That's it. Thank you very much for watching, and I will see you in the next video. Hi everyone, and welcome back to the course. Today we will talk about how to define test cases using the unit test case class. So to do that, today I will create a test that is going to microsoft.com and selects something there. Okay, I will also show you how you can do assertions so you can validate whether your test case passed correctly or not. So firstly, I will comment out everything in the conf.test.py so our test cases are not affected, and let's create a new file here, new Python, and let's do test unit. Okay, so here we can create our new test case. Now firstly, let's import Playright. So let's do from Playright.sync API import page. Okay, and let's create a class a test class. So let's do a class my test, and then let's do unit test dot test case. Okay, so this to this class we will pass test case from unit test, which is a predefined class for testing code. Okay, and after that, let's first create here a fixture, and I will explain you why we do that. So pytest dot fixture, and let's do auto use true. Okay, so this fixture, unlike the fixtures from the conftest.py, is going to work only on this file. And when you select auto use equal to true, this means that this fixture will be applicable to all the test functions in the file without the need to pass it to a specific test function. So let's do def. So here's how we're going to define the fixture, and I will do set up. So basically we'll do this fixture, we use it to set up our test. So let's do page, okay, and then self.page equals to page. So here we define page for every test case, right? So from every test that we write from here below within the class, you'll be able to use this page parameter, okay? So let's do now def test full bar, and let's do self since we're in a class, and then let's do self.page. Right? So basically this fixture acts as an initialization, right? So now we can use this page that's in the fixture, and let's do dot go to, and let's go to https microsoft.com, and then let's perform some action. So let's do page dot actually self.page dot locator, and now I'm gonna place something that I got from our code generator. So there is a button on this page that you can click, and here I will pass the exact location of that button. So here it is, and this is basically the button that selects the information for the new Microsoft laptop, the Surface Pro 8. But feel free to go, for example, on the code generator. Let's say if you write Playright code gen, and then if you write microsoft.com, you will be able to actually do any type of locator, and I will show you how this is done. So here we are on the microsoft.com, as you can see, and for example, if I select the shop now button right here, you will see that a new code is generated, and you can pretty much use that, right? Even if the page changes, you can simply go and select some of the buttons, so you can actually get some valid code that can be tested. So you can, for example, copy this and then place it here in order for this button to be automatically selected. And I'm giving you this information because, of course, the things on the websites constantly change. So I don't want you to be affected from that and to be able to generate it by yourself. So after we located the code, let's do dot click. Okay, so we're clicking on this location right here. And after that, in order to end the function, let's do some assertion. So let's do self.page.evaluate, and let's, for example, evaluate 1 plus 1, okay, just so we have some assertion in the end, and let's make sure that it's equal to 2. Okay, so let's save that, and so now we can test our test case. So if I do pytest test unit.py browser chromium --edit, and let's also do slow mo slow mo of 10 seconds. Okay, let's run that, and you can see that we have the page, and we have that for 10 seconds, and after that the button will be selected after this time passes. Okay, now we selected the button, and now we're going to wait 10 more seconds until this step is completed, and then our test will finally end after 10 seconds pass. So it should be close to now. Okay, you can see that the test passed. It was 36 seconds, and it didn't fail since the assertion was also validated. So this is how you can use the test case class, guys, in order to create firstly a fixture, generate your page, then use your page to go to microsoft.com, and after that perform certain actions. You can have a huge list of actions right here, and then you can do the assertions. Of course, if I do here 1 plus 1 equals 5, let's say, and let's run that now for just 1 second per stage, so we're a bit faster. Here we go to the page, and then we select the button, and once we do that, then the test case would end, and it will fail since 2 is not equal to 5, right? So this is how we do assertions in the end. I will leave that equal to 2 so you can have it for your record. And this is how you're using unit test case in order to create Playwright automation. Thanks for watching. Hi guys, and welcome back to the course. In this video, I will show you how you can debug your script and also add from the command line some additional commands while you're running your test file. So let's create a new file and do Python file, and let's call that test debug. Okay, So let's create here a new function. So let's do def test and let's call it test Bing, because here we're going to go to bing.com. Of course, since Playwright is made by Microsoft, this is why we're trying to go to their pages. So let's do page, comma, okay. So let's leave page here and then let's do page dot go to, and then let's do https://bing.com, and then in order to run the debugger, let's do breakpoint. This is pretty much going to launch the PDB debugger, so you can add additional commands here, okay? So let's run our test. I will use the same command like the last time. The only difference I will make is I will change the test. So let's do test debug, and also I remove the slow mo since we're going to stop anyways when we're in our debug mode. So you simply need to run pytest testdebug.py, specify the browser and run the headed command. So let's do that, and you can see that now your page appears right here, but it's not removed. And if I actually move the page on the left hand side, you can see that here we have our PDB controller, right? So let's display both of them. And here you can actually pass some commands to run on the website. So let's do, for example, page.locator, and let's do input name equals /q/ okay, let's close the bracket, dot click. Yes, and I did some typo here, so probably you'll get error as well. So this parenthesis should be before q. Okay, so if I run it, you will see that immediately something appeared on the page, and this actually automatically selected the search of bing.com, right? So this is how you can pass commands and see how they execute. And if they execute good, you can then place it in your code. This is a very good way to real-time debug your script and see if you add some additional lines of code, how it would work out. And then simply if you want to close the debugger, you can write here close or actually exit, and then you exited the debugger, right? So this is how it works, guys. You can always write the breakpoint keyword if you want to activate the debugger. So that was everything from this section actually. These were all the key tools that are interexchanged between Pytest and Playwright. Thanks for watching, and in the next videos we're going to start exploring the key Playwright functionalities, and we will start with the actual testing. Thanks for watching. Hi everyone, and welcome back to these sections where we're gonna explore the most useful Playwright methods for API testing, browsers and assertion. But the first method about which I would like to talk today is the Autowaiting. So as Playwright is an advanced testing tool, it performs constantly checks of the elements before making actions to ensure that those actions behave as expected. It has an option called Autowait or Autowaiting all the relevant checks to pass, and only then performs the requested action. If, however, the required checks do not actually pass within a given timeout, the tests fail with timeout error. And I bring you some example here for you on this slide. This is the example with the page check method. So when running, let's say, the page check method, Playwright will check all those 5 elements before enabling the element in the final step. So it will ensure that the element is attached, that the element is visible, that the element is stable, and there is not animation. It will ensure that the element receives different events, and finally, it will check whether the element is actually enabled or not. So all those checks are performed for different type of tests, and actually here I just gave you a sample in the next table from those actions and what is available for each of those. So here on the top, as you can see, I placed all the different categories, and depending on the action, we're performing some of those steps and some of those who are not performing. For example, for the hover, we do not check whether the element is enabled or not, but we check for the other 4 options. So there are some type of actions that support the force command. And for example, the page.check actually supports the force command. But what the force command means? So the force command means that if some of those checks that I just mentioned to you is not met or do not pass, you can actually add the force parameter in order to still make the test possible. And for example, if you use that on page check, the method will not actually check that the target element actually receives the click events, right? So you can pretty much play with those checks, and of course I advise you to use them all the time, but in case you feel the need in unlikely events that you don't need to use those, you can definitely disable them for some actions. So before ending this presentation, let's actually talk about what each of those keywords here mean. So for example, attached, it is an element that is connected to a document. Visible, for example, this element has non-empty bounding box and its visibility is not hidden. So let's say if you have an element that has display set to none, then this check here would fail. A stable element is an element that has maintained the same bounding box for at least 2 consecutive animation frames. And then enabled element is considered an element that does not have disabled property, and this includes buttons, selectors, inputs, and text area. So this was the end of our first video, guys. That was an easy one without too much coding. Bear with me in the next one where we're going to start the real deal with API testing. Thanks for watching. Hi everyone and welcome back to the course. Let's create our new PyCharm projects where we're going to start with creating API tests. So let's go to PyCharm, and let's create a new project, and I will place it on desktop since it's easier. Let's create a new folder and I will call this Playwright Guide. Okay, so here we're going to create all the test cases from this section and the next one. Okay, we're again going to use Python 3.10. So let's create. Perfect. And the very first thing that we need to do is just make sure that you have installed Playwright inside and Pytest. So let's do pipe install Pytest. Then let's do pipe install Playwright. Okay, so we have collected Playwright. Then let's do Playwright install. And finally, let's install the Pytest Playwright plugin. So I will do pipe install Pytest-Playwright. Okay, so everything is collected now in your virtual environment, and as you can see, if I go here into the packages, you can find Pytest and Playwright. So we are ready to go. So in this video, I will show you how you can access the GitHub API, create a repository, create a few requests on this repository, and then delete it. I will also show you how to create different issues in your repository. But before that, let's go to GitHub and see how we can do that. So here I am in github.com, and in order for you to access your GitHub account, you first need to create a token in order for your code to be able to access GitHub. So this is very simple. Just click here and then select settings. And from there, you can go to developer settings right here and then select personal access token. Okay, so here you can generate a new token and you will need to write your password in order to do that. So let's name this token Playwright, and I will select the expiration in 7 days, although you can choose as much days as you like, and then you can select what access you would like your token to have, right? So I will select all of those options so I don't face any issues, and I advise you to really make your token valid as low time as possible in order to expire quicker, so once you're ready with those tests, nobody else can access your repository. So let's create the token, and as you can see, this is my token right here. Save that information because later on I will show you how you can use it in the script. So if you go back to PyCharm, let's create a new file. Let's create Python file, and I will call this file API. Actually, let's do test API. Okay. So the very first thing what we'll need to do is to define our username variable, our token, and our repository name, so the name of the repository that we would need to create. So to do that, firstly import Pytest, and after that, let's do from playwright.sync API, and from here we're going to import Playwright page, okay, then API context, and finally expect. Okay, so once you have all those classes passed, now you can first create your token. So let's do GitHub underscore API underscore token equals, and here in the string form you can simply copy and paste your token. So let me copy it and paste it right here, and later on in the code, everywhere where it refers to GitHub API token, we can use that token here. Then let's do assert just to verify that the token is set correctly. So assert GitHub API token, and if that fails, we would return a message something like GitHub API token is not set. Okay, and let's do a variable that defines the GitHub username. So let's do GitHub underscore user, and here you simply need to write your username. Mine is Martin Yanev 94. Okay, and finally let's assert GitHub user And if that fails, if there is no GitHub user for some reason, then I will write GitHub user is not set, okay? And there is one last thing that we will need to do, and this is to set the name of the GitHub repository. So let's do GitHub repo equals, let's name it actually test API, okay? So this is the repository that we would like to create. So here we're simply defining or initializing the main parameters. So I will name this initialize, okay? And after that, let's do Pytest dot fixture, and here I will create a fixture with which we will generate the API context, and with this fixture, before every test, we're going to send our token to GitHub in order to assess our repository, right? So obviously, since you want to assess your account before every test, you add this into the fixture. So I will show you how this works. Let's first create scope, and scope will be session. Okay, and then we're gonna define our fixture. So let's do API request context, okay, and here we can do playwright, okay. So now here we define function, and here we're passing parameters, right? So we pass the playwright class right here to our parameter playwright. We'll go to the function, okay, and let's define what this function will actually return. So it will return generator, and we need to import this. So let's import from typing, okay, and here I will do API request context, then none and none. Okay, so we generated this list, and it has a class API request context where we're gonna request the information from the API. Okay, so after this is done, let's write headers, and this is gonna be a parameter. So basically we decide what we will pass here. So headers would be equal to actually two elements, and the first element is going to code accept, and this is pretty much defined in the GitHub guidelines. So in the accept, you need to write application slash vnd.github.v3 plus JSON. So here we're basically defining what portion of Git we're accessing and the file type, which is JSON. And after that, the next element is going to be our authentication token. So let's do authentication, okay. And here what we're going to pass is actually the authentication token. So let's write token, and then here I will pass the actual variable GitHub API token. So let's do GitHub API token here, okay. And this is how you're passing both of those parameters, the accept and the authentication, to GitHub, which is what its API expects. Okay, perfect. And after that, let's request the context. So let's do request underscore context, and this will be equal to playwright dot request dot new context. And here's where we actually create a new context of our browser, or basically this will be a new window where we're gonna see the GitHub API. Okay, so let's write here the base URL. Okay, base URL will be equal to https api.github.com, right? And then let's do extra HTTP headers. So this is a predefined parameter, and let's write here headers, which is our headers that we set here. So this whole thing, this parameter, we're passing it to the extra HTTP headers. And if I click on it, if I press Control and click on it, you see that this is basically an optional parameter when creating a new context. So you can create it in order to pass some optional parameters there, which are our token and our location. So for GitHub, of course, this is necessary. This is why we need to pass this header. Okay. After that, we will write the keyword EOT, and this means that EOT is going to transfer the control over the test case. So this means that all this here is going to be executed before the test case, and everything after EOT is going to be executed after the test case. So let's do request context, and then let's do request context dot dispose. Okay, and the dispose function, of course, is going to be called after every test. Okay, so basically this is our fixture, guys, for assessing the GitHub API. Now, we are going to create another fixture with which we're going to create a test repository, right? So we can actually run that fixture in our test cases. So let's do that. So let's create a new pytest.fixture, and here I'm gonna add scope would be again equal to session, and then we're going to add auto use here equal to true, which means that this fixture will pass to every function and we don't need to specify that. Okay, so let's create the fixture and let's call it create test repo. Okay, so let's first do and pass here API request context, and we're gonna pass it as API request context class. Okay, and after that we will expect here an output that is generator, and it will be none, none, and none. Okay, so before every test case we would like, of course, to create a new repository, right? And after every test case we would like to delete it so we don't leave anything in GitHub. So let's do new underscore repo. It will be equal to API request context dot, and here we will use the post method, which is something specific for the APIs, and here we can specify where we want to actually post. So we want to post in user repos. So here we're assessing the place where we create repositories, and then let's do data equal, and here we're gonna pass the name of the new repository. So it's very simple, guys. You simply need to do name colon, and here I will pass the GitHub repo parameter, which is going to be the name of our new repository that we wanted to have. Okay, and after that let's make sure that we actually created it. So you can simply do assert new repo dot okay, right? So this is how we're checking the status if this is created, and after that we will run the test case. Since we created the repository already, we can run the test case, and after the yield keyword we can delete it. So this is very simple as well. So let's create a parameter called delete underscore repo equals to API request context dot delete, and this will be done from repos. Okay, then we need to assess the username, so GitHub user. Okay, and after that let's assess the repository, so it will be GitHub repo. Okay, so basically here before the repos we're passing api.github.com/repos GitHub user and the repository. Pretty simple. And finally, once the repository is deleted, let's assert or check whether the deletion is completed. So let's do deleted repo dot okay. Okay, let's save that, and also here we need to write a column, so this is all set. Okay, so these are the two fixtures that we created, one for creating repository and one for creating the actual browser or the context, and also the initialized parameters. I think this is enough for today, guys. I'm not gonna go to writing the test cases in this video as it is already very long. Thanks for watching, and in the next video I will show you how you can run two test cases for testing the API. Thanks for watching. Hi everyone, and welcome back to the course. In this video, I will show you how to create all the test cases for our API project. So as you remember, in the last video, we already created the variables that are holding our GitHub API token, our username, and the repository that we wish to create. Also, we created two fixtures, one of them for creating our browser context and entering the API of GitHub, and the other fixture for creating a test repository. So now I'm gonna create two test cases. One of them will actually test if you can create a bug report, and the other one if you can create a feature request. So if you're familiar with repositories, there they hold some code, and if you want to raise an issue for the code that is within that repository, you can raise a bug or add additional features. So let's do our first test, and let's do here DEF, and I'm gonna name that test bug report, and here I will pass the API request context, which is the API request context. Okay, the same as how we did it here. And this function will return nothing, so I will do return none. This is not something compulsory, but it is good to know from the header of the function what are the parameters that we pass and also what it returns. So let's first create a new variable called data. And data would be a dictionary that basically holds the name of the title and the description of the bug that we're going to raise. So let's create here title, okay, and the title will be bug report 1, okay, and after that let's write the body. So let's do body, let's add some parentheses here. Okay, so the body will be bug description. Okay, that's it. So once we have the data, let's now create a new issue. So let's do new issue. Of course, you can name this parameter how you like, but it's more descriptive if we name it as the data that we're going to pass inside. So this will be the variable that will actually create a new issue or a new bug into our repository. So I will do API request context dot post, and here let's select the path to the issue creation page. So this will be in repos, then our GitHub user, then it is the GitHub repository, and finally we'll assess the page issues. Okay, and then we'll do data inside would be equal to data. Okay, so what we are basically doing, we're going to this link, which is the link for creation issues in GitHub, and then we're passing our data dictionary there in order to create a bug. Okay, so here we close the bracket, and then what we're going to do in the end, we're going to do assert new issue dot okay, and this will verify that the test will pass if a new issue was created, and it will fail if a new issue was not created. Okay, so now the next thing that we would need to do, since we post our issue, now we would like to get it. So let's do issues equals API request context dot get, and here we're basically going to pass exactly the same folder. I will save some time by copying it. Okay, and then we will assert that issues was successfully created dot okay, and then what I'm gonna do here is I will do issues underscore response. So what we're basically doing, guys, is we're creating a new issue with our post request, we're getting it with our get request, and then we're going to convert it into JSON and assign it to issues response. So I will do issues dot JSON, that's it, and then let's do another variable called issue, and this will be equal to a list. Okay, and let's do filter here and add a lambda expression. So let's do lambda issue, and then issue title equals to bug report 1, comma, and then let's write issue response. So here we're doing lambda expression to filter our issues for the one that is equal to bug report 1, right? The one that we just created here. Okay, and after we found it, we are going to assign it to our issue here. This is why we take the 0 element. So what we're basically doing here is we're creating a list of all the issues that start with bug report 1, and then from that list we take the first element. Okay, and this is how we're gonna have the exact issue assigned to the variable issue. Then we're gonna do assert issue, and also we'll make sure that the body of the issue is with the same description as we wrote. So let's do assert issue body to be equal to bug description. Okay, so that's the first test case, guys. Here's how we're creating a bug report quite easily using the API request context and using the API features of Playwright. Okay, also here I noticed that I did one minor mistake. So here instead of authentication, it's actually authorization. Okay, where we pass the GitHub API token into our API request context function, and also down here where we assess the repos, we also need to have a backslash here and right here as well. Okay, so that looks good. Let's now create the other test case, and then we're going to test both test cases using Playwright and Pytest. So let's write here def test underscore feature, and here again I'm going to pass API request context and then API request context, and this function will also return none. Okay, and then let's do again data equals, and here we're going to again write title and body. Okay, so here the title is going to be equal to feature request 1, while the body is going to be equal to feature description. Okay, so this is going to be our dictionary that we will pass to our post method. So let's do new issue equals, and you can just copy and paste actually what you've already created here. Okay, this is the one, because there is almost no difference, since creating bug and feature is done exactly in the same way. They would just have different titles. So this is also created in issues section right here. Then let's do the assertion. So let's do assert new issue dot okay, and then I will just copy and paste the issues and the issue response, because those are going to be exactly the same and I don't want to make you waste your time. Okay, and the only difference will be here where we created the issue, that what we want to do is again of course to create a list, but here in the lambda expression we'll search for different parameters. So let's do filter lambda and then issue in issue title. So we search for everything that has in its name feature request 1. So let's copy that, and this is how we make sure that the exact feature that has been created is the one that we set it up. So let's do issues response. Good. Okay, and here we'll just use the first element into that list, which will be our issue. Okay, so let's now assert issue and then again assert. So now we're gonna check the body. So issue body to be equal to feature description. Okay, so now with those assertions, guys, even without you seeing anything visually, you can actually make sure that you created a new bug and a new feature by using those assertions here. Okay, so let's run our test cases and see what happens. So let's write pytest test API -- edit. So let's see what's gonna happen here. Okay, as you can see, the first test passed and the second test passed as well, right? Because we have two dots here. So this means that we successfully created a repository, we added two tests there, and then we added actually one feature and one bug inside of the repository, and then we deleted the repository. So if you would like to actually verify that your tests and your repository has been created successfully, you can simply go to the fixture here where we actually create the repository, and you can simply remove this last statement here, delete repo. So let's save that. And for example, if I go to my GitHub account, right? So if I go to my GitHub account, as you can see, we don't have any repository named test API as the one we created, and this is because we're deleting the repository every time after we were creating it. So let's run the test without the delete command, and let's see if we're going to get a new repository. So let's do pytest test API. Okay, and remember we commented out the delete statement here. So let's run this and let's see what happened. Yes, we can see the first test is passed and the second one is passed here. So now if I refresh, you'll see that there are a few very interesting things happening. So firstly, we have in recent activity a feature request, right, created today, and as you can see, we have also this new repository test API. So we have the feature and we have the bug that we just created, and you can see that feature has feature description, while if I go to the bug, it has the bug description that we wrote. So this is how you can add features and bugs automatically. And for example, if I want to go to the repository, you can see that this is a perfectly valid Git repository. So this means that those tests successfully created a repository test API and created two issues inside, as you can see. So let's say if you are assigned with a task to test the GitHub web page and API, then you can definitely use those two tests to exercise how issues are created and repository is created as well automatically. So this was everything from our API lesson, guys. We wrote quite a few lines of code today, but I'm sure that this was worth it, because if you can apply this to GitHub, you can basically do it to any other web page. That's it. Thank you very much for watching, and I will see you in our next. Hi everyone, and welcome back to the course. In this video we'll talk about one of the important topics when doing automation testing, and this is the assertions. And in more detail, we're going to talk how assertions are actually executed. And so as I was saying, I will provide you with the full guide on how you can do assertions, which means testing different elements in your automation testing. So firstly, let's create a new Python file, and I'll call it test assertions. Okay, so here we're going to write two test cases that are going to exercise the assertions. Now I want you to know that the list of different types of assertions covered in Playright is quite long, so we will not cover absolutely every type of assertion that you can see, but once I show you those two test cases, you pretty much get the idea and be able to use all of them. So firstly, I will just show you how many assertions they are, and I will provide them to you into this file. So let's talk about what assertions are and what this actually means that you can see here. Basically, these guidelines here would normally show you how you can take the element from your web page or API that you want to perform tests on, and then you will be able to define what exact test you want to perform and how many arguments you want to pass. If you want to if you see here EW args, this means that you can run this test without passing any arguments. If however you see something like expected or value or name, this means that you need to assign certain values or variables, actually values, to those variables here, right, in order to run this test. So those are all of them, and I will leave them here so you basically have access to all of them. And let's create our test cases. So firstly, we will go to a page, press a button and check if that button is submitted. So let me show you how this is done. Now let's do def test submitted, and here we're going to pass the predefined fixture page, right, which comes from the class page. Okay, and as you can see, this is not recognized because we need to import Playwright. So let's import Playwright sync API page. Okay, and then this function would return nothing, so I'll write here none. Okay, so firstly let's go to a page. For example, let's do go to, and I'll go to google.com. So let's do https, okay, www.google.com, and then I want to locate a certain button, click on it and verify that this button have the text that it actually has. So let's go to google.com actually and see with which button we can do that. So here I am in google.com. So let's say we would want to go to settings, and let's say select the search settings here. Okay, so let's try to do that and verify that this button here has a text search settings. So how we can do that? Well, the first thing is that we would like to select the settings button. In order for you to find out how your code can select the settings button, you can simply go to the terminal and write code gen google.com, actually Playwright code gen. Okay, and now we're gonna go to google.com, select that button and verify that we get what we expect. Okay, so we can see that when we open this, here is our code generation tool, while here is the page. So let's actually select the settings button, and you can see how it's called immediately when I place my cursor on it. So let's select it, and then here you can see that we can refer the search settings by the text equals search settings. Okay, so that's great. This is actually everything we need. Now we have here the page locator in order to click on the button. So what you simply need to do is to copy this, paste it here, and we have here .click. So what the software will do is it will basically locate the settings button, and with .click it will actually click it. Okay, and after that we need to check if there's a button with text search settings. So to do that, let's see what option we can use. So we can use here the option to have text, and here as you can see we need to provide something, and this is the expected text, right? So let's do that. Now after the locator, so after we clicked the settings button, we would want to check that. So let's do expect, okay, and let's do page.locator. Okay, so now we need to locate the button, and as you remember, the button was named text equals search settings. Okay, so this is how we find the button. And actually let's also import the expect. We're going to import it from Playwright sync API. Okay, and let's do here now dot, and you can see all the different options here with their documentation, so you can definitely refer to the options from the PyCharm IDE as well. So now we search for the method to have text, which is this one. So let's select it, to have text, and then we can make sure that it has a text search settings. Okay, and this is basically the assertion in Playwright that you need to do. This is the only thing you need to do in order to verify that a button has a particular text. So let's run that and let's see how it works. Actually, let me first close the code generation tool. Okay, so let's close that, and let's close the browser to free the terminal. And here you can simply write pytest, then test assertions -- edit, so we can see, and then let's do slow mo so we can see how the actions are performed. So I will do slow mo 4000 seconds. Okay, let's do that. So you can see that now a page appears. We're selecting the settings, and from here we're going to verify the assertion right here. Okay, so another thing, if you have the window a bit bigger, so more big than you expect, for example, you can see here how big my window is, you can add a fixture to reduce the size of the window so it's easier for you. We actually already had this lesson, so I'm just gonna do it right here, and I will do onf test.py. Okay, and here I will just place a fixture with resizing the window. I will do it 1080p on 720p. Okay, and I will also import Pytest to avoid any errors. Okay, and now once you have that, actually 1280. So once you have that update of the browser context, when you actually run your code, you will see that the window will be smaller, so you can see the settings better. Actually, I will make it even smaller than this. Actually 1280, I think it should be fine. So if you want, play this fixture in order to reduce the size of your screen, but it is not compulsory. So this is how, guys, you are actually doing the assertions to check for a text. Now another test that we can actually try is to check whether a page is visible or not. So let's say if I go again to google.com, we can check if this button terms is visible or not. Obviously it is visible because we can see it, but how do we automate that? So let's close the window, and I will do a similar thing here. So let's create another function, and let's call it test visible, and here I will pass page, and then this function will again return none. Okay, so let's again go page dot go to https google.com, and then I will copy and paste the locator settings, which you actually not necessarily need to do. But for example, let's say you want to check if once the settings button is clicked, if the rest of the buttons are still visible. So here, after you click the settings button, you can do expect page dot locator text equals to terms, and let's see the appropriate function here. So let's look for to be visible. Okay, as you can see, this is one right here, and here, as you can see, you don't need to pass any parameters because a button is either visible or not. You don't compare it with anything, so you can simply do dot is, or actually to be visible, right? So let's save that, and let's run now both of those tests, and you will see how they will be executed one after another. So let's do that. Now our first test is executed, so we're going to press now the settings button, right? And we'll verify the settings. Then we're going to open the browser again, and we'll simply verify that we have the terms button right here in the bottom. Okay, so now the browser will close, and you will see that there are two tests that have passed successfully. So this is how you're doing assertions without the assert keyword, and you're actually using the expect playwright assertions. Thanks for watching, and I definitely advise you to explore the rest of the expect assertions in Playwright, so you can definitely generate code with the code gen and then test it using those expect assertions. So that's it. Thank you very much for watching, guys, and I will see you in our next video. Hi everyone, and welcome back to the course. There is not only one operation that can be done using automation and when going to a web page. So as you know, in those next sections I will try to explore absolutely every possible scenario when doing test automation with Playwright. And one of the very common situations is where you're trying to log in to your account. So let's see how we can automate that. So you can see that here I'm into the GitHub login page, and now let's say we have the scenario where we want to actually write test case where a user is logging into his account, which means he's writing his email address, password, submitting the request, and we also need to state what we expect to see after that, right? So in GitHub, normally the workflow is the following. Firstly, you're into your login page, then you write your username and password, and then you submit sign in, and after that you're redirected to github.com page without the login statement. Okay, so this is all the actions we need to complete in order to be able to log in. So let me show you how this is done. Let's go back to our PyCharm IDE, and I will create another Python file which will be called test authentication. So let's see how easy actually is to test the authentication settings using Playwright. So I will create here a new test case. So let's do test out, and I will pass the page class right here. Okay, so now with this page class we can actually access the login page of GitHub. So what you simply need to do is to write page.goto, and then let's write https github.com/login. Okay, so now you're on the GitHub login page, and after that you will need to provide your username and password. So let's do page.locator, and now you need to locate the login field, right? So you can either get that field from the code gen, or you can simply use the inspector on your browser. Both ways work. Let's do this from the code gen. So what I want to do here is to simply do playwright code gen github.com/login. Okay, so let's go there, And you will see, guys, that we have here the GitHub login page, okay, and also our code gen tool. So let's say if I click on this field, you can see that a new code is generated with the click tag right here. Of course, we're not going to click on this field, but we're simply going to write our username there, okay, and then we actually need to click on the password field, okay. So after I clicked, you can see that now you have the password field, and then you need to fill it with your password. So let's copy those two lines here. Let's close the window. I will delete this line and simply place those two. So now here we clicked on the login page where we need to provide the username, and then we need to do page.locator. Okay, so we clicked on the field and now we will need to fill it. Okay, let's do fill, and here in the brackets you can provide your username. So my username is martinyanev94. Okay, and after that you're gonna click on the password and then you provide your password. So let's do fill, and here is gonna be your password. I'm not gonna write mine right here, but you need to write yours instead. Okay, you need to write the exact password to send to the web page. Then you would need to click the sign in button. So let's do page.locator, and we need to locate the sign in button. You can do this from the code gen. I actually already know how this button is named, so I will simply copy and paste it. But if you don't know it, you can exercise using the code gen for that. And then we will simply need to click this button. Okay, let's do click, and this means that we submitted our request for getting authenticated for GitHub. And so if our authentication request is successful, then we should land to the github.com page. So how we can check that is by writing page.wait for URL, and we're gonna wait for https github.com. Okay, so if we see that page, this means that all operations are performed successfully and we logged in successfully. Okay, so once the code is ready, let's run our test from the terminal. So let's do pytest test authentication, edit, and let's do the slow-mo of 3 seconds so we can see every action. So let's run that, and you can see that we entered github.com, and now in 3 seconds we're gonna have my username there right here, and then we're gonna have our password also inserted, as you can see. Now the sign in button will be clicked, and then we will go to github.com. Since we're there, now we're gonna check if we're in github.com, and once we verify that we're there, the test is going to pass. So as you can see, this test actually passed successfully, and if you had any issues with failing tests, because I did, I actually missed this slash right here. Okay, so initially didn't recognize that we are going to github.com. So make sure you place it there. But as you can see, it is pretty simple to do the login into a web page. So if you want to test the login functionality of absolutely every test case, or actually absolutely every web page, you can definitely do it with Playwright now. That's it. Thank you very much for watching, guys, and I will see you in the next video. Hi guys, in this video we'll talk about the browser context. Now, I mentioned browser context many times and we also used it quite a lot, but we never actually dig a little bit more inside and see exactly what it is. So today I'm gonna describe this to you and I'm gonna show it to you visually. Browser context is basically an instance of a browser. You can run, for example, multiple browser contexts which will appear on different windows with the same or different test cases. So if, for example, you want to run your script within different browser contexts, let's say one browser context would be with one resolution and one type of language, while another context of the same browser would be with different language and different resolution, right? So you definitely would like to explore that. So let me show you how to create a single and then multiple browser context within the same test. So let's create a new Python file here, and I will name it test context. Okay, so let's write here from playwright.sync API import sync playwright. Okay, so we're not going to use Pytest here. Instead, I'm just gonna create a simple with us methods with different browser contexts. So let me show you how it's done. Let's do with sync playwright as p, and let's first add our device, or by device I mean something that has specific resolution, and we can name it, such as iPhone, certain type of laptop, something with non-resolution. So I'm gonna use here iPhone 11 to define the resolution. So let's do iPhone 11 would be equal to p.devices, and here we use iPhone 11 Pro. Then let's define the browser. So let's do browser equals p dot, and let's this time use as a browser webkit dot launch, and let's do headless equals to pause, and let's do slow mo equals to 5 seconds. So now once we have the browser, from this browser we can create a context. As I said, one browser can have multiple contexts, which means multiple windowses. So let's do context would be equal to browser dot new context, and let's define how we want our browser to appear or our context to appear. So let's do iPhone 11 will be our device, then local, and here we will define the language. So we would like German, DE-DE. Okay, let's do geolocation, and this is basically how your website is going to appear on that specific location on the earth, right? I don't know if you're aware, but depending on where you live, the websites and the elements that you can see there are different. For example, a selling website could have some prices that are lower in some country that is poorer and higher prices in more rich country, right? This is actually happening. So this is why sometimes it is important to test your website on different geolocations. So let's do longitude is going to be equal to 12.492507. Okay, and let's say latitude will be 41.889938. Okay, and let's add another parameter, which is going to be permissions, and let's do geolocation. All right, and this is if you want to add specific permissions to that geolocation. And then let's do page equals context dot new page, and you can go some page like https youtube.com. Actually, we're not going to put this here, but we're going to put it below. Let's do actually page dot go to youtube.com. Let's do page dot post so we can see what's there, and finally let's close the browser. Okay, so let's run that and let's see what happens. So I will do Python, okay, and I'll run this file. So let's do a test context.py. So let's run that, and you can see a page appears into an iPhone way, right? And it is in German, as you can see. And after some time, you'll see this pop-up window, which is basically where we reach our pause statement right here. So this is how, guys, YouTube looks when you see it from iPhone and when you have it in German on this specific geolocation. So let's close this tab. So let's click this button to close the pause. Okay, so if I click it, the page now closes. Okay, so this is how you create one context, but let's see how you can create more than one. Now let's leave all this until where we defined the context, and let's delete everything below. And here, after the first context, we can create another context from the same browser. So let's do that. Let's write context to will be equal to browser dot new context, okay, and then we can do page equals to context. Actually, let's name the first context context 1. Okay, so now we're gonna create a page 1 into our first browser. So let's do dot new page, then let's do page 1 will be again in context 1 dot new page. Okay, then let's create page 2, and page 2 will be in context 2. Okay, so let's do context 2 new page, right? And let's do, for example, page 1 dot go to https youtube.com. Then let's do page 11 dot go to https google.com, and then page 2 dot go to https cnn.com. Okay, so once that's done, let's do browser dot close. Okay, so that's it. Let's see, guys, now how is this going to work with two contexts. So let's simply do pytest test context.py. So let's run that, and you can see that we opened 3 total pages. So 1 page from the context 2 and 2 pages from context 1. Okay, and you can see we have Google, YouTube, and then we have also CNN right here. Okay, so after about 5 seconds, as you can see, those were closed, so we closed the complete browser, and this is how the test is completed. So you can basically see that context is basically the same browser, is just within the context you can define certain parameters to pass to this browser, such as which location you're in, which device you want to use, and this pretty much allows you to create basically the same test and run it into the same browser but in different contexts. So I hope now there are no secrets for you about how contexts are used in Playwright. This is some very powerful knowledge right there. Thanks for watching, and in the next video we're going to explore the advanced command line tools that are the most widely used by the developers in Playwright. Thanks for watching. Hi everyone, and welcome back to the course. In this video we'll talk about some of the key Playwright command line tools that everybody should know. So to do that, let's actually create a new test case, which is going to be quite simple, and then we're going to focus on the command line. So let's do here test CLI, and right here let's create a new test case. So let's do def test underscore, or actually let's do test CLI, and let's pass page here, and I will simply do page.go to https youtube.com. Okay, so let's save that and let's pass the column here. Now the first thing I want to talk about is basically how to install different browsers in Playwright. So in order to install the default browsers, you simply need to do Playwright install. In that way, all the default browsers will be installed in your device. However, if you want to install a specific browser, you can simply do Playwright install and then write the name of the browser. For example, if I would like to install WebKit, you can simply write WebKit here, and this browser is going to be automatically installed in your device. If you want to explore the Playwright options, you can simply do Playwright install --help, and here you can see all the different options when installing. Now you can see there is one option, install dependencies, and this is to install all dependencies from the different browsers. Let's try to do that. So let's do Playwright install -deps, and this will install all dependencies for your browsers. If you want to install, for example, the dependencies for specific browser, you just need to specify the browser after that statement. So let's say I can write here Chromium, and all the dependencies for Chromium will be installed. Now we already talked about how to generate code, but I will just recap this by simply writing Playwright code gen youtube.com. will basically activate the code generation tool for youtube.com. So it will give you the YouTube page and the Playwright inspector. So where you click on certain areas, you will be able to automatically generate code for those. Like when I just press to game shows, you can see here it appeared game shows.click. If for example I press on the search and I write something in the song, let's say, and select it, you will see that we activated the fill method, and then we click on the Hindi songs, right? And we're waiting until the particular page for Hindi songs appeared in front of us. Pretty simple. So let's close the code generator, since I'm sure that you're already familiar with it. Now there is one quite nice option using Playwright, and this is when you enter a page, you can save the cookies if you want to test them later on. So you can simply write Playwright code gen. Let's go again to youtube.com, and here you can specify save storage equals out.json. So this will basically save all the cookies into out.json file. Actually, I already tested this, so I have it here, so I will delete it. And so let's run that. Let's go to youtube.com and see our cookies after that. So as you can see, we activate our code generation. So let's click few tabs so our cookies can start getting detected. Okay, let's select this. Okay, and let's close it now. And as you can see now, the out.json file was generated. And if you select it, you see that you basically have all the cookies and all the things that this user has been selected ready for tracking. So this is how you can get the cookies if you want to test them later on. You can also consume those cookies and run them into your app by simply writing Playwright open --load storage equals, and then the name of the file, let's say out.json, and then you can place the name of the app in which you want to run them. So if you don't want to activate the code gen, but you just want to open a page, you can simply write Playwright open, and let's say wikipedia.com, and this will simply open wikipedia.com, as you can see here. Okay, you see selecting elements basically doesn't activate anything into your code inspector, which is right here. What you're simply doing is opening a page and exploring it. You can also specify with which browser you want to do that. So if I write Playwright WK for WebKit, wikipedia.com, you open wikipedia.com with WebKit. Also, you know that in the past we were talking about context, and for example, if you want to open a web page in a specific device, you can also do that from the command line. So if I write Playwright, and then open --device equals, let's say, iPhone 11, and then let's open some page. So let's do youtube.com, and you can see that now. So you'll be able to see that it is actually opened in iPhone 11 size. So you can not only add device here, but also if you do, let's say, viewpoint size, you can specify, for example, the exact size of the window that you wanna see. You can also specify in the same way time zone, geolocation, language, and so on. You can even generate a PDF of a web page by writing Playwright PDF, and let's say we go to https://en.wikipedia.org/wiki/pdf, and you can name the PDF, let's say, wiki.pdf. Okay, so if I run that, you will see that we are navigating to Wikipedia and saving a PDF. So if I hit here, you will see that a PDF is generated. You can open it and you can see that we actually have a PDF of wikipedia.com. So you can see how Playwright is really flexible, and in a very easy way you can generate pictures, videos, PDF, reports, and more and more and more. So this was everything I wanted to share for the command line tools. Definitely explore those tools more, because they can really simplify the way you run your test cases. Thanks for watching, guys, and bear with me in the next video, because there I will show you how you can use the best tools for debugging tests. Thanks for watching. Hi guys, and welcome back to the course. Today we will talk about and do a quick overview on the debugging tools available in Playwright. So let's go back to our Playwright guide project, and here I'll write a simple test case. So let's create a new Python file. Let's call it test_debug. And so I write a test case where we go to Microsoft.com, click a button there, and I will show you how you can debug that type of test. So let's write here def test Microsoft, and let's pass page. Okay, and first let's go to Microsoft.com. So let's do page dot go to, and then https microsoft.com, and we're going to locate a button there and simply click on it. Now you can either get the ID of the button with the code gen tool and simply copy and paste it in your project. So then let's put a button that we would like to select, and I selected the button shop surface deals. You can get the ID of that button with the code gen tool. So if you simply do Playwright code gen Microsoft.com and then simply select this button right here, you can see that the code will be generated for your click. Okay, so and then you can simply run pytest testdebug.py. So let's run that, and now one test is running. So now it's going to Microsoft.com and simply locates this button and selects it, and you can see that after a couple of seconds this test is completed. Now how we can run this test in debug mode? Well, there are a few options and we're going to cover some of them. So one way, for example, is setting the pwdebug parameter to 1. So let's do pwdebug equals to 1, and then we can write pytest testdebug.py -s. So let's run that, and you can see that two windows appear. Actually, one of them is empty. So from here, from the inspector, you can do steps through the code with this button right here. So this means that you're going to the next line. So if I click it, you see that here we're going to go to Microsoft.com, right? And then once we click this button again, then we're going to execute the next line, right? And you can see whether what you are setting up is passing or not. Also here you are going to get a very valuable logs for what you are planning to do. So here you can see that we're locating this button, and this is our next step. So you can see that the first step has been completed for 360 milliseconds. Then we went to Microsoft.com for 3.6 seconds. And then the next step is to to go to Shop Surface Deals button. You can see that there are a few checks that are performed: attempting to click, waiting to see if the element is visible, checking whether the element is stable or not. But what you need to know, and the most important thing, is that with this button right here, you can simply go line over line, and if you have an error, you can simply see exactly where it originates from. So if I do step over, we went now to the next line and we click the button, okay, and now our test is over. Okay, so this is how the first technique works, simply setting the pwdebug parameter to 1. So another way to debug certain code is with the pause keyword. So for example, let's write another line of code. I'll comment out our first test. So let's do here with sync underscore playwright, and you will need to import that as p. Let's create a browser. So browser would be equal to p.chromium.launch, and let's do headless equals to pause. Let's do slow-mo equals to 1 second, okay, and after that let's do page equals to browser dot new page, then let's do page dot go to, and let's go to playwright.dev. So let's do http playwright.dev, then let's print the title. So let's do page.title, and here we can actually use the pause keyword. So if you do pause, your code will be stopped here, and you will get the inspector, and you will be able to either move forward or end your program. Okay, so here instead of the debug tool, which I believe is more advanced, this one is simply stopping the code at some point, and you can decide to continue it after it. So let's, after the pause keyword, do page dot go to, and let's do here https cnn.com, and finally let's close our browser. Okay, so let's run that and let's see what happens. So I'll go to the terminal and write python test underscore debug.py, and as you can see, we're getting here our browser, and immediately we're also getting the playwright inspector, and this is normal. So as you can see here, we actually stopped on this pause line right there, and from here you can again control your test. So you can see where we paused right here, so you can decide whether to move forward from this step or stop your test, right? So if I press step through, you can see that you're going again to the next line. Okay, basically you get all the debugging capabilities after the pause keyword. The only difference between the pause keyword and the pwdebug is that the pause keyword activates the debug after it's called, while the pwdebug keyword activates the debug since the beginning of the run of your script. So definitely both of those will work fine for you. It is up to you whether you want to debug the whole code or you want to debug just a portion of it, where you can specify that with the page.pause. So let's end that. Let's go to browser close, and as you can see, we completed our program, and this is how you can debug it. So I hope you like the two ways of debugging code with Playwright, guys. Thanks for watching, and in the next video I will teach you how you can download files and automate that process. It's gonna be really interesting. Thanks for watching. Hi everyone, and welcome back to the course. As you saw from the header of this video, today we are going to talk about how we can automate downloads in Playwright. And Playwright really supports that and have a specific option that will allow you to actually download and check if this download is successful. So as you already downloaded the PyCharm ID for this course, we're going to use exactly that in order to test downloading. So we're going to download PyCharm once again. Don't worry, when you do that with Playwright, you don't actually download PyCharm, but you're simply downloading a dummy file and test the downloading service. I will show you how it works. It's really simple. Let's first create a new Python file and let's call it test download. Okay, so let's do here def test download, and I will pass page. So now what we need to do is firstly to go to the page of JetBeans download. So in order to navigate there, I'm gonna use our inspector. So let's do playwright codegen jetbrains.com/pycharm/download. Okay, so go to this address, and from there we're going to navigate and generate the code for this test. Okay, so let's hit enter here, and as you can see, you're in jetbrains.com. So what we're going to do, actually, I want to be on the Windows page. So as you can see, it automatically detects that my device is Mac OS, so it goes to Mac. But let's do this for Windows. So this is going to be, guys, our link for Windows, okay? And this is how we're going to go to that page. And after we do that, we would need to actually hit the download button for the community version and start downloading the file. So let's do that. And as you can see, some dummy file starts downloading. So if you take a look at the inspector right here, you pretty much have all the information you need. So you would need the link that you are going to the Windows downloads, and also you would need the locator for the download, which is this one. Okay, so I will not close the inspector, but I will use this information that you just saw in order to create our test case. So firstly, let's go to this page. So I will simply copy it, and I will do here in our test case page dot go to, okay, and here I will place this page. Okay, so we go to https jetbeans.com PyCharm downloads hashtag section Windows, okay, and this is a tab for Windows. And after that, what we need to do is to activate the download function. So you can do that by writing with page.expect download as download info, okay. So everywhere where we refer the download info, this is going to be related with our download. So let's do now page.locator, and now we need to locate the button that is clicked in order to download the JetBeans. And we have this in the inspector. So if I go right here and I copy this is DEF out wherever it says, okay, this is its tag. So let's place it here, okay, and then let's do dot first, dot click, okay. So we click the download button, and after this is done, now our download info has all the information of the downloaded file. So let's do download equals download info dot value, okay, and now let's simply print the download in our screen. So let's do print download dot path, okay, and finally let's do download dot save as, and then you can simply say where you want to save your downloaded file. So we're gonna check if we actually can save it. I will copy the path of our current directory, so you can simply do a copy path reference, and you can copy the absolute path. So let's place that here, okay, and then you need to refer to the file. So let's call the file at.txt, and this will hold all the information for the downloaded file. Perfect. So let's now close our code inspector. Okay, let's close the jetbeans.com, and let's run our code and see if it needs improvements or it works as expected. So I will simply do pytest test download.py -- edit. So let's see if everything is going to work as expected. Actually, I will also do a slow-mo of 3 seconds, just so you can see each and every step separated. So let's do that and let's see what's gonna happen. Now, as you can see, the page is opening, okay, on the Windows side. Then we click the download button, and you can see that the file is now downloading. So now we'll wait until the file is downloaded, so Playwright knows what to do, and for this reason it is still waiting, okay. So now the file is completely downloaded, as you can see, and then the test is ended, okay. So now you can see that we have this file at.txt, and of course you can see that this file cannot be read because it's a binary file, but this is the information about all the download that you just did, okay. So it is saved in text file. So thanks for watching, guys. This is how you're actually doing the download and testing it in PyCharm. Thanks for watching, and bear with me in the next video where we're going to do some emulations. Hi guys, and welcome back to the course. Today we'll talk about emulations. So Playwright can override various parameters on the device where the browser is running. Those could be viewpoint size, device scale factor, touch support, location, time zone, color scheme, or geolocation. So most of those parameters in the Playwright world are configured during the browser context construction. But some of them, for example the viewpoint, can be changed depending on the individual pages. So let's create a new file and see firstly how this is done for devices. So let's do new Python file, test, emulation, and here first let's import Playwright. So let's do from playwright.sync API import sync Playwright, and then let's do def run Playwright, and let's create here a new device. So let's do pixel underscore 2 is going to be equal to playwright dot devices dot, actually here in brackets, let's do pixel 2. Okay, then let's do browser equals to playwright.webkit.launch, and then let's do headless equals to false. Okay, and then let's do context. So let's create a new browser context equals to browser.new context, and let's our new context be the pixel 2 device. So let's do pixel 2, and that's gonna be all. So let's do now page dot, actually page equals to context dot new page, and actually as you can see now PyCharm does not guess our parameters, and this for a reason is because here in this function we're passing the playwright variable, but for now Playwright doesn't hold all the functions from Playwright, and I will show you later on when we call this function we will actually relate this Playwright keyword with the sync Playwright, and this is where the bond will happen. So let's do new page, and then let's do page dot go to, and let's for example go to discovery.com. So let's do https discovery.com. Okay, and let's do page dot pose. Okay, so this is how we're running to the pixel 2 device, and now what you can do is with sync playwright as playwright run playwright. Okay, so now here we defined that playwright is the same as sync playwright right here, so we're basically passing sync playwright in our function. Okay, so let's run this file and see what happens. So let's do Python test emulation. Okay, and when I run that, you can see that we're running the discovery page for pixel 2. As you can see, we can spot right here that they have problem with the resizing, right, on specifically this device, because you can see the discovery is overcrossing this image right there, and the rest seems to be fine. So you can see that even the big websites of the big companies also can have some issues revealed when you run them on different devices or resolution. Also, since we did the pause in the end of the test, you can see that we actually pause the page and we're not going to move forward until we press either of those buttons. Actually, this play button means that you want to execute the test until the end, so let's hit it, and now the test will end right here. So for your tests you can also actually specify user agent, right? So user agent means that this is a variable that has a certain name, which name is shared between all the pages. So all the pages in the same context will share this user agent. So to do this, it is quite simple. First of all, I'm going to remove our Pixel 2 device, and I'm going to remove this one as well. And instead, I'm going to define user agent. So user agent equals to, let's say, Martin Y. Okay, so here we create one page. We can create another one. So let's do page 2 equals context dot new page, and let's do page 2 dot go to https youtube.com, and let's pause both pages and see what happens. So let's run the code again. So let's run the code here, and you can see that here we're going to get the two pages. They are run literally in the same context, and now both of those, they refer to the same user agent, which is Martin Y right here. So now guys, the next thing I want to show you is how you can add a resize viewpoint emulation for individual page, and how you can do high DPI at the same time. So for this we will need to create two contexts here. So I will keep the browser, right? And firstly, we already have one context, so let's change the viewpoint here. You can do viewport, okay, and here we'll do width of 1280, okay, and let's do height would be 1024. So this is the viewport of your first context, and now let's create another context. So let's do context 2 would be equal to browser.new context, and let's do here a different viewport. So viewport equals to width of 2560, and let's do height of 1440. Okay, now you can also do a device scale factor, which will basically scale your image. So let's do device scale factor. Let's do it by factor of 2. Then let's change the location to TE-E, and let's also change the time zone ID to Europe, Berlin. Okay, and pretty much that's it. So now we have two contexts that are completely different, and now let's actually page 2 be run from context to. Okay, so now two pages should appear with different context. Perfect. So let's again do Python test emulation.py. Let's run it. And you can see that there are two pages that actually appeared. So one is from Discovery, the other one is from YouTube. As you can see, they're very different in the way they look. So you can see that, for example, the discovery.com is way smaller, while the youtube.com is actually enormous since we created a huge resolution. And also you can notice that the youtube.com actually has everything in German. So this is how you can make sure that your page is displayed well on very high resolution, as you can see on youtube.com, while at the same time you can test a smaller resolution on other pages. Or maybe you would like to check different contexts on the same page. So you can definitely do that with Playwright. Okay, so I will finish this test right here. Okay, so this is going to be everything for today, guys. Thanks for watching, and stay with me in the next video, which is going to be the last in this section, where we will talk about events. Hi everyone, and welcome back to the course. In this video, I will show you how you can work with events in Playwright. So Playwright allows listening for various types of events that are happening on your web page, such as network requests, creation of child pages, dedicated workers, and so on. There are several ways to subscribe for events, and I will show you some of those. We will also export some very nice images from wikipedia.com today. So let's get started. So let's create a new file here. So let's do new Python file, and I will call this file test. Yes, you guessed it right, events. So let's create a new function. So let's do def test event1, and let's pass here page. So let's first state what request we would expect. So let's do with page dot expect request, since here we're doing requests, and here write the following. You can definitely get this from the code gen as well, and this is going to be where the logo of wikipedia.com is. So let's do logo.png as first. Okay, so now let's do page dot go to, and then https wikipedia.org, and then actually let's print first dot value dot URL. Okay, so we would like to print the URL of the logo. So let's save that, and let's hit here the play button so we can run this in our Python console. So let's run and run the test. Okay, so you can see that this one is running right now, and then the test has passed, and also we got the URL of the logo. Okay, so this is how you're expecting the request, you're getting the response. So for example, if you're wondering what is the link to the logo of wikipedia.com, now you have it right here into first.value.url. So let's hit it, and you can see that in your window you can see the logo of wikipedia.com. Okay, so let's see how we can automate this to track multiple URLs when we want to access certain page. I will show you how you can detect when a request has been sent and when a request has been finished and the next one has started. So let's comment out this, and let's do another function. So def test events, and here we're going to track a lot of events. So let's do page, and then we'll create two functions inside this test function. So let's do def print underscore request sent, and I will pass here request. Okay, and what we will do here is we'll simply print request sent. Okay, and after that you print the URL of your request. So request.url. Okay, then we can do the same thing with the with actually where the request has been finished. So do def print request finished, and let's pass here request. Okay, and so let's print request comma actually request finished plus again request dot url. Okay, great. So we have those two functions. Now we need to write the active statements that are going to activate those. So let's do page dot on, and here we would need to select what event we're going to be tracking. So let's do request, and let's use the print request sent function in order to print it. Okay? And then let's do again page dot on request finished comma, and let's do here print request finished. Okay, and let's select which page we're actually going to. So page dot go to https wikipedia.org, and then let's finally do page dot, and let's use here the remove listener function, and we will check for the same request finished. Okay, so we don't listen for the request after it has been finished, and I will again do print request finished as a print function that we're going to use, and finally I will do page page dot go to, and let's go to another page. So let's this be https www.openstreamup.com. Okay, so .org actually. So that's it. Let's now test our code and see if we're going to get all the URLs. So hit the play button right here, run Python tests, and you can see that everything is running now. And your test, as you can see, has been passed for 1 second and 720 milliseconds. So let's see what's going on here. Now you can see all the requests. So we sent requests firstly to wikipedia.org and we finished it. Then we sent multiple requests to get a different type of images from wikipedia.org. We also got JavaScript and SVG files. Okay, so you can see how many requests we sent and we finished. And then we went to openstream.org and pretty much did the same thing. So we got all the files from these pages. If I click on this one, for example, you get the CSS file of that page, and if you have some program such as Sublime Text, you can open it there and definitely work on it. Or let's say this SVG file, you can see that this is a PNG of a map. You even got the ones and the zeros inside and other various files that you can see here. So from the open map we got really a lot of PNG files and so on and so on. And if you click on the last link right here, right, you see that this is pretty much an empty untitled page, and this is how we actually finished our service. So definitely if you want to track the events and get all the links, you can use for sure the event functionality of Playwright. This is going to be actually the end of this section, guys. Thanks for watching, and in the next one we will continue exploring the most interesting functionalities from Playwright, and I will provide you some real world examples. Hi everyone, and welcome back to the course. In this video, we will talk about frames, but in this section, we will talk about many different topics, such as frames, networking, generators, object-oriented programming, and all of those techniques we are going to relate to Playwright and automation testing. So let's get started. So we already have the project Playwright guide, and here we are going to continue creating test files. So the topic of today's video is frames. So frames is a very simple concept which allows you to display a website into another one. For example, if I have this web page, right, and for example, let's say if the front of the page is on https, let's say playwright.com, okay, let's say this is our web page, but however, for some reason we would like to display some other page inside. So in that case we'll use frames, and what we will do is in the HTML file of that page, we're going to display another one right here. And this will be our second page that could be completely different comparing from the first one. For example, here we could have https google.com, right? So let's say if you want to have a Google search in your main website, you can refer to google.com and display it as a frame within your web page. So let's see how we can test those in Playwright. So here in the Playwright guide, I will create a new Python file and let's call it test frames. Okay, so in order to generate the code for those frames, of course, I have a web page in which we can go to, but let's first create the test case. So let's do def test underscore frame, and we're gonna pass page here. Okay, so how we're going to do it is first we will need to go to a page. So if we do page dot go to, okay, we would go to certain website, https, okay, and we're going to a website, and then we need to detect the frame, and you can do that by writing page dot. So you know usually we have a locator here, but here in order to detect that there is a locator in a frame or a different web page, we need to do frame locator, okay, and inside the brackets here we'll need to write the reference to this frame locator, right? And after that we can add the options with dot, and for example we can do click or something like this. So after we have the page, the frame locator, we actually need to define the actual locator within the frame. So usually do frame locator dot locator, right? In a normal page, we'll just do the locator. So page locator dot locator, and here we would have something that is within our frame. And then finally, you can do, for example, click. Okay. So let's see how this is done, and we're going to generate this code with our code gen tool, and I will show you how it works. So let's do Playwright code gen, and we're going to go to https developer www.mozilla.org, and here I will specify the location of where we have the iframe test. Okay, so let me just remove the parentheses here, and let's go to this frame and let's generate some code there. Okay, so as you can see, we went to the page and we have our code generation tool here. So let me go back to the page, and as you can see here, we have few things. Now we have the web page with all the headers and menus, but at the same time we're having this frame right here. This is another application within our web page. So this is referred as a frame. And if you're interested, this is how you can actually create a frame. You need to simply use the iframe method. So let's click somewhere here and let's write Python. Okay, so now we should have the code generated right here, as you can see. So let's copy it. Okay, let's close the window and let's simply paste it into our test. Okay, so as you can see, what we're doing here is we're going to the web page that I just mentioned. So you can see below that here we're using again the frame locator. We're using the text to the marker, and also we're pointing to an iframe, right? Then within the iframe, we're using this tag, and then we're clicking on it. This is where we clicked on the iframe. So after that, in order to fill certain text into the iframe, you again need to use the frame locator. Then you need to use a specific location within the frame. And finally, you can write the fill command with the text that you want to add. Actually, let's add a different text here, so we don't choose exactly what we copied from the code generator. Let's write my favorite tool is Playright. Okay, so let's run this file and let's see if we're gonna get the same action. So let's do Pytest and then the name of the file, so test frames. Then let's do edit and then let's do slow-mo of 1 second. Okay, so let's run that, and as you can see, we entered here the frame. We wrote my favorite software is Playright, or my favorite tool, and we exit. Let's run it again just so you can confirm. So we go to the page, we scroll down, we enter our text, and we exit. Okay, so this is how you can automate frames. So thanks for watching, guys. This was the first video of this section, and next one might be a bit longer because there we're going to talk about inputs. Hi guys, and welcome back to the course. In this video, we'll talk about inputs. Now, into our Playwright guide project, we'll need to create a new Python file, as we usually do, and let's name it test_inputs. So what are inputs? Well, inputs can be many different things. So inputs can be either fields where you fill your data, right? So sometimes you're getting forms with, let's say, name, date, password, okay? And there you need to perform certain inputs, okay? Other times you have something called radio buttons, from which you can select only one, right? So those radio buttons, they might have like different options, and you need to select only one of those options. So we will learn how to deal with those buttons and how to select them automatically using Python and Playwright. And also, you know, there are other times that you have buttons from which you can choose multiple. So those are usually those squares, okay, where you can simply tick on each and every of those if you wish to. So we're going to learn in this video how to deal with all those situations, plus some other situations, for example, where you need to choose a date from a list. Let's say you click on it and then you get a list of dates from which you can select, and so on. So let's see how this is done in Playwright. And in our first example, we're going to perform a test where we are doing registration into Facebook. So yes, for example, if you go to facebook.com and select create a new account, you will get this registration field right here where you will need to fill your data. Now I will teach you how to do this absolutely automatically and test the registration form of Facebook. So let's write a test case. So I will need to do a new function, and let's do test Facebook, and I will only need to pass page here. And of course, the very first line will be for us to go on the registration page. Okay, so let's do page.goto, and our page will be https://www.facebook.com/registration, or actually register, that's right. Let's actually test if we're gonna go to that page. So if I do right now Pytest test inputs and then I write headed, or actually dash headed, we should be able to go to Facebook registration page. So let's see. Yes, you saw it for a moment. We went to the registration page. So let's do it for a little bit longer time. So let's do slow-mo 2000 seconds. And as you can see here, we're going to the Facebook page, and now the test test ends. Okay, good. So now let's see how we can fill those fields. Well, the first thing that we need to do is to basically locate them and then to fill them, right? So let's do page.locator, and let's firstly locate the field where you need to put your first name. So let's do area-table, okay? So we're defining here that we're actually looking for a label, and then let's do first name, okay? And this is how we locate the field where we have the first name. So let's click on it, so click, and then we're actually going to locate the same thing. So page.locator, first name, and here we're going to fill this name. So let's fill, and you can choose the first name. So let's say my first name is Jack, although it is not Jack, but let's say it is my first name. Actually here you need to do fill, okay? So let's see if this works. Let's run the page, and you can see we go here, and for first name we select it and we fill Jack, and then we exit the page. Okay, that's perfect. So let's do this for the rest of the form. Now sometimes in order to move to another page, you can do that not only with click, but you can also select the tab to move between fields. So to do that, you can simply locate the current button that you have your cursor in, do dot press. So this is where we press keys on the keyboard, and then right tab. Okay, and this is the same as if you would press the tab button. So you switch to the next field. Now next let's do page dot locator, and here we're simply going to change the first name with last name. So this means we would go to the next field. So let's do, instead of first name, let's do last name dot, and since we're already on the last name field, since we press the tab button, we actually don't need to click it. So let's do here fill, and let's say our last name is Jones. Okay, so we fill the last name. Now let's go to the next button with clicking. So the next button will be our mobile number or email. So you can simply do page dot locator, and again I'm gonna copy this and then update it so we don't try the same thing over and over again. And here we have mobile number or email. Okay, let's do dot click, and once we're on this field, then let's add some number there. Now notice that the name of this field pretty much depends on Facebook, right? So if they change the name from mobile number or email to email or mobile number, then this field will not be detected. So make sure that if you have any issues with detecting or locating the parameters, you can simply use the code generator, select them, and see what's the exact label. So now once we clicked on mobile number or email, let's actually copy this again and paste it below, and you can do dot fill and pretty much fill your number. So let's have my number 1 2 3 4 5 6. Okay, then from here let's hit tab again. So I will copy this page, paste it below, and do press, and let's press the tab button. Okay, so we'll go to the next field, which is the password, and here let's do page dot locator. Okay, and let's copy and paste this, and I will just change the label to password. So let's do new password. Okay, let's do dot fill, and let's write an example password to 1 2 3 4 5 6 7 8, for example. Of course this password is not going to be accepted by Facebook because it is too easy. The same accounts for the phone number, but now we're testing whether we can fill the fields or not. So let's save that, and let's actually test our first test case where we are entering the registered information. So let's do again Playwright test inputs headed slow-mo 2000 milliseconds, which is 2 seconds. So let's run that and let's see what happens. So here you can see we're on the Facebook page, and now the first thing we will do is to enter the first name, then we will enter the last name. After that we will click on the mobile number or email, then we will click on new password, actually with a tab, and we're ready, so we exit the test. Great, so now you know how to fill all the fields from a form. Now the next thing I want you to learn is how to actually work with the radio buttons and selectors. So if you go back to the Facebook registration page, you can see that there are firstly those selectors right here from which you can choose month, day and year, and also here you have radio buttons from which you can choose only one, whether you are male, female, or you can do custom. So obviously you cannot do all of those at the same time, so for that reason you will need to select one of those. Okay, let's see how we can automate that. So under the field where you selected your password, let's actually extend our test case, and let's do here page dot locator, Okay, and let's here select the field. So let's do area label equals \month. Okay, so here is the field that we have selected. Okay, so now we're on the month field, and from there let's do dot, and since this is a selectable field, you need to use the command select option. Okay, so select option, and then you need to choose some of the options. So since the months are from 0 to 12, let's select the 9th month, right? And there you pretty much saw them with their abbreviation, which means January, February, March, and so on and so on. However, this is just visual, but if you want to automate this, you need to provide the number of the month, which 9 means September. So let's do this for the rest of the buttons as well. So let's do page.locator, and I will copy the area label. So let's copy those, and I will paste it here. So let's do day dot select option, and let's select here 23rd, and finally let's do page dot locator, and let's here select the year. So I will again copy this, and I will simply write it down there, year. Okay, let's do dot select option, and here let's do 2011. Okay, so our new user is 11 years old. Now, how we select the radio buttons? So those were the buttons for the gender, and so when you're dealing with form that has radio buttons, of course, firstly you need to select the form. So let's do page.locator, and let's get the label here. So the label is sex, and then here you need to use the nth function, and you can use the index of the button you want to select. For example, if I want to select male, I will do 1. So instead of click here, it's actually check. So when we're working with radio buttons, you can do check. And also the other thing that I want you to notice is that here we're actually not using area label, but instead we're using name. So the name of the field is sex, and also this is an input field, so you need to use input. Okay, and finally let's actually submit our registration. So we can do that by simply clicking on the submit button. So let's do page.locator, and I can do button name equals \web submit. Okay, slash, and then let's do a square bracket. Okay, and let's do dot click. Since this is a button, we simply click on it, and we should be ready. Okay, so let's run our code again, and let's do 1 second difference. So let's do 1000 milliseconds, and let's see what's happening. So you can see that we're entering the first name, the last name, the mobile number, the password. We selected September 23rd, 2011. We select male, and finally you saw this error there because we actually clicked on the submit button. So that was everything for today, guys. In the next video we will continue with the inputs, and I will teach you how you can work with checkboxes. Thanks for watching. Hi everyone, in this video we will talk about automation of checkboxes. So last time, as you see, we developed this test for filling the Facebook form, and today I will show you how you can simply fill checkboxes in your application. So in order to do that, we're first going to go to this web page, which is actually a page that tests checkboxes, and we're going to use this example right here. Okay, so you can see we have different checkboxes, so we will automate the way that we select them. So if you go back to our file here, I'll actually comment out our Facebook test, and let's just under it write def test checkbox. Okay, and let's pass here page, and first let's go to the page that I just showed you. So you can do this by page.goto, and simply copy and paste this page right here. Okay, so it's www.w3.org, and this is the exact address to the checkbox. Okay, so once we're on the right page, let's firstly locate the first field, and let's say we want to click first the sprouts field. So what you simply need to do is to check for the specific tag. So if you do page.locator, and after that this will be the tag of the page, so ly has text sprouts, and then select dot click. Okay, so this means that you click the radio button, okay, but you didn't select it yet. So to do that, let's create a new parameter called sprouts, and this will be equal to page.locator, and now we need to write specifically the tag of our checkbox. So here's the tag in front of you. This is div row checkbox as text sprouts, Okay, so this is the tag of the checkbox, and again you can get this tag by simply inspecting the file by doing, for example, inspect, and here you can find the tags. As you can see here, we have div row checkbox with the name sprouts. So this is one way to find the tag, and the other way, of course, is from the code generation. Okay, so now let's do sprouts.click, and now we selected the radio button. Now if you want to check whether the button is clicked or not, you can simply use the assert method and write sprouts.isCheck is true. So you're checking whether the button is checked or not. So let's select now another button. So there was a button called mustard. So let's make this equal to page.locator, and let's again place the tag of this radio button right here. Okay, and then what we need to do is to click it. So let's do mustard.click, and then let's do assert mustard.isCheck, and this should be equal to is true. Okay, and also if you want, you can actually have those two lines on the same path. So you can do, for example, page.locator, and let's do this with one of the other buttons. So you can here define the latest button and to do simply .click. Okay, so you don't need to create a separate parameter. It's entirely up to you. So let's save that and let's run this. So I will do pytest test inputs headed slow-mo 1000, and let's see what's gonna happen. So let's run the file. As you can see, we go down and we selected a few buttons, okay, and then we exit the program. Okay, so now we learned how to click buttons, but how to unclick them or click them out. So you can see that on our page we have one button that is previously clicked. So let's deselect this one. And how you can do that is, of course, first you need to locate them. So let's do page.locator, and I will simply copy the latest tag, and instead of latest I will add tomato. Okay, .click, and this should actually deselect the button. You can also perform a double click on those buttons. For example, if you do dbl click, this means that you click the button 2 times. So for example, if the button was previously clicked and it is unclicked once you select it, when you do double click, it will stay clicked. So let's try that too. So I will remove the click and I will just leave the double click. So if I run the file right now, you will see that we will go down, we'll click the sports, mustard and lettuce, and then the tomato stays clicked. So this is because we did double click. If we just do a single click, then you can see that once the program starts executing, this button will be deselected. Okay, so this is how, guys, click and double click works, and this is how you can basically select and deselect checkboxes. So there's another feature that I want to show you actually, and I will comment out this test first. So we quite often use this fill command where you can simply fill a field, but also Playwright allows you to type, which means that you can type letter by letter automatically instead of simply copying and pasting the command that you passed into the fill field. So let's do that. Let's create a new test, def, and I will call it test underscore type. Okay, and let's do page. So here, let's for example go to page.go2, and let's go to google.com. So let's do https www.google.com. Okay, and there let's click the search. So you can click the search by writing page.locator, and let's find the search by the tag. So let's do aria label equals \search. Okay, and let's do click. So now we can add text into the search, and instead of this time filling it, we're going to actually type it. So let's do page.locator, and we'll basically copy the same tag from the search. Okay, and here I will do dot, and you can use a type keyword and then write social media. So this is what we're going to search for. And finally, in order to complete our search, let's do page.locator, and let's again copy and paste the search field, and I will do dot press enter. By the way, always if you want to use keys, you can use the press keyword, and then a key is automatically pressed. Okay, perfect. So let's try out our test case. So let's run again pytest test inputs headed slow-mo 1000, and let's run this. So you see we go to the search, and you can see that now we're actually typing social media instead of simply pasting it. Okay, so you can see that we're automatically typing it, and once we're ready, we'll click enter and we'll go to the page that we desire. So this is how the typing works, guys, and today we covered typing and we also covered the checkboxes. Thanks for watching, and in the next video we'll talk about how you can upload an actual file into your web page. Hi everyone, in this video we'll learn about how to upload files in an automated way. So this is actually something pretty simple to do in Playwright, and I will still write here in our test inputs function since this is a type of input, and I will comment out absolutely everything above it. And let's create a new test case, which of course is going to be called test. Actually, let's do def test underscore upload, and we're going to pass the page keyword here. So let's first go to a page where you can upload file. I found one website which is specifically for uploading files. So let's do page.goto, and the website is https www.filemail/share/upload-file. Okay, and before continuing, you actually need to create an actual file into your folder. So let's click new file, and this file will be called test1.txt. So it will be a text file right here, and inside let's write this is a test file. Okay, so let's go back to our inputs file, and now since we entered this page, let's first click the correct button for us to add a file. So let's do page.locator, and then let's do text equals add files dot click, and then we can do, since we clicked on this button, page.locator, and here's where, guys, we're actually going to upload our file. So how to do that is, firstly, you're using this hashtag add btn input type equals \file. Okay, so this is the tag for the place where we upload file, and of course you can get it with the code again when you go to this web page. So let's do dot, and let's use the option set input files, as you can see here, and let's go to the next line. So here you can simply write the name of the file that you want to upload and location. Since the file that you want to upload is in the same folder as the test file, what you can do is simply write the name of the file. So let's do test1.txt. Okay, perfect. And finally, let's click the send button, which is actually going to upload our file. So let's do page.locator, and then let's do button has text, and then we can do send.click. Okay, so this is our test case. Let's run it and let's see if it's gonna work properly. So again, I'm gonna do Pytest test inputs headed slow-mo 1 second, so we can see everything that happens on our browser. So let's hit that, and we got an error. This is because I forgot to write .com here after file mail. Maybe you spotted that already. So I'll actually provide the absolute path to this file, as you can see here, and you can get this path simply by clicking on the file and select copy absolute path, and then simply paste it here. Actually, I'll remove this, and I will simply paste the absolute path of the file. So now if we run it, and let's do 2000 seconds delay. Okay, if you run it, you will notice that we're going to go to the page. Okay, then we will select add files button, then we will put the file, as you can see, on the background, and now the file is completely uploaded. So this is how this thing works, guys. This is how you can test if your page is capable of uploading files, and you can add this to your automation test suite. So that's it. Thank you very much for watching, and I will see you in the next video. Hi everyone, and welcome to this practice lecture where we will talk about navigators, and I will do a simple example with navigating through Instagram. So let's create a new Python file, and here let's call it test_navigation. Okay, and here's our new file, and now, as I said, we're going to navigate into an Instagram page. So let's create a new test case. So let's do def test navigator, and let's do page. Okay, and here let's write page.goto, and let's go to instagram.com. So https www.instagram.com. Okay, great. So once we're in instagram.com, let's say that you forgot your password. So to change your password, you would normally want to go to page.locator, and you would search for something like text equals forgot password ? Okay, so let's click on this button, and here we're in forgot password page. Now, once we click on this button, what we would expect to happen is that we're gonna load the password page. So we normally don't want to do any other actions before this page has been loaded. And for that reason, you can do page.wait for URL, and nothing will happen until the reset page is appearing on your screen. So let's do https www.instagram.com/accounts/password/reset. Okay, so once we have this page, let's say that we actually want to create a new account instead of changing the password. So in this page, you actually have this option. So let's do page.locator, and let's select the button where it says text equals to create new account, and let's click on it. So let's do dot click. So once we do that, we don't want to do any action before we go to the sign up page. So let's do page dot wait for URL, and here we're gonna put the link to the sign up page. So until this page is loaded, we will not perform any other actions. So let's do https www.instagram.com/accounts/email sign up. Okay, so once we're on the email sign up, actually let's check if our code is working properly. So let's do playwright test navigation --edit slow-mo 1 second. Okay, let's run that. Actually here I had to write Pytest instead of playwright, so let's do Pytest. Okay, so that should work. And as you can see, we're on instagram.com. We're going to forgot password, and after that we go to our Instagram login page. Okay, that's perfect. So everything works for now. Let's just paste a slash right here in the end of the sign up so we can locate the sign up page, and then let's add some parameters into the fields there. So let's do page dot locator, and let's first go to the mobile number or email field and let's click it. As you can see, actually Facebook and Instagram, they use the same tags for registration, and this is because the company is pretty much controlled by the same people. Facebook owns Instagram. So let's under it do page, so page dot locator, and let's again select this mobile number or email, and let's fill this time an email. So let's do fill, okay, and let's say my email is playwright@gmail.com. Okay, so we can do the same with the username. So let's do page dot locator, and for label I will put here full name, and I'll select click, and then I'll copy this and paste it below, and here I will put for full name, let's do fill, and let's do play for a full name, and let's now select tab. So I will again place this, and I'll do dot press tab. Okay, so now we're gonna be on the button username. In Instagram, as you know, you need to have a username. So let's do page dot locator, and here instead of full name we'll put username dot fill, and let the username be right. Okay, actually here is fill, and let's actually place some numbers after it, and let's actually write it with a lowercase letter so it's a unique name, right? And finally, let's click on the password field. So you simply need to go to password dot click, and then you can select password dot fill, and for password let's choose right 1 2 3 4. Okay, and finally let's submit our registration. So let's do page dot locator, and here we need to locate the sign up button. So this will be button as text, and then let's do here sign up. Okay, let's close this bracket, and then let's do dot. Okay, great. So now we click the sign up button, and our navigating into Instagram is completed. And before running the program, let's change this quote to double quotes. And now let's simply write here playwright test navigation headed slow-mo 1000, and let's see if everything is going to work properly. You can see that now we're going to Instagram, we check forget password, create new registration, and now we start adding the different fields. So we have play for username, right, password, and then we click the sign up button. So you can see that everything worked perfectly fine, and we're able to create our new Instagram account and navigate through the Instagram page with those simple commands. So that's it. Thank you very much for watching, guys, and I will see you in our next video. Hi guys, and welcome back to the course. In today's video, I will teach you how to use Playwright in your network and how to subscribe request and response events. We will use today lambda expressions, so if you want to brush up on that before we start, please feel free to do that. So let's create a new Python file, and I will call it test network. Okay, so what we will do is we will go to python.org and we will start tracking the requests and the response methods. So let's first import playwright.syncAPI. Actually, from there, let's do from import sync playwright, and let's create now a test function. So let's do def, and the function will be called to run, and here we will pass playwright. Okay, and I will show you how you can run this function later on in the script. So now playwright would refer to our sync playwright, but the assignment will be done later. So let's create first our browser. So let's do chromium equals to playwright.chromium, and below in the lowest indentation level, let's run this function. So let's do with sync playwright as playwright run. So this is our function here, playwright. Okay, so now this is the statement that runs our function. Okay, great. Let's now create here our browser. So let's do browser equals to chromium dot, and you can see that now you can see all the options. So chromium dot launch, and then let's create a page which will be equal to browser dot new page. Okay, perfect. So now we created our Chromium browser, we launched it, and we have a page there. We haven't yet defined the way that we're going to subscribe to the request and the response events, and also we haven't defined the website. Since we're running the function from outside, we can actually define the website as one of the last things in our run function, and you will see how this is done. So let's do page dot on, and when you use the on keyword, you can specify events and functions for running these events. So let's do on, and let's name the first one request, comma, and let's write here lambda request, and let's do print, and I want some arrows here so this could be easily distinguishable, and let's do request dot method and then request dot URL. Okay, so we will print the method and the URL of our request. Let's do a similar thing with the response. So let's do page dot on response, and then let's do lambda request, actually here is response. Okay, and then let's do print, and here let's do the arrows in the other direction so we know what is request and what's response. Great, and then let's do comma response dot status, and also response with e, so response dot URL. Okay, and finally let's go to the page. So let's do page dot go to https python.org, and finally let's close it. So let's do page dot close. Okay, so this is it, guys. So let's now extend our terminal and let's write python and then test network.py. So let's run that, and you can see that we're starting to get the requests and the responses. So you can see here we got a get method. So you can see that actually firstly we tried to go to https python.org, but we received 301 response, so the website was inaccessible, and then we tried to www.python.org, and then we received response 200, which means that we logged into the page successfully. And after that we used those JavaScript, you can see CSS files, PNG files, and so on, in order to request what we're going to see on our python.org page, and then we received responses for those, right? And you can see then we made a little bit more requests, and we got the responses here as well. Okay, so basically when you log in into a page, these are all the requests and responses that are happening just for clicking a single link. So if you want to explore those, you can definitely do it, and you can use those links for your test cases. For example, if I click on this one that I can see is .png, so it might be a PNG file. So for example, I can see here that there is a PNG file, which means there is a picture from this link. So if I click it, you can see that this is actually the Python image that is displayed on the website. You can also select the JavaScript files, which of course, since we don't have an editor, you're going to see in that form. But if you, for example, open this file into tools such as Sublime Text and so on, you will see it way more prepared. And basically you can really easily explore all the files that are making the Python website. So this is how you can basically do networking and examine and use the requests and the responses. Thank you very much for watching, and I will see you in our next video. Each browser context could have multiple pages. A page refers to a single tab or a pop-up window within the browser context. This is normally used to navigate to a URL and inspect the page content. So this is what we're going to be doing in this video. So here, guys, we will explore how to log into pages, how to check their URLs, and also how to work with pop-up windows. So let's create a new file here. Our next test file will be called test pages. So the first test, just to warm up, is gonna be a simple one. So let's do def test page, and here we will pass page. And so let's go to google.com. So page dot go to http google.com, and from there let's do page dot locator, and let's select the search there. So the address of the search would be area label equals equals search dot click. So we're going to click the search, and then in the same search we're going to search for Mike Tyson. So let's do dot fill Mike Tyson, and then let's click on some of the topics that appear. So let's do page dot locator, and so the first page that appear is Mike Tyson, American former professional boxer, and do dot first. So first time that this appears, dot click, and we're done here. And finally let's print the URL. So let's do print page dot URL. Okay, and let's run our test file. So you can simply do right click, run Python test. Okay, now our file is running. We can see that everything passed correctly and we actually got the link from the page. Let's click it, and you can see that in fact we went to the page of Mike Tyson, and this is our link. So this is how you get links from pages that are reusable and you can use them later. Of course, if you would like to run the test from the terminal, you can simply write pytest test pages -- edit -- OMO 1000. So you can see that we go to Google, we search for Mike Tyson, we select the first option, and we go to his page. Okay, good. So we warmed up. Now the question is, can we do that with multiple pages? Well, yes, but we will need to do some modifications. So let's create a new test case and comment out this one, and let's do def test page2, and here instead of page we will pass context, and this will allow us to actually create more than one page, because instead of passing a single page we pass context from which we can create multiple pages. So let's do page equals context dot new page, and then let's do page1 equals context dot new page, and let's make both pages to go to google.com. So you can do page dot go to http google.com. Okay, and I will just copy this and paste it below, and I will do the same for page 1. So now we have in the same context two pages that go to google.com. So now let's, in only one of those will go to Mike Tyson. So I'll actually copy this, okay, and instead of page I will put page 1, okay. And so the idea is now that we open two pages, and in one of those we search for Mike Tyson. So let's see how this is done. I'm gonna do here 2 seconds delay, okay, when we run the file, and let's see what's gonna happen. So let's run it, and you can see we open 2 pages immediately, and the second we went to Google as well, and in the second page we're looking for Mike Tyson, and we'll go to his page. So you can see that now we open 2 pages, and each of those pages is different schedule for what websites is gonna go and what functionalities it will have. So we already talked about how to run a single page, how to run multiple pages in a context, and you can run really a lot of those, but we haven't thought about how to do pop-ups. So let's try that. So let's comment out this, and let's create a new function, and I will call it, let's do def test page3, and I will pass again here context. So I found a page that have a very suitable pop-up, and you can see it here in the browser. So this is rrc.taxes.gov resource center research and so on. So this page is basically a page that runs a pop-up test, okay? So when you hit the run pop-up, a new pop-up window will appear, and then you are able to close it, okay? So this is the page that we will use for our test, and let's see how we can automate that pop-up process, or actually pop-up problem, because we yet don't know how to work with pop-up windows. So firstly, I will do page equals context dot new page, and then you want to go to the page from which we select the pop-up window. So let's do page dot go to, and then I will simply copy and paste the link that I provided to you. Okay, so this is the link. I divide it into 2 rows so you can see it better, and then let's do with page dot expect pop-up as, let's call it pop-up info, okay, which means that all this function is now assigned to pop-up info. So let's do now page dot locator, and we need to locate the button where we open the pop-up window. So this button had text that was run pop-up test dot click, and finally we want to do page 1. Okay, so now we create another page equals to pop-up info dot value. Okay, so this is how you're basically assigning a different page to the pop-up window, right? So then you can have control on the window that pops up in front of you. Now, we want to make sure that we are not doing any other things if we are onto different page. So what I'm gonna do here is I will do page dot wait for URL, and then what I'm basically gonna do is to wait for the same URL, because the URL from which we selected the pop-up didn't change, okay? And finally, if you want to close the pop-up window, you simply can do page1 dot close, okay? and let's also print page.url. Okay, this will be the URL of page one. Okay, so let's run our test. This is basically how it looks like. So let's do pytest test pages.py --edit --slowmo, and let's leave us time of 2 seconds between every action. So let's run that. Okay, and you can see that the page appears in front of you. The run pop-up button is selected, and then we close the window. So this is how, guys, you can run and expect pop-up windows when testing your web page. So these were all the tests for testing pages. I hope this video was useful for you. We did 3 tests today. Thanks for watching, and I will see you in our next video, where we're going to cover how to make videos and screenshots of your web pages. Thanks for watching. Hi guys, in this last video from this section, I want to step back and talk in a little more detail how you can do videos, screenshots, and also do a trace report of your work. This is something very important, because no matter how good work you do, it pretty much doesn't matter if you cannot document it properly. So luckily, Playwright has some very good, actually great tools to document your work by taking screenshots, videos, and trace reports completely automatically, just with a few lines of code. So to do that, I'm going to create a new file that will be called test.doc. Okay, great. So here we're actually not going to write any new tests, because we already have created plenty of those. So let's go to our test navigation file and just copy the whole test where we're testing Instagram. Actually, here I will write test Instagram. And also let's go to test inputs and copy all the Facebook tests. So here we have test Facebook, just copy it and paste it in your new file. Okay, so we will modify those tests. Actually, I will leave the test Facebook empty for now. And so as I want to progressively show you how you can save your work, let's first talk about screenshot, or how to take screenshots automatically from the code. Now, this is pretty simple, and for example, if I want to see the page after these first 3 steps, I can simply do page.screenshot, and then you can select the path of the screenshot. If you want to leave it in the same folder, you simply write path equals to the name of the file. So let's call it sc1.png. Okay, so this is your first screenshot. Let's copy that, since we're lazy to write too much. And let's say that once we go to our login page, which is going to be here after we click on the number or email, we would like to make another screenshot to see how the page looks there. And maybe finally, after we add all the fields, after we add the information for all the fields, maybe we would like just in the end to do the last screenshot, maybe just before pressing the sign up button. So this will be sc3. So let's run our file, and we can do pytest test_doc.py --edit --slowmo, and let's do it just 1 second. So what we would expect, guys, is to see the page in front of us, and then automatically we should see 3 images into our tests folder. So let's run that command, and you can see that our page appears. We're switching through different pages, and now we put our login information. Okay, we will put our password as well. Okay, and then we sign up. Okay, so you can see that after this finished, we actually got our screenshots. So this is screenshot 1, 2, and 3. So on screenshot 1, we saw the page where we have trouble logged in, because this is where we went at first for resetting the password. Then screenshot 2 is the sign up page, and screenshot 3 should be the sign up page after we added all of our information. You can see it right here. So you can see this is pretty easy way to mark your work and see images from your test cases. Now, of course, for me this is not enough, so let's go to the next level and see how we can create a video and a trace report from the script. I know that I already showed you how to do this from the command line, but in order to automate it completely, you can add those commands right in your test cases, which is way more convenient. So let's comment out the test Instagram, and let's comment in our Facebook page. So in order to take a video, we will need to do that on context level, which means that here to this function, we can pass context, okay? And then we can make the page from our context, right? So for example, I can do context.new page, and the page will be equal to that, right? So since we already have the context, here in the beginning of the file, we can define how we're going to record the video. Actually, as a matter of fact, in order to create context, we actually need to have browser here, because always first we have browser, then we have context, and then we have page, right? So this means that here from this browser we can actually create a context. So just do context equals to browser dot new context and simply write record video directory. Okay, and in this directory we're going to place our video. So let's do videos slash, and this is how we define a directory where we're going to locate the video from that page. Now, not only this, but you can also define what's going to be the resolution of your video. So if I go one step below here, I can write, actually let me write a comma, and you can do record video size, and here you can pass this as a dictionary, right? You can do width, let's say, would be equal to 1280, and height would be equal to 720. Okay, so this is a basic HD video. So let's run that test and let's see if we're going to have our video recorded. So you can do again Playwright test doc headed slow-mo 1000, and with this simple command here you will see how you can get a full video of what you're testing. So let's run that, and you can see we're going to Facebook, and we will basically fill all the parameters that we need right now. Okay, now we fill the password, then we select the dates, the year, the gender, and then we try to sign up. Okay, so you can see that after this was completed, now we have our videos folder, and we have our file here in the WebM form. So if I open the Playwright guide here, and I open the videos folder, and I select this file and drag it into my browser, you will see that we got a complete video from how we're writing the different commands into our browser. And this is how a video is done in Playwright. Now the final cool thing and cool feature that I wish to show you is how to do tracing from your browser. So if I remove our video context, right, and simply do context equals browser.new context, you can set the context tracing by writing context.tracing.start. Okay, and here you can define whether you want to have screenshots, snapshots, and sources. So let's do screenshots equal to true, and let's do also sources equal to true. So we're gonna record both of those parameters. So once you run this in your context, you can definitely define where you want this to stop. So let's actually stop after our submit button has been hit. So let's do here context.tracing.stop, and here you can define where you want to record your file. So let's call it tracing.zip. This is going to be a zip file, and then we'll review it together. So let's save that, and let's run our test again without a slow-mo. Okay, so let's run it, and you will see our page and the data added inside. Now, if you go back to your folder, you will find this file tracing.zip. So how you can view the file? You simply need to write playwright show-trace and then the file name tracing.zip. Okay, so if I hit that command, the zip file will get opened immediately, and you will see the report here. So when you hit, you can see basically the different screenshots from your browser, the data that we added, and basically what happened after that as well. So you will see the whole span of 1.4 seconds and each and every event that happened. On the left hand side you can see the actions, and you can select by actions with different data. You can also check the metadata here, and you also have the console inputs, the network, the sources, right? This is your test script, and also the different calls. So if you ask me, this complete report is very worth it, because this is the best way to document your work and see what happens second by second, actually millisecond by millisecond. So I hope, guys, this video was useful for helping you documenting your work. Thanks for watching this video in this section, and I will see you in the next one. Hi everyone, in this video we will start with our automation playground project, and I will show you many different examples and the solutions of those examples into the Automation Playground website. So let's get started. Now, as you can see, here is this website that is called UI Test Automation Playground, and this is a website specifically created for you to be able to test your test automation knowledge and the tools that you're using. So this is a perfect website for us to use in order to learn the Playwright functionalities, because here below there are quite a few examples of UI testing that you can work with, and I choose a few of those tests with which you will be able to explore more of the Playwright functionalities. So the first test, or actually the first problem that we will solve in this video, would be the load display. So let's explore what the task is here. So you can see that when you hit this button, you're getting something to load and there's a page that appears. So as I said, every task would be different, and this task comes from the idea that sometimes when you want to enter a web page, the server that has this page might respond with unpredictable delay. So the aim of this test is for your test code to wait until the page has been loaded and not fail before that. So the task, as you can see here, is to go to the home page of the UI testing playground and to click the load display link exactly how we just did. Then there will be a timer for loading the page, and while this timer is still running or the page is not loaded yet, our test case should wait until we move to the next page. And after this is loaded, I will also make sure that our test script hit the button appearing after delay so we can prove that everything works properly. So let's see how we can do this in Playwright. Now the first thing that I will do is I will actually create a new Playwright project. So let's create a new project and I will call it UI Playground. Okay, so we'll use Python 3.10 for that project, and here you can see that we're now running the project. Now the very first thing, of course, that we'll need to do, since this is a new project, let's install Playwright into the virtual environment. So let's here in the terminal do pipe install pytest-playwright. Okay, and now this is installing in our virtual environment, and after that let's do Playwright install. Okay, and let's also install Pytest. So let's do pipe install Pytest. Okay, and now we have everything installed in our virtual environment. So let's create a new test, and here's where we're gonna run the load display test. So let's do new Python file, and I'll call it test load display, and I'll create a new test case here. So let's do def test underscore load display, and let's put the page here. Okay, so the very first thing that we want to do is to actually go to the UI Playground website. So you can do page.go-to, and here we would simply need to copy and paste the website. So this is the UI Playground. Okay, and we actually don't need the www here. So let's first run our test and see if we're going to go to the actual website, just to prove that everything works. So I will simply do pytest and then testloaddisplay.py, and after that I will do headed so we can see what's going on, headed, and then slow-mo of 2 seconds. Okay, so let's see if that is going to work. Okay, so you can see there is a page loading, we go to the website, and then we exit the test. Okay, that makes sense, so everything works fine. So since everything worked, we can be sure that now we can actually enter this page and Playwright is working. So let's continue. Now, the very first thing that we would need to do is, let's go back in the page. We need to make sure that we select the load display. So how we do that, it's actually very simple. We simply need to locate the field, so page.locator, and we'll search for a locator that has text load display. Okay, and we'll click it. Okay, so this is the action for clicking this button, and then let's actually make sure that once we clicked this button, we actually go to the next page, that is the load delay page, so we can make sure that our script is actually waiting until we reach it. So let's do page.url. Okay, so we're checking here the URL, and then I would want to actually have the URL of the actual page. So what I will do is I will simply click Ctrl C to copy it, and then I will put it in parentheses. Okay, so now we make sure that we actually reach this page here, and finally let's click the button appearing after delay, okay, which is this button here, and that is also very simple. Let's do page.locator, and then let's do text equals button appearing after delay. Okay, make sure that this is exactly the same as the text that you see on the button. Even if you're not sure, make sure that you copy it and paste it there. So let's do click. Okay, and this will basically end our test. So let's use the same command here, pytest test load display headed slow mo 2 seconds, Actually, let me make it 1 second so it executes faster. And let's run it and see what happens. Okay, now you can see that we're going to Automation Playground, and you can see that actually nothing happens, which means that we did something incorrect with the test. So let's go back and see. So yes, here I wrote load display instead I wrote load delay. Okay, so let's change that and let's run the test again. Okay, so you can see that we're going to the web page. We're waiting now for the load delay page. Okay, and you can see that our test failed. So I suspect what the reason is, but let's check it out. Yes, so the reason is that here in the page URL I actually had www, which is not the exact name of the page when it's loaded. You know, here you need to be very precise. So I'll simply need to remove the www in order to avoid this assertion error here. So let's try again. Okay, let's run the same test and see if it is going to work now. So we go to the page, we select load delay, and after we enter the page, our script is checking for the URL. It is correct, so our test, as you can see, is passed. So this is how you can create a simple test, and as you can see, Playwright doesn't need to have additional line for waiting for a web page to appear. It does this automatically. And if you remember, in the previous videos I actually showed you one table that was actually called Autowaiting, and you can see it now in front of you. And you can see that for the click you have actually auto-waiting of some seconds, and this automatically, you don't need to specify it for absolutely every test, because in many cases the waiting is absolutely necessary, so Playwright does it automatically. And this is why we didn't need to add anything complicated into our test case, which is not the case with many other automation test tools. So this was the first test and the easiest one, guys, for this section. Thanks for watching, and in the next video we're going to talk about the AJAX data and how you can manipulate it. Hi guys, and in this video we're going to talk about how you can manipulate AJAX data, and I will show you how we can resolve AJAX data based tasks from our Automation Playground webpage. So if we go to the Automation Playground, and here you can see the AJAX data task, and here is the introduction. So some elements may appear on the page after loading data with AJAX request. And you know, AJAX request, for example, is typically an HTTP request. So we're going to test what happens when we do those type of requests. Now let's go to this page and let's see what is there. So here's your task. So sometimes an element could appear after processing an AJAX request to web server. So the test should be able to wait for the element to show up. So this is another wait-based task, but this time we're having AJAX data. So what the goal of this task is, our test should automatically press the button below, wait for 15 seconds, and check on the next loaded label. Let's see how this is done. So let me press this, and now the 15 seconds will start going. And after those 15 seconds are done, we will need to make sure that the test is waiting for this label to appear, and we'll actually check if this label appeared. Okay, so this is the goal of the today exercise. Now, if you feel already confident with Playwright, I would advise to stop this video and try this out yourself. In all other cases, you can just follow up and see my solution. So there are a few things that we need to consider when we want to firstly select this button and then check for this tag here. Now this tag here, in order to check if it appeared, or to locate it, or to use locator in order to find it, I don't want to use the text, but I want to use the specific ID or class of this tag. And how you can do that? Now if you select inspect, you can see that the class of specifically this window here is called bg-ss. So you can locate this element by this class here, and I will show you how this is done. But let's first make sure that we go to this page from our Playground website and then click the button. So I'll create here a new test case. I'll call it df test ajax, okay, and I will pass page here. So after that, let's do page dot go to, and we'll go again to this website here, to the UI Playground. Okay, let's remove those additional brackets, and after we do that, let's go to the AJAX Data, or let's select this button, and this is done by page dot locator. And after that, let's do text equals AJAX Data, which is actually exactly the name of the button. Okay, let me actually go from another page. Okay, so you can see that here we have AJAX Data. You can actually simply copy this and paste it here. It's exactly the same. And then let's do click. Okay, so we go to the AJAX Data task, and after that, let's do assert, just to make sure that we actually went to that page. So page dot URL equals to the domain name slash AJAX. Okay, and now the next step would be to hit this button triggering AJAX request. Okay, so you can either actually refer this button by the text, or also you can refer it by the class, and this is called btn-primary. So let's refer this button by class too. I will do here page dot locator, and let's do bg actually dot bg dash primary. Okay, and then let's do dot click. So now we click this button, and after a certain amount of time we would like to see our success tag. Okay, and there are a few things that we want to check for. First of all, we want to check that the tag actually appeared, right? We want to wait until the tag appeared, and we want to make sure that this tag has specifically this test. So we need to locate the tag with a tool that doesn't include this text, and actually check after that if the field has a text. I will show you how this is done. So it's done in a single step. So you can use the expect keyword. So let's use expect, and you can see that in order to use it, you need to import it from the Playright. Let's do sync API. Okay, so you import it here, and let's do expect dot actually break it. And first of all, we need to locate the element for which we want to expect certain action. So as I said, the element will be bg dash success. Okay, and after that, let's do dot, and we can use the option to have text. Okay, which means that we're checking if this element has the text that actually appear here. So I will copy this text and I will paste it right here. Okay, and also another thing that I want to do is I want to give it a timeout of 16 seconds. So let's do timeout equals to 16 seconds, which means that if this doesn't appear within 16 seconds, then our test would fail. Okay, I did a little bit of reformatting in order for this line to get fit in a good way in our test case. And the only other thing that I will need to do is, since the timeout is actually in milliseconds, I will need to write 3 zeros here. So this refers to 16 seconds. Okay, I will comment out the previous test, and I will again run this file with the headed command and slow-mo if equals to 1000. So let's run that and see what happens. Now you can see that our page appears. We'll go to the AJAX Data, and our test failed because here I didn't refer it with the right tag. Here it should be actually btn, okay, dash primary. So let's try it again, and here I run the test. We're going to the AJAX Data, we hit the button, and now our timer for 15 seconds is going. So if our text doesn't activate in that time, our test is supposed to fail. So let's see, now we're waiting for the text to appear. It appeared within 15 seconds, and as you can see, our test is now passed. Okay, so this is how you can wait for the AJAX Data and to expect what text is going to get appeared with a certain button within a certain timeout. And this was everything I want to show you for today, guys. Thanks for watching, and in the next video we will talk about how to deal with clicks. Thanks for watching. Hi everyone, and welcome back to the course. Clicking requires a special attention for every automated test framework because this is the most commonly used action on every web page. So for that reason, the UI playground actually has this click test, and the reason to have this test is that when you're building your web page or application, clicking on certain elements do not always work. So here's your task. So for every different browser, sometimes when you click on element with a mouse, this action is handled in different way. So sometimes you can click on an element, but this element might not do the action that you were expecting. So what we will do in this test is we will record a button click, and this button will become green after we click it, so we ensure that a click action has been performed. So basically our test will just make sure that we're able to click the button, and we will check if the button has been clicked successfully. So let's first inspect this button and see what is its class. So you can see that the ID is bad button, and we have button primary. And after we click it, you can see that the tag here changes to button success. So we can use this change in the tag in order for us to check if the element has actually been clicked. So since we already know what to do, let's go back to the PyCharm and write our test case. So let's write a new test case here. So I will do def test button change, okay, and here I will pass page. And of course, the first things that we will need to do is to go to the UI playground, which I will copy from here because there is no reason to lose our time on that. And after that, we will go to the click page. So let's do page dot locator, and here I will refer it in a different way. So I will do a has text, and we can do here click, okay, and this is how we locate the button. And then let's do click. So we enter the click task, and after that let's actually check if we're on that page. So I will do assert page dot URL to be equal to the domain name of the UI playground, okay, and then I will do slash click, okay. So we're checking if we're on the right page. Now, as I said, the first thing that we'll need to do is to click this button, and if I go back and I select click, you'll see that this button is called btn-primary. So this is the tag that we're going to use initially, and then we will check if this tag actually changed. So let's do expect page.locator, and here I will select the tag of the button, so it's btn-primary, okay, and then let's do dot to have text, and we will check if the button has this text that is called button that ignores DOM click event, okay. So let's paste it here, and I'll put it in parentheses, okay, and then let's click this button. So let's do page dot locator, and again I will use the same tag. So let's do btn dash primary dot click, and after we click it, what we would expect is that the tag of this button changes to btn dash success. So what we can do is do expect page dot locator, and here what I can do is btn dash success, okay, and then to have text, okay, and we will check for exactly the same text, okay, because the text on this button doesn't change, but what it actually changed is a tag. So let's first comment out the previous test, and then let's run this one with 2 seconds delay, okay. So let's run the file, and you can see that we're going right here in the web page. We select the click, we check the button, and then the test passes. And this is because our assertion and our expect statements are all passed successfully. So this is how you can find a very useful strategy for how to verify that when you click on a button, the actual action that you're expecting happens. So use this test and approach for your future tests, and in the next video I will give you a very interesting task on how to work with text inputs. Thanks for watching. Hi everyone, and welcome back to the course. In this video we will talk about how you can work with text inputs. So let's go back to our PyCharm course, and actually, as you can see, I wrote a few tests in our first Python file, but for this video I'm going to create another one. So let's create a new Python file, and I will call it test inputs, okay, and this test will be a little bit longer than the ones in the previous videos, so let's talk about it a little bit. So let's go into the text inputs, and let's select this one here. So here's your test. So you can see that you have a field here, And in this field, you can write wherever you like. The idea is that if you press the button will take the name of or the text of what you wrote here. So if I do Martin and I click the button name will change to Martin. However, if I write something else, let's say event, but I hit enter instead, then the button will not take the name, but instead the whole page will actually restart. Okay, so this is what we're trying to do here, and we will do a few steps into our test case. So the first one would be to write a few names and click the button and make sure that the button name actually changes. We need to verify that. And also we're going to do one test for clicking enter and making sure that the button doesn't take the name of the field. Okay, so I hope everything is clear. Let's go to our test file and see how we can test that. So let's first create a test case. So let's do test underscore form and let's do page, and then let's do page dot go to, and again we're going to go to our UI automation playwright page. Okay, then let's go to our test input task. So let's do page dot locator, and here in the brackets I write text equals text input, which is the name of the link, and then let's do click. Then let's make sure that we actually went to this page. So I will do page dot URL to be equal to the automationplayground.com/text input. Okay, and after this is done, let's click the button. So in order to click the button, we of course need to see what is button's class and name. So as you can see, the button class is button primary. Meanwhile, the field that we need to write something into is called form control, or you can use a placeholder my button in order to access it. So let's use the form control class here in order to say that we want to click on this field. So I will simply copy that and go back to our page right here, and let's do page dot locator, and let's do parentheses, and inside I will do form control, actually dot form control dot click, and after that after we clicked it, let's write something inside, and you can do that by writing page dot locator, and then we can write the same tag inside dot fill, and let's write here new button name. Let's actually test if our test case is working so far until this point, and then we'll continue with the rest of the lines. So let's do Pytest, and here we need to change the name of the file that we want to run. So let's do test inputs. Okay, so let's run that and see what happens. And yes, you can see that we're going to the playground, then we click on my button field and you write new button name. Okay, which means what we've done so far, it works perfectly fine. Now the next task that we will need to do is to click on the actual button. So you can do that by writing page dot locator, and in order to click on the button we will need its class name, which is button primary. Okay, so I will copy this and I will do dot button primary dot click. Okay, and the next thing that we will need to do is to check if the button primary actually has the text of the new button name that we set it right here. So you can do expect. Okay, and let's import that here from Playwright sync API. Okay, and let's first write the locator. So page dot locator to be dot button primary. Okay, and we want this button to have a text the same as the text that we passed, new button name. Okay, so with that line we would actually make sure that our button actually took the name of our field, right? So this is how we test the first test case. Now let's test what would happen if we write another name into the field, but instead of clicking the button we hit enter. What we would expect is that our page would update. So how we can test that? You can do page dot locator, and here we would do dot form dash control dot fill, and let's write here new name. or let's do newer name actually, newer name. Okay, and after that let's hit enter. So let's again do page.locator, and I'll copy this, okay, and I will do dot press, and let's do here enter. Okay, and after we do that, what we'd expect is that our button will not have the name that we passed, which is newer name. So in Playwright, you can check that in a pretty simple way with the expect keyword. So you can do expect page.locator, and here we're going to observe the button primary. Okay, so let's do button, or actually btn dash primary, okay, dot, and here instead of to have text we can do not to have text. Okay, so we would not want our button to have text, newer name, okay, exactly the one that we passed. Okay, and after we do that, let's again write another name into the field, such as let's do hi, and let's check if the button would have this name after we click it. So I will again do page.locator primary button click, and after that I would want to expect in this button that we have the text hi, right? Just to make sure that the button works after we press the enter key. So if you are not fully clear about what these lines of code will actually do to our test case, let's run it and you will see it step by step. So let's do Pytest test inputs, headed slow-mo 2 seconds, and let's run now our test case. So you can see that we're going to the text input. Firstly, we would write the new button name, we would hit the button and it will take the name, then we'll write newer name, it updates since we click enter, then we write hi, and the button takes the name hi. And since everything that we wrote in the test case has been met, for this reason the test case here is passed. Okay, so this is how, guys, you can check if a field has certain text or if a field does not have certain text. And I think these are the most important points of this video here. So that's it. Thank you very much for watching. And in the next video, I will show you specifically how to create test cases, real life test cases working with scrollbars. Thanks for watching. Hi guys, and welcome back to the course. In this video, I will show you how to find an element by automatically using scrollbars using the Automation Playground test cases. Now, the best way to show you how this test should be performed is by simply showing you the Automation Playground, and if I go back, you can see that here we're having the scrollbars test. So here nothing is visible, but if I start scrolling, you would see that we're having two scrollbars, right? One for down and one for left and right. So the task here is for your test case to scroll these bars out, and while scrolling them to find this hidden button. It's somewhere here, right? So to find this hidden button and click it. In that way, we will exercise how our test case is actually scrolling the scroll bars, finding the button and clicking it. Okay, so the main outcome from this video would be how you can actually move the scroll bars, and both of those have to be moved maximum to the bottom and maximum to the right in order to find the button. So we use that in our test case. So let's create a new file here, new Python file, and I'll call it test scroll. Okay, and our test case will actually take the same name. So first of all, let's actually do from playwright.sync API import expect, okay, because we use the expect keyword in this test case as well. And the first few steps, you already know them. So let's do def to create a test function called test underscore scroll, and I'll pass page here. Okay, and after that, let's do page dot go to, and we'll go to our UI Automation Playground website, and we will click the button scroll bars. So let's do page dot locator text equals scroll bars dot click. Okay, and after that, let's assert to see if the page actually appears. So page dot URL pretty standard steps equals to UI automationplayground.com, and let's do here scroll bars. Okay, and so once you did the assertion, the next step would be to click somewhere into this field right here. Okay, because we actually want that our mouse is somewhere here. So in order to click somewhere here, we need to find how this field is called. Okay, so let's see here. So let's write here page locator, and I found out that the text that we need to use in order to access that is this. So scroll bars, an application may use native or custom scroll bars in elements div. So this is the way that you can actually click somewhere into the scroll bar. Okay, and once you click there, actually if you wonder from where did I get this line, is from the code generator. You can also use it on the page and simply click there. So after you do that, you can do page dot mouse dot wheel. Okay, so wheel is when you want to scroll with the mouse, and you can do coordinates. So as you can see here, delta x and delta y. So since we want to scroll to the most bottom part and to the most right part, these are both in the positive direction. So if you do something like 100 by 100, this will make sure that we get to the most bottom right position. Okay, so once we do that, let's make sure that we see a primary button that has text called hidden button. So let's do expect page dot locator btn dash primary to have text hiding button, and you can even click it. So you can do page dot locator, and here let's write btn dash primary dot click. Okay, so this is how you can find hidden buttons or elements within a scroll bar, and with this line here specifically you can scroll. So let's see if that is going to be working. But before running the test case, let's actually add a dot here so we can locate this button. Okay, because I missed the dot. And let's run the test case now. So let's do pytest test scroll headed slow-mo 2 seconds, and let's run that and see what happens. So you can see we go to the UI playground, and notice here the scroll bars. We first move it right and then to the bottom so we can see the button, and then we clicked it. Okay, so you can see that everything here works completely fine, and we got the expected result or the primary button with the text hiding button. So we found our button by using the page.mouse.wheel in order to do a scroll action automatically using Playright. So that was everything for today, guys. I hope this video was useful for you. Thanks for watching, and in the next one we're going to do a little bit more advanced task here, which is going to be how you can work, find, and compare elements in dynamic tables. Hi everyone, and welcome back to the course. In this video, I will show you how to work with dynamic tables using Playright and the automation playground. Now, if you don't know what dynamic table is, I will show you a real simple test case that involves dynamic tables. And so here is our dynamic table task from the automation playground, and the idea here is that this table is updating constantly, right? So if I update the page, you can see that the places of the different data changes and the actual data changes as well, right? So the idea is that you can create a test case that can track always the CPU percentage of Chrome and compare it with the CPU percentage of Chrome into this warning bar here. So this is quite a difficult task sometimes because the field where Chrome is, first of all, changes its position, but also at the same time, the CPU percentage also changes. So you need to find some way to detect specifically where the Chrome data is, to locate specifically at which position the CPU information is, take this information and then compare it with the CPU information that you have here in the warning bar. Okay, so this task would involve creating a little bit more complex for loops in order to check our data, but trust me, with Playright, this task is done in a way more simple manner comparing to the rest of the test automation tools. Of course, here you will need to add some more logic, programming logic that needs to come from you, but I will show you how this is done and what is my solution for this very interesting task. Now, the first thing is, actually let's close all of those elements, and I'll go to the UI playground and create a new task, test dynamic. Okay, and let's create a new test case that is called test dynamic, and let's pass the page here. Okay, great. So let's quickly do the first elements of every test, or to go to the page dot go to, and then let's go to the UI automation playground. Let's do then page dot locator, and we will locate the dynamic table, and then we will click it. Okay, this is the dynamic table test. And after we're there already, of course, we want to assert and make sure that we're on the right page. So let's do page.url equals to UI automation playground, and let's write here dynamic table. Okay, so once we made sure that we're on the correct page, let's see how we can actually test that. So we sort of need to create a variable that can actually take the values from the fields that we need. Now, the first thing is that from the Chrome CPU, this is pretty much static, so it shouldn't be that big of a struggle to take the information from here. So the problem is that not only we need to take this line, but also we need to split it and get just the percentage amount. How we can do that? Now let's first find what is the tag of this field so we can locate it. Now you can see that is called bg-warning, so I'll copy that, and we want to pass the percentage to a variable. So let's create a variable called warning or war variable. Okay, and here I will do page dot locator, and I will do bg dash warning dot all inner text, and this should actually get our text or the inner text from the field. Okay, so I don't know in what form exactly this text is going to be, so let's first print the variable and see what we get. So I'll run this test case. Now I will select this button here because if you run the test case from the Python console, you can actually see the print outputs, while from the terminal you cannot. So I'll hit that. Let's run the Python test, and you can see here now the test case is running, it is passed, and let's see here below. So after the test executes and is completed, you see that we're getting our print statement, which is Chrome CPU, and then the percentage. I can see that this is a list field in which we have a string. So since this is a field, we can take the 0th element of this list. Okay, and let's run the test again. I would expect that here we will see just a string. So let's run that. And yes, you can see that here now we have just a string. Okay, so we're getting closer. So since we have a string, we can actually split it with the Python split function. So let's do dot split, and let's split it on every empty space. Let's run it again and see what happens. Okay, so you can see that since we split it, now we get a new list that has each of those elements separated, which is great. So what I only need to do is to get the last element, which is 0, 1, 2. So we need the second element, 2. And I assume that when I run the test again, I would just get the CPU percentage. Yes, you can see that now our warning variable is equal to 0.7%. Actually, also in Playwright, you can use another function that I think would give you the string straight without the need to convert to take the element from a list. So it will not give you a list but a string. So I think you can do that by just writing inner text. Okay, and now if I remove this part here, I think I will get just a string, right? So let's run the test case. Okay, yeah, so we can skip the list conversion by simply writing inner text, and then if I split it and take the second element, we should again get the CPU percentage. So let's run that, and you can see that here we have the CPU percentage, which is exactly what we need. So I remove the print statement since this statement was only for debugging, and then I will continue with the rest of the code. Now, here it comes the little bit more complicated part. Now, since this table is updating constantly, what I want is to get the information of every single field of a table and then add certain logic in order to find the right value. So let's hit on this table, inspect. Okay, and let's think of what we can do here. Now, the first thing I can notice is that first of all we have div and we have row, so every row is named in the same way. So I cannot simply take the row that has the Chrome, so this wouldn't work. But then I can see that within every row we have this span variable, and this is again the same for absolutely every variable. So maybe if I can use this span variable, I can access all the variables, put them in a list, and then take what I need from that list. So that might work. So let's try that. For a locator, I'll use the span and then the cell row here in order to get all the variables. Let's see if we can do that. Now, let's first of all create the variable called table list, and then let's do page dot locator, and I will do here span and then row equals to cell. Okay, and this should actually locate absolutely every cell within that table, and then let's place that to a list. So let's do all inner text. So let's print that. So let's print table list. Okay, and let's run the test case and see if we're actually going to get a list of all the variables from that table. So let's run that. And okay, this failed. So I would assume that I did some mistake here into locating the variable. Yeah, so row here should be equal to cell, so we got syntax issue. Let's run it again. And you can see that now the test case is passed. So let's go below and see what we printed. So exactly how I thought, now we're having a list with absolutely all the variables from the table. So you can see we have system, then we have Chrome, Internet Explorer, and all the variables. Now, here it comes another problem. Usually, what I could do is I could simply select the element. For example, this is 1, no, this is, so if the system is 0, we have 0, 1, 2, 3, 4, 5, 6. So this will be our sixth element, right? So I would usually just do 6, and then I will assess the Chrome percentage. The problem is that not only the position of the percentage is changing in front of Chrome, but also the whole Chrome data is also changing within this list. So you will see what I mean. If I run this and you expect to get the percentage, you're actually not getting the percentage. Now you're getting the megabits. And if I run it again, you would get another element, because as you know, this table is completely dynamic. Okay, so every time you would get a completely different thing, a completely different field. So we need to find some logic in order to get exactly what we need. So when I look at the table, what I notice is that even though the Chrome data always changes, right, I can see that there is a way to get all the elements for Chrome, which would be to find the index of Chrome, which is easy, and then increase it with 5 and get all of those elements. And then within those elements, I can find which one has a percentage sign right here. So I hope my idea works, and let's try to implement it. So let's first get the Chrome values. So if I do here Chrome underscore values, and this would be equal to table list, okay, and after that, and so we can take just a portion from the table list. Usually in Python, if you want to take a portion of a list, you first write the start element and then the end element. Okay, so if I do table list from 0 to 5 and I print the Chrome variables, you see that we'll get some random Chrome variables here, right? So for example, we got those for the Internet Explorer this time. Yeah, but what we want to do is to actually find the ones for Chrome. So let's see how we can find the first element, because we want the first element of the data that we extract to have the keyword Chrome. And this is very simple to do in Python. So let's do table list dot index, and we will find the index of Chrome. Okay, so what will happen is our code will search in the list for the word Chrome, and it will take this index and place it here. For example, if the Chrome has the index 0, here this will be 0. If Chrome has another index, this will be another index. Okay, so we'll start from here, and where we want to end is 5 positions from that index. So Chrome plus 5, okay, and this will get all the elements from the keyword Chrome until the end of the Chrome data. Okay, so let's see if that works, and we're getting only the Chrome data. So let's run this test case again. Okay, and you can see that here now we're getting only the Chrome data. Let's run it again just to make sure that even if the table updates dynamically, we're getting the same result. So let's see. Yes, so every time we're getting the Chrome data. However, you can notice that the CPU percentage always changes its position, right? So now we're dealing with another problem. So first time it was in the end, now it's in the middle, and we need to find it. The problem here is that we cannot use the same methodology because we don't know what is going to be the number here. So I cannot simply say, okay, give me the field that has 3.7%, and then I get it. No, because this number will update constantly. So we need another approach. Now, first of all, let's create a table value, okay? And this value in the beginning will be none, but then I'm going to write a for loop which will actually find our percentage value. So let's see how this is done. Now first I will loop over every element into our Chrome values list. So if I do for I in Chrome values, or actually let's make it more descriptive, and I will do for value in Chrome values, and I will check if there is a percentage symbol into the value, okay, then what I want to do is to assign this value to the table value, okay, and then since I'm not expecting that there is a percentage sign in any other field, I will simply break this Chrome values loop, okay, this for loop will be broken, okay, and then let's print the table value just to make sure that it has the CPU percentage value. So let's run the test again and let's see what happens. Okay, so you can see that we're really here getting the CPU value, which is a percentage value, right? So now, as you can see, we're having the warning variable and the table variable, okay? The only thing that is left to do now is to compare them. So we can simply do assert table value to be equal to the warning value. So if both of those are equal, then we can make sure that our test case is passed and we solved the dynamic table issue. In order for our test to be a little more descriptive, I will just make sure that I print all the values. So let's do print, and I will do here warning value, okay, and I will write here the warning value just to make sure that they are equal visually as well. Then I will print table value, okay, and here I will do tab underscore val, okay, and then I will assert them. So let's run the test case and see what happens. Okay, so the test case is running, and you can see that here we're having the warning value of 3.2 and the table value is also 3.2. Okay, you can see that both of those values were taken in a different way from different place, but they are equal. So this is how, guys, you can sort the warning value issue with this for loop and with the very smart way of extracting step by step the exact information from the web page that we need. So that's it, guys. Thank you very much for watching this video. I hope it was interesting for you. To be honest, this was one of the most interesting tasks to code for me so far in this section. Thanks for watching, and I will see you in the next one. Hi everyone, and welcome back to the course. In this video, we'll talk about how you can track a change in your elements on your web page in real time. and how you can make your test case do the same thing. So here, as you saw from the name of this video, we'll talk about progress bars, and let's select this progress bar test case into the UI playground. So here is a test. So once you click the start button right here, the progress bar will start increasing, right? So the percentage will increase. Now your test case should notice when the bar is at 75% and then stop the test case. So it should track if it reaches the right amount of percentage and then click the stop button immediately after this happens, no matter how fast the progress bar is moving. This will really prove that your web application has implemented properly the stop bar and actions are happening non-stop until we reach the 75% mark. So let's see how we can code that. So here into our UI playground project, I will create a new Python file called test progress. So let's create a new test case here. Let's do def test progress and I will pass page here. And after that, guys, we will do the standard steps. I will just copy and paste them because you've done this already plenty of times. So we would first go to the UI testing playground and then we will click the progress bar test. And then we will simply assert if we are on the right page. Now, when we do this first three steps, which we do for every test case, now it is time to actually start testing the progress bar. Now the first thing that we will need to do, as we already discussed, is to select the start button. You already know how to do that, and in this case I will do that with page dot locator button has dash text start. Okay, so this is the tag for our button dot click. You can also use the class of this button. You already know how to find this. For example, you can hover over it, select inspect, and you can see that the button is called button primary, while the other one is called button info. So you can either use the class or the name of this button. Okay, so once you click the start button, then we need to track when our progress bar has the number 75 written inside. So to do this, you can wait for selector, and this means that in Playwright you have this function page dot wait for selector, and this function here waits until a selector that has certain attributes appear. For example, if your bar is increasing the percentage inside, until this percentage gets to 75%, the selector will not activate, right? So the Playwright will be waiting for that. The idea is once this button is populated with the number 75, then the test will continue. Okay, so this is why I'm using this function here. Now, how we can actually refer our progress bar? Let's see that. Now, if I hover over here, so let's do inspect, and you can see that this is the progress bar, and you can see that you can use either of those tasks that involve the 75% mark. Now, since I can see that area view now has specifically the 75 inside, I can simply make sure that this parameter shows 75 before moving to the next steps. And if I stop the test case and I start again, you can see that this number continuously increases, right? Until we hit the stop. So if I check for the area view now, I can simply track this number that is constantly changing. So let's do that. So let's write parentheses. And then, as I said, we're gonna track the progress bar. So let's do progress bar, and then let's do area. Also here is value instead of view, so it's area value now equals to 75. So once we have the value equal to 75, then we will pass this step here. So we'll be waiting until this happens. Okay, and once this step is met, then we would want to press the stop button. So let's do page dot locator and then button has text stop. Okay, and then let's do dot click. Okay, so let's save that and let's see if that is going to be working properly from the first time. So here I will just change the name of the test case, and this will be test progress. And actually I remove the slow motion since here we're time sensitive, so I don't want to add that. Okay, so let's run it and let's see what happens. So we selected the start button and now we're waiting. So let's see if we're going to stop the test case at 75%. Now you can see it's at 50, 53, 54, 56, 58, 59, and soon we're gonna reach 75 and we'll have to press the stop button. Okay, so you can see that once we reach 75, the stop button was pressed immediately and the test was aborted. Okay, and you can see that this test is actually passed. So this is how, guys, you can track for particular text or statement into your field or button. I hope this video was useful and thanks for watching. In the next one, we're going to do some login tests. Hi everyone and welcome back to the course. In this video, I will show you how you can test a sample app, mainly the login functionality, into our UI playground. So as you can see here, we're into the UI playground and you can see that there is this test sample app. So if I click it, here you are getting a login page in which you need to write a random username and the password is PWD. So let's say if I do Martin with password PWD and I click login, you can see that here I see welcome Martin and then I can log out. So this is what we're going to create a test case for, and this is what we're going to be exercising with Playwright today. Now let's go here into our PyCharm project and create a new Python file, and I will call the file test sample app. Okay, and here we'll create our test case. So let's create our test case. Let's do def test login page. And so I already copied and pasted the first three steps, which are to go to the UI playground, select the sample app, and then checking if we are on the right page. So now let's first go to the username placeholder, and you can do that by writing page dot locator, and then here I'll write placeholder. Okay, this will be equal to user / name. Okay, and this is our placeholder here, so let's click it. Okay, and now we can enter our username. So then on the next line we'll pretty much have the same locator, but here we're going to fill it with our username. In my case I'll write Martin, and after that I will want to go to the password field. So let's click tab, and so we're still going to be on the username, but here we're gonna press tab, which will place our cursor to the password field. And here on the password field we can actually again use the placeholder, which is those stars, to find the field. That might be the most easy way to do it. So let's do page dot locator, and then this would be our placeholder, those stars, which are 8 stars, and then let's do click. Okay, and then let's use the same placeholder dot fill pwd. Okay, so this will be our password. So now we have the user and the password already created, and the next step is to hit the login button. So let's do page dot locator and then text equals to log in dot click. Okay, and after that let's log out. So page locator equals to text that's equal to log out, and then let's do here click. Okay, so our test should be ready for executing. So firstly we go to the desired page, we click and then fill the username, we click and then fill the password, and we hit first login and then log out. Now how you can make sure that you actually logged in is if you go to this field here, this text, and you can see that this is text access, and you can check that on text access you have the name welcome Martin. Okay, so you can definitely do that to check if you're actually logged in. So what I will do here is I will use the expect keyword. So let's do expect, and I will import that. Okay, dot actually brackets locator or page dot locator, and here we're going to locate this field, which is text access. So I'll copy it and paste it here, test access. Okay, and then we'll do dot to have text. Okay, and then simply copy and paste this text here. Okay, welcome Martin. So if we see this text, this means that we successfully logged in. And on the same way, you can do it with the logout. So when I log out, this field here, if I inspect it, changes to text info. And what you can do is to write expect page dot locator, and here the tag will be dot text info. And this text info, we would like it to have a text user logged out. Okay, so let's save that and let's run our code and see if it works. So I will just change the name of the file here. This will be test sample app.py, and we'll run it with slow-mo of 1 second. Okay, let's see if it's gonna work. So we're going to the page, we select the desired test, we write Martin, then the pwd password, then we log in, we log out, and the test finishes. And since those expect statements are completed successfully, our test passes. If, for example, I change even one character of the expect text, you will see that our test will fail immediately when it reaches this point. So again, we're writing our username, then the password, then we hit the login, and you'll see that our test case is actually failing right here. And you can see the reason for that. It actually tried a few times. You can see that the actual value was welcome Martin, but what we were expecting was welcome Martin without a comma. So you can see even one character difference can fail your test. So we need to be very specific, which is exactly what we want when we're doing our applications. We need quality. So this is how you can log in and log out and check if those actions are successful using Playwright. Thanks for watching, guys, and I will see you in the next video. Hi guys, and welcome back to the course. In this video, we will show you how you can track the mouse actions in real time. And if you don't know what I mean, let's go to the UI test playground and let's go to the mouse over test. So here, this is a very simple test that asks you to create a test script that clicks on this click me link. Okay, so this is a link. And if you click once, you see that this number here increases. So as many times as I click it, the more the number increases. Okay, so the idea is that you click the link 2 times and then you check this number here that it shows 2. Okay, so this is how you can really easily check the number of clicks that the user performs. So let's see how we can test that. I'll create a new file, new Python file called click. Okay, and here we'll create a new test case. So let's do def click and let's pass page. So before starting, I actually think that you will be completely capable of trying out this test yourself. Please feel free to reattempt creating this test case, because I'm sure that with the qualities that you gained already, you can definitely do it. So stop that video, try it yourself, and if you cannot continue at some point, you can definitely watch the video until the end and see my personal solution. So let's get started. Now, obviously, the first 3 lines, I'm not gonna waste time over them, are to go to the UI playground, to click the mouse over test, and to check if we are on the right page. It is very good that we're always repeating this step, so it can really stick in your mind, and you can do that for every test case. Now, the next step is actually, you can create it in 2 ways. One of them is to do page.locator and to check for a text field, so text equals click me, and then you can do a click. Okay, and here, guys, you'll be clicking this button right here that has a text click me, and then you can repeat the action once again. Okay, also alternatively, instead of clicking 2 separate times, you can click 2 times one after another, so you can do double click. Okay, and this is also an option. So I remove this double click and I will just use the 2 clicks for simplicity, but I just want to make you aware that you have both options. So now, how do we find how many times we clicked? Now we can use this field right here where you see now 16. Okay, so if you just inspect it and you get the class which is badge light, okay, you can see that it has value of 16, so we can check that. So for example, if I click again, this value will increase to 17, 18, 19, 20 and so on. So this is what we're changing. Now if I go back here, obviously the first step is to locate this element, and how you can do that is by writing expect, okay, and here you do page dot locator, and the locator would be, as I said, badge light, and then we'll say to have text, and we want to see to there, okay. So let's save that, and I run our test. So let's see what would happen. So I will just change the name of the file to click.py, and let's do the slow-mo of 2 seconds. Yeah, so it couldn't find our file because I did a strategic mistake. Now I didn't write test before the click, so you need to do test underscore click in order for Pytest to detect your file. So let's go back here and let's do the same name, test underscore click, and also the test right here also should be test underscore click, so it's detected from Pytest. Now once we did all that, the test will be detected, and you can see that we're going to the page. We go to mouse over, you can see that we're going to okay, and you can see that we're clicking one time, and then we're clicking a second time, and after that the test is passed since this statement was met. So we have exactly the number of clicks that we were expecting. Now if, for example, I add another click there, okay, and then run the code, you will see that this wouldn't work because our field will get 3 clicks, okay. So you will see now we're doing 1, 2 and 3, and now the assertion will fail because we expect this field to have 2 instead of 3. So you can see that our test case just failed, and if you go into the assertions, you will see that we expected to have 2, but instead our field was displayed with 3. So this is how, guys, you can track clicks of the users into your web application. I hope this video was useful for you, and in the next one, which is going to be the last video of this amazing section, we will do a very interesting test where we will try to uncover a field and then enter text inside. Thanks for watching. Hi guys, and welcome back to the channel. So in this video we will talk about how we can deal with elements that are overlapped, and this is another test that I'm sure you can do it yourself, so I will advise you to try it yourself and then come back to the video. But let me first introduce you to the test that we will need to do today. Now let's click here on the overlap test, and you will see that here we have pretty much 2 fields, one for ID and one for name. However, the name field is partially covered, so it is a little bit difficult to write the information there. So what you need to do is you need to scroll automatically the name so it's visible, and then enter the text inside. And then of course you will need to check whether this was successful or not. So really try it yourself, I'm sure you can do it. But if not, don't worry, because I will give you the full solution in this video. So let's go to PyCharm and create a new Python file, and I will name this file test cover, and inside I will create a test case with the same name. So let's do df test cover, and I will pass the page here. So again, I will not go over the first 3 steps, which are go to the web page, click overlapped element test, and check if the right page appears. So let's first actually enter the ID. You can see that here we're having ID. So what I will do is I will simply enter ID of 1. So you can do page dot locator, and then let's do placeholder equals ID, okay, and then let's close that and let's click on the ID. And then let's copy and paste this placeholder, because there you will enter simply the number of 1. So let's do fill 1. And after that, the next thing I will do is I would want to scroll down. So let's do page.mouse. And then here we're going to scroll. So we'll do page.mouse.wheel. And we wouldn't need that much of a displacement, so I can do 0 and 15, which means on the y direction, which is top to bottom, we'll do plus 15, moving all of our information within the toolbar with 15 pixels up front. So okay, let's place that, and then let's do page dot locator, and let's hit the name button, so we can do placeholder name, okay, dot click, okay, and after that, into the name button, we will fill it with the word champ. Okay, you can see that here we're using the placeholder, but also instead you can use simply the ID, that is name. Okay, so it's the same thing, right, of this field. Even if I go right here and if I simply inspect the field, you can see that you can either use the ID, the type, which I don't advise to use the type because every button has the same type, and also the placeholder. So either the ID or the placeholder are good things to use here. Okay, and we'll add the keyword champ. So let's run the test. So let's do here test cover. So I'll do test cover. Okay, let's run that. You can see that the test is detected, and we'll go to the cover test. So here we're adding first the ID. Okay, and actually the test failed here because I wrote one as a number, but actually we need to write it as a string. Okay, so let's try it again. Okay, so here for the ID, we're entering the number 1, and after that for the name, we're going to enter the word champ, and you can see that the scroll bar movement worked completely fine. So this was all for this section, guys. Thanks for watching, and I hope those selection of videos were really useful to boost your playwright skills, and I will see you in our next videos. Hi everyone, and welcome back to this section. Here you create a complete GitHub project using Pytest and Playwright, and you will see a real-world example of how to use Playwright API testing. So here I am in the GitHub login page, and if you didn't know, Playwright actually has API support. So you can do API testing together with user interface testing using Playwright. So in order to be able to complete this project, you need to have a GitHub account and be logged in into this account. So let's do that. I have account already set up. This is a very simple registration. You simply go to github.com and you can easily create account from there by writing your email address and then continue with the registration process. So the idea of this project is to actually create a GitHub project in which your program will automatically create to-do tickets and move them to be in progress. Okay, so let's say if you want to create this functionality of GitHub for creating a project and different tickets into that project, you can do it quite easily with the GitHub API functionality. And this is what we're going to do in this course. So in this video, what I want you to do is to create a new GitHub project, and by the end of this video, we will have everything set up for us to start coding in Playwright. So in order to go to the next step, we first need to have a GitHub account, created project, and access token. So since we already have an account, let's create a new project, and I will select create a classic project, and let's name it Playwright Test. Okay, you don't need to do a description or anything like this. You just need to select the basic Kanban template for your project, and you can actually leave it private so nobody else can access it. So let's go ahead and create the project right now. So you can see that now, guys, you have this project created. It is called Playwright Test, and you can change the name, but we wouldn't want to do that. And so you can see there to do tasks, tasks in progress, and tasks that are done. We're going to test those two columns if we can successfully automate the process for creating a new to-do task and then moving it to be in progress using the GitHub API. Now, since we already have our project, the next thing is to create an access token. In GitHub, access token is something very important, and these tokens are used for you to be able to access your GitHub account from the terminal. So once you have the token, you will be able to access all the functionalities that you can do from the GitHub interface from your terminal using your code as well. So to do that, let's go to settings. And in the settings, if you go down here, you can see the developer settings. And from there, you can either create a new GitHub app, authentication apps, or personal access token. As you can see, I already have one access token. I will actually delete it because I don't need it there anymore. And I will generate a new token. And you can name this token. I will name it Playright. And also, you can select an expiration time. So since I'm using this for the purpose of this project, I will select 7 days here. And then you can select what actions you want the users to be able to do when they use this token. So I'll actually select absolutely everything. Okay. So make sure that once you create the token and you select everything, you don't share actually this token with anyone, because he will be able to assess your account with it and, for example, edit or delete your projects, which you don't want to happen without your permission. So let's create this token now. Okay, perfect. So now you have your token, you have your project, and you also have your account all set up. We will later use this code right here, this token, into our code and test cases. But that is going to be everything for this video, guys. Now we have everything ready, and in the next one, we will create and start coding our project. Thanks for watching. Hi everyone, and welcome back to the course. In this video, we will start creating our Playwright project, and the very first thing that we will need to do is to create our authentication fixtures, or those are the functions with which you're going to access your GitHub account. So let's get started. So here we're in the new project selection in PyCharm, and I will create a new project on my desktop called GitHub API. Okay. And I'll create this project. So here we have basically two files, and let's create those. The first one will be a Python file, and this will be called conftest.py, and these conftest files are actually automatically detected by Playwright, and the functions written there are running across all the Pytest test cases. So this is a very important thing to name this file exactly conftest.py. If you want to get, of course, more information, definitely feel free to Google it. Now, the next file that I will create is going to be the file that will have our test cases. So I write here test underscore GitHub underscore project. Okay, so here you have your GitHub project test file where we will write the test cases. But before that, we will, of course, write test cases in the conftest.py and then use them into our test cases right there. So now, before starting, I want you to go in the terminal and install Playwright and Pytest into your virtual environment. So let's do that by writing pipe3 install Playwright. Okay, and then let's do the same with Pytest. So let's do pipe3 install Pytest. Okay, great. And finally, let's install the integration between those. So you can do pipe install Pytest dash Playwright. Okay, perfect. So you have all of those libraries installed in your device. And let's now install our browsers. And you can do that by writing Playwright install. Okay, perfect. And once we have all this set up, then we'll create a few functions which are going to assess our GitHub username, GitHub password, and also GitHub access token. Okay, so we need to access those three elements in order to access our GitHub account with our test script. So let's see how we can do that. Now, the first thing is I'll create the test functions, and the first function I will create is def get env variable or get environment variables. So the whole idea, guys, here is that we create, let's say, a GitHub username into our environment, but not in our code file. Okay, so this variable will be available just in our environment, but nobody else will be able to see, for example, our password. And then those variables will be accessed from our code. And if that doesn't make sense for you at that point, don't worry, you'll understand it very easily in this video. So in order for this function to work, we need to have already created environment variables into our virtual environment. Now, how this is done? Now, if you are familiar with Linux or Mac OS, in order to create an environment variable, you need to use the keyword export, okay? And this is nothing related with Playwright or Pytest, but this is related with simply creating a local variables or environment variables into your device using Linux. In Windows, it is quite similar, but instead you're using the keyword set, okay? So again, for macOS and Linux, you use the export keyword, and for Windows, you use the set keyword in order to set variables. Now, if you do export, let's say, and then the name of the variable, so I'll call it GitHub underscore username equals, and then you can simply write your username. So since my username is martinyanev94, this is what I'm going to set here. And if you want to check whether the set of this variable or the export of this variable was successful, you can use the echo keyword. So if you do echo and then you can write the name GitHub underscore username, you will get martinyanev94. So I need to write %sign and the curly brackets in order to specify that this is a variable but not a text. If I don't write this, we'll simply print GitHub username. Okay, I hope that this makes sense for you. So the idea is that we create this environment variable in our environment and then create a function that will assess it from our code. Since we already started creating our variables, let's create our token and password variables. So I will do export GitHub password, okay, and then I will write my password. Of course, I will not show you what I'm writing in the terminal, but here you need to write simply your GitHub password. Okay, so after I have my password created, now the next thing is your token. So let's do export GitHub underscore assess token, and then simply go back to your GitHub account, go to settings, developer settings, personal access tokens, and then if you forgot what your token is, you can simply select regenerate token, select, let's say, 7 days if you didn't copy it at the first time, and then from here you can definitely copy this. Okay, so once you have it, let's go back and simply paste it right here. So this is your access token, and the final environmental variable that we need to create is our project name. So let's do export GitHub underscore project name, and this will be equal to your project name. So let's go back and check our project name from here. So if I click on my account and select your projects and select classic projects, this is our project here called Playwright Test. Okay, so this is our name. Let's copy this name and paste it here, Playwright Test. Okay, so now we have, guys, all of the information that we need to assess. So as I said, since we already have those variables, now the next step is to write some piece of code to assess them. Now let's create this get function, get environment function, and let's write here var name string. Okay, so this is the variable that we expect. The type of the variable that we expect is string, and also we expect our function to return string. Okay, this thing is actually not necessary. It just shows the future users that this function returns a string. Okay, and then I'll create a new variable here called value, and value will be equal to OS, which is a package into Python. So let's import it. So os.get env. Okay, so we're getting here the environment, and then let's write here var name. Okay, so basically to that function we're passing a variable that is a string. Okay, and then we're getting this variable from the environment. So obviously we need to create another line of code that is using this function, passing the variable name. Okay, then I will do a simple check to make sure that this variable actually exists. So let's do assert value, okay, and if the value doesn't exist, okay, this means that the variable doesn't exist. So we can write var name is not set, okay. So basically, if we don't have any value with the same name in our environment, we'll return this error code. And finally, let's return the value, okay, and the value will be a string. Okay, great. So now once we have this function, we need to create other functions that are specifically using the get environment variable with the username, password, and so on. So we need to create a single function for each of the 4 variables that we set up. So in order for us to be able to use those variables during our test cases, we need to create them as a fixture. So let's write pytest dot fixture and let's write scope session. Okay, so you can definitely have a look at the Pytest scopes, the different scopes, but the session scope runs while all the test cases are running. Okay, so this will be used across all of our test cases. Then let's create a function called gh for GitHub user. Okay, and here this will return a string, but it will not take any arguments. Okay, so let's do here return get environment variable, and so we're using here this function and we will pass the name GitHub username. So this is how we're going to assess our username. Now let's create the next fixture, and pretty much you can copy this, paste it 4 times, so 1 2 actually 3 times, 1 to 3 times, okay, and simply change the name of the variable. So the first one was the username, then we'll have GitHub password, okay, after that we'll have the GitHub access token right here, and finally we'll have GitHub project name. Okay, so those 4 functions will basically return our actual username, password, access token, and project name. And this is how, guys, you can get a variable from your terminal and use it in your Python code using Pytest and the OS function. Okay, so let's save that, and this will be everything for today's video. I hope you learned a lot. In the next one, we will create another fixture that will assess our GitHub context or the GitHub API. Thanks for watching, guys, and I will see you in the next video. Hi everyone, and welcome back to the course. In this video, we will talk about how you can create a fixture that is assessing the GitHub API. So if you go back to our conftest.py project, you can create a new fixture and we'll call it context. So let's do pytest.fixture and let's do scope equals to session. Okay, so under it let's do def gh underscore context. And before continuing, actually I noticed that in the previous video we didn't change the name of the functions, so let's do that. You can see that all of them are called GitHub user, which is incorrect. So for the password I will do gh password, and then we'll have gh token, and finally we will have gh project. Okay, so let's go back to the current function. Now we want to assess the GitHub API, and to do that we need to pass a few arguments to this function. The first argument will be called Playwright, okay, and this will take the Playwright class. So let's do Playwright here, okay, and I will import that from the Playwright sync API. Okay, and let's check what is that. So you can see that this is actually a class built in Playwright, and using this will return a browser with a new context or new page. Okay, so this is simply passing Playwright to our function, so we're able to assess a page. And after that, we're going to pass the GitHub access token function that we already created. So I will do here gh token, and this is gonna be of a type string, okay? And then this function is going to return a generated list. So you can pass here generator, okay? And this will be API request context, and then let's do none and none, okay? So we need to import both of those. Let's import this from the Playwright sync API. And the generator, we're going to import it from typing. So if you don't know what generator is, every generator pretty much has an iterator, send type, and return type. In our cases, we're not going to send or return anything to the API request context, and we're simply going to use the API request context to access the GitHub API. So if we go forward and press Command and click on the API request context, you can see that this is used to get and store all the API methods and display them into a context. So you'll see how this works. So let's put a column here. And so now we can start writing our function. So as we discussed in previous videos, you can modify every new context in Playwright. So if you're not quite familiar with what context is, you can pretty much see it here. A context is basically a browser or group of browsers that have the same functions, or browsers that have applied the same parameters, such as resolution, language that is used for the browser. Let's say our context 1 could be 1080p browser. Another context, let's say context 2, could have pages that are from another resolution, for example, for iPhone. Okay, so when I mention context, this means different browser pages that are having the same parameters. So those parameters, of course, can be modified, and when we call a context, we can specify within this function how our context is going to look like. Okay, so let's create a variable called request context, and this will be equal to playwright dot request dot new context. And here within the new context, we can specify certain parameters. We can specify base URL, and the base URL will be our GitHub API page. So let's do https api.github.com. Okay, and after that, let's do extra HTTP headers. And here we need to create the headers in another variable, and this will be basically everything that will be used after the base URL. Okay, so we would use here an accept header, which will be the page where we can pass our token, and also we'll pass our token as well. So I'll call the extra HTTP headers simply headers. Okay, and you can see that for now we have an error here, and this is because we don't have the headers file yet, but I will create it now. So let's do headers will be equal to a dictionary of two elements. The first one will be accept, okay, and this will be application slash vnd.github.v3 plus JSON, okay, and then the authentication would be token, and then the name of the token. And here we pass the token as a GH token, as you can see here, okay, and let's place comma between the two. Okay, so if that looks confusing, let's actually go into our browser and go to api.github.com. So let's go to api.github.com slash, actually let's first go to the API, and you can see here the different API functions, as you can see, and then let's do slash and place application slash vnd github v3 plus JSON. And you see that here we're getting another message, but we have message not found just because we don't have our access token. Okay, so once we wrote the headers and also the request context, after that we'll use the EOT keyword, and we use the EOT keyword in order to generate our generator function here. Okay, so if you hover over it, you'll see that the EOT keyword, or the statement in that case, it's used to create a generator function instead of a normal function in our code. Okay, so we're gonna yield the request context, so we use this instead of the return statement, and then we'll do request context dot dispose, or we're going to remove our request context after this function ends. So this is how, guys, you're going to access the GitHub API in 3 very simple steps: creating the request context, defining the headers that we're going to pass to this context, and then eout or return the request context and generate it with the API request context function. So that's it. Thank you very much for watching, and in the next video I will show you how you will be able to assess your GitHub project. Thanks for watching. Hi guys, and welcome back to the course. In this video, we'll create a fixture that will assess your GitHub project. Now you can see in front of you our conftest.py file, in which we're still creating the fixtures used during our testing. So we didn't create the test cases yet, but before that we need to create the fixtures used by those test cases. You can take this as creating functions which we're going to use for testing. So let's create a new fixture. So let's do pytest dot fixture scope equals to session, okay, and let's do def gh underscore project, and here this project would need 3 variables in order to get discovered. First of all, we will need the gh context function that we already created, and this function will be passed as API request context. Then we would need the GitHub username. So let's do gh underscore user, okay, and the username is a string. And finally, we'll need the GitHub project name, okay, and that will also be a string. And then this function will return a dictionary, okay. So once we do that, let's create a new variable called resource, and this is where we will define the path to our project. So let's do resource would be equal to f/users/ and here we will use our GitHub username, so GitHub user / projects, okay. And if you're unsure where this comes from, I will show you. It's very easy to grasp. So when I go to our GitHub page and I go to projects, you can see that we have first our username, okay, which is this one, and then we have our projects, and then you have certain number. But you can see that we can assess our projects by having our username, exactly what we wrote in our code, projects, and before the username is users. So our code is pretty much defining this path here in order for us to assess our projects, okay. So let's create a new variable now called response equal to gh underscore context, okay, and let's do dot, and we'll use the get method, which is a simple HTTP get method used to get certain data from our project. So let's do get, and let's use the resource, okay. So once we do that, in order to make sure that our response get method is completed, we can use the expect keyword. So let's do expect, and you will need to import that from Playright, from the sync API, okay. And here let's do response, okay, dot to be okay. And as you can see, the to be okay function pretty much checks if the API response request has been successful, which means that we received the 200 response, okay. As you probably know, if you don't know, you can check in Google HTTP responses and see that a successful response usually is response with number 200, okay. So if the response is with number 200, this means that our request or our response has been successful and we can continue. So this is what this function to be okay is doing. Then let's create another variable which will be called name underscore match, and we will check if the name that we are getting from our response is the same as the name of the project. So let's do lambda x in x name to be equal to GitHub project name. So GitHub project right here. Okay, so then we can filter that list using filtered. So filtered will be equal to filter name match response dot JSON. Okay, so this means that we're going to filter the name that we currently want, okay, from our JSON file, or we're going to transform the resource to JSON, and from there we're going to get our name match. And finally, let's do project variable, and the project will be equal list to list, okay. And here we're gonna do filtered, okay, at position 0. So this means that when we have our filter variable, this will be a list, okay. So it will be with only one variable, which will be our project name, and we want to get that variable actually and to assign it to the project variable here. Then we want to make sure that we actually have a project, so we're gonna assert project, which is the same as asserting project equal to true, okay. But you can see that this is actually not necessary. And then let's return our project. And lastly, guys, I also noticed that we have two functions with the same name. So this function that assesses the GitHub project has the same name as the one that has the project token. So simply change that to GitHub project name so we avoid confusion. And here I will do the same, GitHub project name, okay? And here again, GitHub project name, so we can define which function actually holds the project name and which function actually assesses the project. Okay, so that will be all for this video. Now we know how to assess our API, our GitHub API, how to assess the project, and in the next video I will show you how to assess the columns and the IDs from that project. Thanks for watching, and I will see you in the next video. Hi guys, welcome back to the course. In this video we will talk about how you can assess your project columns or tasks using Pytest and Playwright. Now let's go back to our conftest.py file, and here we will need to create one new fixture called okay, so let's do pytest.fixture. Okay, and I'm not gonna specify this time into what scope is that fixture, and let's do def, and I'll call it project columns. Okay, and so here I will pass a few variables to that functions. The first one will be our GitHub context, okay, or this will be our browser, and you know this one is of a type API request context. And then we'll have our GitHub project, okay. You can see that there is a reason why we create project columns after project, because we will sort of need to have this fixture here in order to assess our project before, of course, assessing the columns there. And GitHub project will be a dictionary, okay. And here, this function, the project columns, will actually return a list of dictionaries, okay. So this will be our columns. There will be a list of different dictionaries with a key and a value. Okay, so this is how the parameters that we pass and return from our function look like. And now let's start calling the function. Firstly, I'll create a response variable. Okay, so response will be equal to GitHub context dot get, and from the context or from the from what we got from the API, we're gonna do GH project. And as you know, the GH project is a dictionary, and this dictionary would have a key column URL, okay, column URL, okay, and in that way we will be able to assess the specific column from our project, okay. And then let's do expect, and let's just make sure that this was successful. So expect response dot to be okay, which means that our response would return a response 200 of a successful completion of that request. Now let's create another variable called columns, okay. And actually you might ask, why do we need to create this variable, since actually we have our columns in this response right here. So our response variable should already have the columns that we need from our project. Well, we do that because the response is not in a JSON format. So in order to make it in a JSON format, we will need to do response.json, and now we have it. So now this JSON file in a very readable form contains our current columns. Then let's do assert. Length of the columns should be less or equal to 2. Okay, and then let's return columns. Okay, so you can see that now we don't have any more errors here. This function is basically returning the columns from our project, so we have them. And the final thing that I will do is I'll get the IDs from those columns. Okay, so every column would have a specific ID or a name, and we'll need to get this ID. And for this, we'll create our final fixture for that conf.test py file. So let's do Pytest fixture, okay, and here I will do def project column IDs, and here we will pass project columns, which as you already know is a list of dictionaries, okay, and it will return a list of strings, okay, since the ID is a string, and here we're going to get some IDs. This is going to be list of strings. So here we will return a list of, and here I'm going to use the map class, which is going to create a map from an iterator. Actually, we can see what this function is doing. So here you're passing an iterator function, okay, a function in iterables, and it basically generates a map from those computed objects. So here we're going to pass a lambda expression, so x for x ID, okay, so here we're going to get every ID for every project column, okay, and so this last fixture will return the full column data. So since in order to get the column data we actually only need the column ID, this is why we're making this function simple. And so the project column ID uses the map function to get the list of IDs from the list of columns. So actually we could get this map in one fixture instead of two, but sometimes it is better to have them in two different fixtures because they represent completely separate concepts. So while the test that we're creating is going to require the column IDs, some tests might not require that, so I don't want to tie the ID creation with getting the project columns. So let's go up to our other fixtures and just summarize what they're doing. So in the project columns fixture, we're assuming that columns could change during testing, so each test should get and fetch the current column list, right? Since in one test we might create columns, but in the other one we will start with more columns than before. We want to always firstly get the column data. So this function, as you can see, uses the GitHub context fixture to make the requests, and also uses the GitHub project to get the project data. So the GitHub project data includes the full list of URLs that are related to the columns. So from there we can get the column URL. And here we're making the get request to that specific URL, and then we verify that we have at least two columns before returning the column data to the user. Now, as I said, this function is using the GitHub project, which we marked as a session scope because we want to be in the current project that we use while executing all the test cases, right? With the project columns, we might want to use this fixture for every test, but for the GitHub project fixture, we would like to assess the project and to not get out of it while executing our test cases. So this will be immutable during the test execution. So here, as you can see, we're using the GitHub context, which was our previous fixture, to build the requests and the authentication, and we use the GitHub username and the project name fixtures to find the user and the project. So in order to get the list of our projects, here, as you can see, we're using the get request to the user's username projects in order to get those projects. And finally, we're checking if this request has been successful. So the resulting response will contain the list of all of our projects. Then we're filtering those projects to find a project with the targeted project name that we defined already. Pretty simple. And finally, we return that project. And then in the GitHub context is also a fixture that is shared between all the tests. We're using here the Playright fixture in order to create a new context object, which we already explained what it means. And we're using the GitHub token in order to get user personal access token and access the API. Then we use the two API headers that are accept and the authentication header. And the accept is used for the proper JSON formatting, while authentication is used in order to get our token. So then we're creating an API context with Playwright request new context using our headers and the API GitHub domain. So using that, you can see that the rest of the fixtures are actually calling the GitHub context function to build GitHub API requests, and all requests created using the GitHub context function will contain the URL of those headers by default. So this was our conftest.py file, guys, and we use this file for us to create our GitHub test cases. Of course, errors are possible, and it's possible while testing to find some errors in those functions and fix them. But that is part of every programming project. So thanks for watching this video, and in the next one, we'll start writing our test cases. Hi everyone, and welcome back to the course. In this video, we will create our first test case called create project card, in which we will create project cards using Pytest, Playwright, and our GitHub authentication setup. So let's move to our test GitHub project. Let's go back to the conftest.py file, and I noticed that we did some mistakes here. So first of all, this column that is called column URL, it's actually columns URL, and also into the headers here write authorization instead of authentication, because this is the field where our token needs to be. So let's do authorization. Okay, that sounds good. Now let's create our first. So here in this test, I will not only show you how you can create a new project card, but also we will have our logs collected in a particular file, so you can see what is going to get printed or what our functions are returning when we execute them. So this is going to be very useful for you in order to learn. Now let's create a new function here, and let's do def test underscore create underscore project card. And so here we're going to pass the GitHub context fixture, which is of a type API request context, and of course we'll need to import that from the sync API. And after that, let's add the project column IDs, which, as I said, is a list of strings. Okay, and this function will actually return nothing. What the goal of this function is to basically create a new card into our project, and I will show you. So here we are in our project, and you can see that actually those tasks here are automatically generated, so I'll remove them. Okay, so you can see that we have all of our fields empty, and the idea of this test is to create a new to-do task in this column automatically. So this is why here we're returning nothing, because this function is simply creating this test. So let's think of what would we want to be the name of our card. Well, I think it is quite feasible right now to create the name equal to the current time, so we know that this card has been created right now. So let's create a new variable called now, and to get the time, I will do time.time. Then let's do card name, and this will be equal to f a new task at now, and then we'll display the time. Okay, so this is the idea. Now, how do we pass this name to the card? Firstly, we need to create a new card. So let's do c underscore response equals to GitHub context dot post, okay, and we're using the post context in order to post or create our card. And to do that, firstly, we will need to access the cards field right here from the API, and we can use the project column IDs, right? So the project column IDs will basically give us the IDs of every column. And so you can access it in the following way. You can do projects slash columns slash, and then you need the ID of the specific card. So you can do simply project column IDs at position 0, okay, slash cards, okay. And then once we have that, then we can specify the data or how our card is going to get called. So let's do data equals to, and so this field is called node, and then I write here card name, okay. So this is how our card is going to be called, and pretty much this data here is predefined into the GitHub API, and this is the way we can modify the fields. But in order, guys, for you to see a little bit more information, because I know that you would request that, let's actually do something. I will create a log file. So this is pretty simple, and I will do that above the C response. So after that, we can actually log all the information and all the files that we're creating. So I will do logs equals to open, and you can use the open function to actually create a file and write inside. So let's name the file log.txt, okay, and the function to it is going to be W for write, okay. So now we have this logs file, and every time we want to add something inside, we can do it. Now, for example, here, what I want to do is, firstly, I want to add the column IDs. So I will do logs dot write, and here we'll write this as a string in order to be able to place in a file. And here I write project column IDs. Okay, so this will basically give us all the IDs of every column. And let's before that simply place empty line. Okay, so you can simply do that. And also into this file, let's actually copy and paste that. Let's see what is going to be our node. So let's actually firstly in this row, so we know that we want to display the column IDs, I will do column IDs, okay, and then we'll display the column IDs here. And then on the next line, let's for example display the node that we generate, just to make sure that we generated the right node. So I will do here n, and then I will do c underscore response dot JSON, and I will use the field node. Okay, so this should display exactly the node that we are passing. Okay, so here we're logging, so I will just write here logging. Okay, and then we can continue. Now, so once we got our response, obviously we want to check if our post response is completed correctly. So you can do expect, okay, and I will import that name from the sync API, and let's do here c response dot to be okay, and then after that I will do an assertion. So let's do assert c underscore response dot JSON, and then let's do node here to be equal to the card name. Okay, so card name, and obviously what we want is the card name that we send to our response here to be exactly the same as the one that we receive, as the one of the card created. So now guys, our card should be created. Okay, so in this C response is basically the creation response of our card. And let's run our file and see if a card is actually going to be created. So I will create two windows here, right? So one is going to be this one, while the other one is going to be our GitHub project. So let's run our test case. So let's do pytest test GitHub project py headed slow-mo 1 second, and let's see if we will be able to create our card. So let's run that, and you can see that the test is running, and after a few seconds our new card is created with the time of the creation. It is in a little bit weird format, I mean the time, but it's exactly what we were expecting. So not only this, but also you can see that we have our log.txt file here. So obviously our card is created, so the test is successful. And let's see what's in the log file. So you can see few things. Firstly, we have here the column IDs, which are those, right? And as you can see, this is in a list, and every column here that is to do, in progress, or done has different ID. So this is the IDs that we're actually using in order to assess the different columns, right? So what we actually did was we assessed the columns, we took their IDs in a list, and we took the first element, which in Python the first element you stated with 0. Okay, and then we created a card with this post request here. So it is a very good programming practice after you create something with whatever tool you use to check if it's successfully created. So far we simply checked that we created a variable with certain name, and this name is the same as the one that we sent it for creation of a new card. However, we didn't retrieve the card. So in order to do that, here I will actually retrieve the card. So let's create, actually I will write here, retrieve card. So the goal here is to retrieve the card number and compare it with the one we send it to create that card. So let's do card underscore ID would be equal to C underscore response and dot JSON, and then we will take the ID parameter from here. Okay, and if you're interested what is in the C response, let's add it into our log file. So I will do here logs dot write /n, and here I will add the C response dot JSON. Okay, and let's name that as well C response. So I will do created response. Okay, and this line will basically add the response JSON data into our log file. And after that, let's create a new file called R response. Okay, or this would be our retrieved response. So obviously here we go to the ID of our cards. So in the retrieved response, we will do gh-context dot get and then f / projects / columns / cards / card ID. Okay, and from here we will get actually the card ID of the card that we created. And let's also add this into our log file. So let's do logs, right? And this will be our retrieved response, and this will be our response in a JSON format. Okay, also in both of those, let's write their strings. So let's transfer from JSON to string. So let's do str. Okay, so they can be actually printed into our file. And after that, let's check, of course, if our retrieving response is being successful. So expect retrieve response to be okay. And then we're going to compare the R underscore R response dot JSON to be exactly the same as C underscore response dot JSON. Obviously, the response of the created card should be the same as the response of the retrieved card. So let's run this test and see if we will get any errors in those assertions here. So let's run that, and you can see that after some time our test is passed, and you see that also we're having a second card that has been created right here, and the test passed because the retrieved card was actually the same as the created. Let's look now at our updated log file, and you can see that in this file we have the created response and the retrieved response, and even visually those look exactly in the same way. So here is the ID which we actually used for finding the retrieved card, and this is the node ID, the node name, You can see also the creator and many other information about the user and the card that have been created. So guys, this was everything about this specific test for creating a card. As a conclusion, I would say that in this video you learned two very important things, and this is how to use your fixtures to create a card and also to check that the thing that you created and testing actually works. And the second most important outcome of this video was how you can create a really efficient log file for you to get all the data that you need while troubleshooting your test cases. That's it. Thank you very much for watching, and I will see you in our next video. Hi everyone, and welcome back to the course. In this video, we'll create another test case which will help you to move a project card in GitHub. You're going to learn amazing things today, so let's get started with our test case, which obviously is going to be more complicated comparing to the previous one. But I hope you're already expert, so let's start coding. Now, I'll create here a new test case under the create project card, and this test will be test underscore move card, okay? And here we'll need to pass a little more parameters for this test case to work. So firstly, I will pass the GitHub context, which is common for both test cases. And this is the API request context with which we actually create our browser and the actions that happen inside. Then we will pass the GitHub project, okay, which is a dictionary. Then we will pass the project column IDs, which is a list of strings, okay. Then we will have page, which will help us to actually visualize our page, okay. Then we will do GitHub user, okay. Let's do here str and GitHub password. So you will be able to see how we log into our account and basically how we create and delete and actually move cards from there. Okay, so here we will do the complete process for logging into the GitHub, assessing our projects, creating and deleting, actually moving a card. So, okay, once we selected all the things for this project that we need to use, the first thing that we need to create is some preparation data. So getting the specific ID of the column that we need to use, creating a log file, those sort of things. So first let's create a log file and let's call it logs equals to open log.txt and then write. Okay, so now this will be our log file, so actually it will be updated from the previous test, and I will actually name it log2 in order to have the logs from the different tests in different files. Then let's create the source column, or the column from which we're going to take our tasks. So let's do source column will be equal to project column IDs at 0. And if we check our previous log file, you can see that the column IDs are represented by the following. The first ID represents the to-do column. The second one represents the in progress column, as you can see here. So since we want to move from to-do to in progress, the source column will be to-do, and the destination column, or dist column, will be project column IDs at position 1. Okay. Then let's create our time. So let's do now equals to time. Then we're going to again create the new task. Okay, so in this test we're going to do step 1 from the previous video, but at the same time we will also move that task. So we can do here card name would be equal to f, and let's name this card as move this card at, and I will do the now here, so we'll show the time on this card, and in that way you will be able to distinguish between a new task and move this card. Okay, so the tasks will be named differently for the different test cases. So firstly, let's create the cart, and this will be something that you're already familiar with. So let's do c underscore response will be equal to gh context dot post, and again we're going to create this cart into our cart stub and pass the name. So let's do projects slash columns slash, and then let's do source column. Okay, so this will be creating the first column slash cards. Okay, and here the data would be the actual name, so what we will pass is node, and this will be the card name. So here you see that I referred to node, but also you can see that there are other fields that you can also update, such as id, node id, and many more. Okay, so here I'm simply referring to the field node and I update the information there in the API. Pretty simple. Okay, let me move this bracket here, and after we're done, let's check that we received the correct response. So let's do expect c underscore response is to be okay, and then let's do page, and here we'll go first to github.com login. So let's do page, go to https github.com/login, and then let's add our login information. So we're gonna do page dot locator, and we're gonna find the login field by id. So id would be equal to login underscore field dot fill, and here we're going to use the GitHub username function. Okay, so this is how we will pass the username. Then we will do the same into the password field. So let's do page dot locator id equals password dot fill, and here we will fill with the password, so GitHub password that we already added into our virtual environment. If you have errors related to the username and password, please make sure that you actually added them into your virtual environment, especially if you're doing those videos, or if you're watching those videos in different days. Some of the virtual environments or virtual variables might not be there anymore, so definitely make sure that you check that. And finally, let's click the submit button. So let's do page dot locator input, and then name equals commit. Okay, and let's close the parentheses, and this is how we refer to the submit button into the login page, and then let's click it. Okay, so far what we've done is we created a new card, and we also logged in into our GitHub account. Now the next step is to load our project page. So let's do page dot go to, and here we will go to our project page. So this will be https github.com/users/gh user. Okay, so you're going to your user page, then projects, then gh project. Okay, and remember that your GitHub project function actually returns a dictionary, and in this dictionary you have information about the project. One of the fields there is called number. Okay, and this is your project number. So I will use this field in order to get a project number and be able to pass it to the URL. Okay, and actually I want to show you the project data. So I will actually write it into our logs file. So let's do logs dot write, and here we'll make sure that this is on a new line. So /n plus, and let's write here project data. Okay, and here I will do gh project. Okay, and I will pass this as a string, of course. Okay, so we'll be able to see all the project data in our log file. Okay, so once we made sure that we're on the right page, let's verify that the card actually appears on the first column. So let's do card column. This would be equal, and here we'll need to find the ID of the particular card. So we can do that by inspecting the page. So let's say if we have cards that are already created. Let's do inspect. And so when I start searching here, you can see that the different cards are right here, okay, that are into this column. So the first one is with ID co-cards, and this is the ID right here. So we can pretty much search by this ID, okay? So the ID that you can see right here is the actual ID of the column that the card is in. So we can check if this column contains our card name, okay? So this should be pretty simple. So let's copy the ID that we found right here. So I will copy the whole thing, okay? And then I will go back, and so the card column would be equal to f//div, because this was a div, and then let's do add id equals to column cards. And here, since I want this to be the same as the current id of my column, I will pretty much pass the source column, okay, because the source column should have the id that we need, okay, because we look for our newly created card to be into our source column because we didn't move it yet, okay? So let's close this bracket, and then let's do //p contains, and here we can specify the text, okay? And the text will be our card name, okay? So let's do card name, okay? And we can close the two parentheses. And I will also place on the next line, so it's more presentable. You of course don't need to do that, but I want to keep it within the visible area right here. So here is how we verify that the card is in the first column with the XPath variable, and then we're simply going to check. So expect page dot locator card column is visible. So let's do to be visible. Okay, so pretty much this is the locator of the card, right? So here we're locating the card, and we make sure that this is visible for the user. Okay, so this is how we find the card. So this is what we use for our locator, and then we make sure that this one is visible. So now after this line is passed, we made sure that our card is visible, and since that's confirmed, now we can move it. So let's do page dot, and you can do here drag and drop. Okay, so this is some function that we haven't talked about before, but this is pretty much used to get an element and put it somewhere else. Okay, so for example, if I want to automate how I get this element and I put it into another column, this can be automated, and you can do this with the drag and drop function. So how it works? What do we need to pass? So what we need to pass is firstly a reference to the card. So we will find the card by text. So let's do text equals to card name. Okay. So actually, if I hover over it, you'll see that we're passing the source and the target. So our source is our card, and here's how we will locate it. And then our destination is a destination column. So we can find this column by ID. So let's do ID column dash cards dash, and here is going to be our destination column. Okay, that's it. So this should move our card to the destination column, and then we'll basically do the same thing. So we will pretty much check if our card is now into the destination column. So I will copy those two lines, I will paste them here, and the only thing that I will need to change is here, instead of source column, I will do destination column. So pretty much I will check if a card with our card name exists in the destination column. And honestly, you don't need to change the name of this file. It's pretty much going to get updated and then checked again, and you will not need the previous variable. So that is completely fine. So we don't create a new variable. And finally, we can check that our backend is also updated. So now into the API, the card has different column ID. So you can do that by writing card underscore ID equals to see underscore response dot JSON and then ID. Okay, and then let's do the retrieved response. So R response equals to gh context dot get and then f slash projects slash columns slash cards slash card ID, and then let's do expect R underscore response to be okay. And finally, let's do an assertion. So assert R underscore response dot JSON, and then let's do column underscore URL dot ends with, and we want to make sure that this ends with the destination column. Okay, so let's save that. Okay, so let's save that, and let's run our test case and see what happens. So I'll run it, and here you can see we go to github.com, we write our username and password, then we go to the tab and we move a ticket to another column, and then you can see that our test is passed. So if I go here, you can see that we actually have a move card that you saw that it was created in the to do column, and it was moved to the in progress column. So we can verify that the GitHub move functionality works properly, and we did this automatically using Playwright. Also, you can see that you have the log2 txt file, which has all the project data as we set it up. So you can see that, for example, here we actually use a project number in order to go to the project page, and let's see where that number is. So you can see right here the project number is 10, and as you can see we went exactly to number 10, which is the project number. Okay, so this is how, guys, you learned in this video how to pretty much use the JSON data extracted from GitHub related to columns, projects, pages, and so on, and using this data to assess the pages that you need. You also learned how to create and move page with a drag and drop function, and how to check whether our card is moved or not with the toVisible function. So I hope this video was really useful for you and straightforward. Thanks for watching this video and this course, and I will see you in our next coding challenges.